Hey guys, welcome back to the section 7, session number 33. So let's see the knapsack problem using dynamic programming. In the knapsack problem, we have been divided into the two parts like 0 by 1 problem, and even we can solve the knapsack problem using a subsets over that. Then we are going to see the Java program related to the same. So let's begin with the example how a knapsack problem can be solved using a formula, and how we are going to see the specific using and apply the dynamic programming concept to it. So let's begin with an example. So coming back to my drawing pad. So here I have created one profits and weights into the table over here. So if you see here, we have a profits that is 0, 1, 2, 3 is the profits over here. And we have a weights that is 2, 3, 4, 5 over here. And we have m value and we have the n value is equals to 4 over here. So what is meant by the m here? So m is going to be the capacity of the bag. So we are having one specific capacity of bag that is been declared with the m. So we can use only the maximum capacity that is going to be 8. So inside the maximum 8 capacity, I need to select such a profitable items so that all the specific bag will be filled, the maximum capacity will be filled, and the profit should be high, over here. So P denotes here the profit over here. So I need to select such a profit, and I need to select such a profit so that I can add into the specific capacity of my bag so that m value becomes 8 and I should get the maximum capacity over there. So there can be n value here. So n is equals to 4. We are having a 4 items here. So what all the probability of 4 will be there. So it will be a 4 cross 4 probability basically, right? So it can be like 0, 0, 0. I can select 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1. So 1, 1, 1, 1. So like this I can select it, right? So there can be a 4 power 2 power 4 probability, basically 2 power 4 probability, so that I can get a different permutations and combination to select the specific weights and the profits. But make sure that your capacity of the bag value is only 8. You can only fill up to the 8 capacity itself. Okay, so we have a weight here 8. So that is how the specific problem is. So when we are going to solve this specific problem using an knapsack that is 0 by 1. So here P, let's try to create here as a P is going to denote as a profit, and it is going to be denoted as your weights over there. Let me tell here as a P, and it is going to be your weights. I'm going to write it into a table that is a 1, 2 and a 5, and I'm going to make it as a 6, and the relatively respectively the weights is 2, 3, 4, and the 5 is going to be the weights over there. So I'm going to write the specific 0, 1, 2, 3, 4 over here, and maximum capacity of your weight will be 8, right? So I'm going to make it as the first 0. So 1, 2, 3, 4, and I'm going to make it 5, 6, 7, 8. I'm going to give the indexing position for it. Okay, so now first I need to fill the starting for 0. Let's fill everything with 0. So I'm going to mention as 0, 0, 0, 0, 0, 0, and a 0 over there. Okay, so now I'm just going to select the first specific profit over there. So I'm going to just select the specific profit, that is I'm going to select that is 1 and 2 over here. So I'm just going to select the specific profit that is only 1 and a 2, and I'm just going to fill out the specific table using certain formula over there. So we have some certain formula to be noted down. So that formula I'll tell you for the next iteration. So let's understand in a simple way how we can going to fill the specific keep on filling the bags over there. Okay. So now I'm going to tell here. So basically this denotes your specific 1, 2, 3, 4 is going to denote the n cross 8 matrix, right? So I can have a 8 weights over there, right? So whatever the 8 right hand I have created, this is basically your weights, whatever I have created the table over here. So imagine now I'm going to select that is 1 of 1 over here. So I'm just going to select the specific 1, and I'm just going to specifically select the specific 1 cross 1. So how the value I am going to fill? So that's we are going to see now. So first there are some certain points I need to tell over here. I'm going to tell here as a first I need to select the first weight. Select the specific, that is the first weight. What is the weight? First weight we have having that is a 2, right? I need to just select it as this first weight, that is going to be 2 over here. So for the weight 2, so for the specific weight 2, I'm going to tell, like let's select the second weight. When we select second, we need to select this specifically, basically how we are going to fill, right? First I'm going to see these two data. Then when I come to this point, I'm going to look onto the top value as well. When I look onto the 5, 4, then I'm going to look onto the 2, 3, 1, 2 as well. When I come on to the 6, 5, then I'm going to look onto the all the selected tabs over. So right now I'm just selecting 1, 2, 2, 1 and 2 over here. So now I wanted to specifically select the specific weight that is 1 over here. So in this specifically weight, if I just select a weight 1, suppose imagine if I just select the specific weight 1, what is going to be your profit over here? So obviously the profit for the specific 1, we don't have a specific profit for the weight 1, right? So first initially I'm just going to make it as a 0 over here. So imagine next condition. Now I'm just selecting the specific weight that is 2. So if I select the weight 2, so what is the profit we have? We have a profit that is 1 here, right? So I'm just going to mention here as a 1. So when I select the weight 3, so if I just select the specific weight 3, I cannot select the weight 3 because right now we are only selecting the specific weight 2 itself. If I imagine, I can, if there is a specifically, imagine we are having specific 1, 2 and 3. So we are having a 3 seats here, right? Inside a 3 seat, if I try to put the 2 seats whichever I already have, I can select, right? This I can select these 2 seats, right? That is possible, right? This is possible. That is why I am just telling. So when there are a weight is equals to 3, in this 3 seats I can accommodate at least 2 seats, that's fine. So at least I can accommodate 2 seats, right? Yes, I am going to tell, okay, in this specific 3 weight I am accommodating the 2 seats, that's fine. And what is going to be the profit? The profit is going to be 1 itself, right? Because only 2 seats we can take up, and we can just add the only profit of up to 1. So we are out of 8 weight, I am only selecting 2 weights. So in this while selecting a 2 weights, I can have a only profit of 1. So in that case, for all the 8, whenever I go to the 4, if there are 4 seats, I am accommodating 2 seats, I can have a only profit that is a maximum profit 1, and 5 also 1, this is also 1, this is also 1, and this is also 1. It is going to be similar to it over there. Okay, so this is how the first row has been filled. So because only we are selecting 1 and 2 weight here. Now next, let's take another example now. So now I'm just going to select this entire weight now. So I'm just going to select this specific entire weight. So now I can accommodate up to 2 plus 3. I can accommodate, that is a 2 plus 3, up to 5 I can accommodate. Okay. And for the 5, and we have a profit, right? For the 2 weight, we have a profit 1. And for the specifically 3 weight, we have a profit that is what? We have a specific profit that is 2, right? So even I can accommodate, when I accommodate both the thing at maximum profit, I can get up to plus 3 here, right? So same way, so for the first condition, if I have a weight here, that is basic, imagine I have a weight 1. So for the weight 1, we don't have any profit. So I'm just going to make it as a 0 over here. So for the weight 2, definitely we have a profit that is 1. So only this is the maximum profit. I'm just going to put it here as a 1. And for the weight 3, what is the profit we are having? The profit we are having 2. So I'm just going to mention here as a 2 here. For the weight 4, so for the weight 4, what can be the maximum profit for the weight 4? So for the weight 4, imagine right now we have not selected the weight 4 area. So in the weight 4, I can put either 3 or I can either put the weight 2, right? So I can put in the weight 4, I can put either 3 or I can put either 2 here. So what I am going to do here is, I am going to select for the weight 4, I am just going to select the maximum profit. For the weight 4, I am going to put 3 seats into it. And what is the maximum profit? That is 2. So I'm going to mention here as a 2 over here. So the weight 5. So for the weight 5, I can put both weight, right? I can make that is 3 plus 2. I can accommodate both the weights here. In the weight number 5, I can accommodate both the weights, that is 3 and 2 as well. So when I accommodate both the seats, I need to take both the values, that is 1 plus 2, that is going to be 3 over here. I can accommodate for the 6. For the 6 weight also, I have a 6 specific 6 weight space. I can add 2 and 3 as well. So even I can add, so what is the maximum profit? That is going to be the 3. Even for the 7 also it will be 3. Even for the 8 also it is going to be 3 over here. So this is how we are going to calculate the specific weights over here. So this is very easy. Whichever we are selecting it, we need to see whether I can accommodate or not. If you are accommodating it, what is the profit of that? Just you need to place it over here. That's it. That is the only simple task here. This is the third iteration. And what is going to be the next scenario? So what is going to be the next scenario over here? So for this, I'm going to select it as a purple color. So I'm going to just select draw the over here. So now I'm just going to accommodate specifically now I'm accommodating 2 plus 3, how much? 2 plus 3 is going to be 5, right? So 5 plus 4, that is going to be 9. So now we are accommodating 9 here. We are accommodating 9 weights here. But the maximum here is 8. So the maximum here is 8, right? I can only accommodate up to 8 itself. So we need to accommodate only up to 8 itself. So basically 9 is greater than 8. I cannot accommodate all the weights here. I need to select such a weight which is giving maximum profits, and only the capacity of the bag can be only 8 itself. I cannot place more than 8 over here. So let's imagine for the specific weight, if I am try to add the weight 1. So for the weight 1, we don't have any profit, so that is going to be 0. So when I add it for the 2, definitely the same thing will be there. For the 2, maximum weight is 1, so I'm going to place it here as a 1. For the 3, the maximum weight is going to be 2, so I'm going to place it as a 2. So for the weight number 4, so if I want to accommodate the weight 4, for the weight 4, so definitely which is going to be there. So for the weight 4, I know it is we can accommodate the 4 value, right? Definitely I can accommodate direct 4th value. So the maximum profit will get it as a 5. I'm just going to place it here as a 5, and I'm going to accommodate the 5 here, the weight 5. So for the specific weight 5, which 2 you are going to select. So imagine for the weight 5, if I try to accommodate the 2 plus 3, 2 plus 3 is going to be 5, right? So 1 plus 2 will be, only maximum profit will be 3. Even though I am selecting these 2 specific weights, and only the maximum profit will be 3. What? In the place of 5, I am going to only accommodate the weight 4. Okay, and the maximum here is 5 I can select. In maximum of 5, I am only selecting 4. In that, I am going to get the maximum profit, that is 5, right? So if I select 2 plus 3, I will be having only 3 as a profit. If I select only 4, I will be getting the profit 5. So 5 is greater than the profit 3. So I'm going to select this specific scenario. So I'm going to mention here as a 5 over here. Now accommodating the 6 now. So now I'm going to accommodate the specific value, that is 6 here. So how we are going to accommodate the 6 here? I'm going to write it properly 5 here. So I'm going to accommodate the 6th weight. So 6, in what way you are going to get the 6 here? So 2 plus 3, I'll be getting 5. 3 only the profit, that is less. If I tell 4 plus 3, it is going to be 7. So I cannot use 7 as a weight, because maximum I can put it as a 6 here itself in the table. So what I'm going to select, I'll search for the next combination. Okay, I can just select 4 plus 2. 4 plus 2 I can select. If I select 4 and 2 as a weight, what is the profit you are going to get? 1 plus 5, that is the 6 over here. So the profit is going to be 6 over here. So for the weight 7, I'm going to select the weight, that is 4 plus 3, that is a weight 7, and we will be getting a maximum profit 5 plus 2, that is 7 I'll be getting. I'm just going to mention it over here. And even for the 8, when I want to select a 8 here, so this is a best case. Again, for the best case, when I select all the weights, if I see, the best scenario is 4 plus 3 itself, so that I can accommodate the 2 plus 5, that is going to be 7 over here. So this is going to be your specific scenario, how we are going to select the specific things over here. So here we are having some kind of a formula, guys, here. So let's try to solve the last row with the formula. So first I wanted to make it as a simple, so that we have given. So let's try to write a formula, and let's understand how and exactly we are solving this specific problem. So we have the specific formula in this way. So like we are going to take the v, the vertex v, that is I comma w. W is going to be weight. So in this specific, I am going to find the max value from the vertex v. I need to traverse I minus 1, and I am going to select the weight over here. So again, I'm just going to tell vertex of I minus 1. Okay, again weight of I plus specifically, that is I'm going to write the formula that can be a p of I. So this is going to be your formula to solve this specific scenario. Right now we are imagining this specific formula into our mind while doing this operation, and I was filling out. Okay, so for the 4th row, let's imagine we are going to use the formula and we are going to fill up this specific scenario over here. First, I am going to fill it for the starting one. So for the weight 1, it will be 0 itself. Again, it will be 1 itself. Here it will be 2 itself. It is not going to change over here. So let's imagine for the 4 now. So for the specific weight number 4. So now I need to do for the weight number 4 over here. So which is going to be the maximum value, and how I will be getting the specific max value, and I am going to store that specific max value into our specific program over here. So in this, take it an element number 4 here, right? Imagine I am going to select this as a 4. If I select a weight 4, which is going to be the maximum here. So when I select a weight 4, the maximum profit will be 5 itself. We have direct here, so I'm going to put it as the direct here over here 5. Now for the weight number 5, for the weight number 5, I can select only 5. Now let's see for the weight number 5 how I can select. So now I'm just selecting, again I'm just going to draw it here. So now I'm just going to select the whole bucket here. So I'm just going to select the whole bucket now. Okay, when I select the whole bucket for the 6, so for the weight number 6, now let's say solve with the formula, we are going to get the maximum profit and we are going to fill it over here. Okay, so in this case I'm going to tell here specifically I'm going to tell here as a max. So now I am going to take the vertex. This is 4 is your vertex, right? I'm going to take the vertex of v. This is going to be a vertex 4. So what is going to be your I value? So for the I value, it is going to be 3, right? So what is the value of I minus 1? So basically I wanted to select, I'm selecting the vertex 4, right? So if I tell a vertex 4, what is the I value is going to be 4. 4 minus 1 is going to be what? 4 minus 1 is going to be, I'm going to write it here, 4 minus 1 comma. What is the weight we have been selected? We have selected the specific weight that is 6. I'm going to sell the weight we are selecting as that is as 6th weight over here. I wanted to search it for the sorry, not 6, I are selecting for the weight number 5. So for this we are searching, right? So for this specific thing we are doing it. So I'm going to tell the weight is maximum 5, I can up to select it. Okay, again I'm going to tell vertex of what is I value. I value is 4. So I'm going to tell 4 minus 1. So what is the weight here? Weight is going to be 5. So I'm going to tell weight is going to be your 5 minus what is the weight of I? What is the weight of going to be, what is going to be 5 of that is what W of I. So what is going to be the W of I over here? So when I talk about 4 minus 1, it is going to be 3 here. So basically weight of I. So we don't have a weight of I for this specific thing that is directly for the 5. So we are going to make it, this is going to be your 0 plus, this is going to be plus. What is the profit? So the maximum profit for the weight 5 we are having, that is 6, right? I'm just going to place it here as a 6 over here. So when I place it here, now I'm going to evaluate to the further. So this I'm going to tell here as a max. So the vertex of 4 minus 1 will be 5, right? For 5 comma 5. So what is going to be for the so it will be 5 comma 5, right? So basically the vertex of 3 comma 5. So if I see in the table, that is for the 3 comma 5, we are having the maximum weight is 5. So I'm going to write it here as a 5. Again I'm just going to tell vertex of, basically we are going to tell vertex of 3 comma specifically here what I was seeing here is, so I wanted to tell vertex or what is going to be this is so vertex weight is basically we have mentioned as a 5 minus, so what is W of 5? So even this is also going to be your thing that is going to be same, that is a 5 itself. So that is going to be 0. Okay, so that is going to be 0 plus 6. So it is going to be 0 plus 6 over here. So in this, when I tell what is going to be, so 3 and 6. So which is going to be here? So basically 3 and 6 we are having it, right? So in this specifically 3 and 6, so vertex of 3 comma 0 and sorry, I need to tell like this. So vertex of 3 comma 0, vertex of 3 comma 0 is going to be 0 itself, and we are having a maximum that is 6. So in this 5 and 6, which is going to be in the maximum, the 5 is going to be the maximum. So I'm just going to fill out that is going to be 5 over here. Okay, so for the vertex 5, so sorry, in the specific wrong. So for the 5 and 6, we are having the maximum that is 6, right? Not 5. So I'm going to place this is going to be 6 over here. Okay, so this is how the things is going to be there. So now let's see for the next element, that is a vertex, that is a 4 comma. So now we are going to see 4 comma 6 over here. So again I am going to say, if you have not understood this specific part, so now we'll get clarity inside the next part over there. Okay, so let me erase this thing. I'm going to erase this specific thing and I'm going to write it neatly over here. Okay, so don't worry if you have having any doubts with this specific formula. So let's try to do it for the neatly here. So I'm going to do it for the vertex, that is 4 comma 6 over here. So I'm just going to do it for the vertex, that is 4 comma 6. Inside that I'm just going to make it as the max value I need to find. So in this vertex v of I minus 1, that is 4 minus 1 is going to be 3. So what is the weight we are selecting? So the maximum weight we are going to select it as the specific 6. Again for the vertex we have a I minus 1. So I minus 1 will be same, that is whatever you will be having here. So same thing even here it will be having it, again comma. So we have W minus W of I over here. So right, so we have W minus W of Y. So what is the specific profit we are having the for the weight? So we have selected the specific 6 right here. So we are just selected the specific weight as a 6. So 6 is going to be taken over here. And what is going to be your specific profit for the maximum value if you have taken as a 6 over here? So if I take it as a maximum value for this 6, so it is going to be specifically I'm going to get it as the 5. So then plus what is the profit of I? So what is the profit for the specific 6? So for the 6 we don't have direct a 6, so we can take it as a 5, and whatever the for the 5 what is the profit, that is we are having a 6. So I'm going to calculate it over here as a 6 over here. So in this if I just try to find what is the maximum, so we are going to get it as a 6 itself. So 3 comma 6 you can find it. So 3 comma 6 will be 6 itself. Okay, and vertex of even if you evaluate this thing and if you do it, so it is going to be like this. If you will be getting 6 comma 6 inside this, the maximum value is going to be 6 itself. I'm just going to update the value, that is 6 over here. Here also we will be getting a 6 over here. Now next, so we are going to see for the vertex 4 comma 7 now. I'm going to find the 4 comma 7. Even you can do it directly, but actual problem solving is going to come from the formula. But previously we were assuming it from the mind and we were solving it. You can do any of your way, but latest the output should be correct, right? So whatever the thought we have seen in that behind the scenes, this is the specific formula that is getting calculated. Okay, this is what the formula which we are going to calculate it behind the scenes, and we are going to fill out the specific table here. Now again I'm just going to tell it as a 4 comma specifically I'm just going to select what is going to be 4 comma 7 now. So again I'm just going to evaluate with the formula. So I'm going to tell 4. So basically when I tell about a vertex here, so I'm going to tell is a vertex. So for 4 comma 7, 4 minus 1 will be 3. And what is going to be your weight? So for the specific number 3, so the weight is going to be, the maximum weight is going to be for the specific 7. If we are 7, I can fill at least 5 into it, so that weight profit will be 6 here. So I'm going to tell here as a 3 comma 3 comma 7, right? So okay, so I am setting for the specific weight that is 7, right? Now I'm searching for the weight that is 7 over here. So I'm going to tell 3 comma 7. Then vertex of, so 3 whatever will be there here, it will be same again for the next iteration. So whatever you are seeing, so it will be same as it is, you need to minus with the specific weight now. So for the specific 7 I can do what? So for the specific 7, what is going to be the specific weight now? So for the weight, it is going to be W of Y is going to be, that is 5. And again from the specifically 6 is going to be as it is, because profit is maximum profit from the when I am selecting the weight number 7. So maximum profit I can put it, that is 6 itself. So it is going to be a 6 over here. And if I evaluate this, I'll be getting as a 7 over here. So this 7 I'm going to fill it over here. So again for the vertex of, that is 4 comma 8. So I'm just going to find again the maximum of, so I'm going to simply evaluate, that is a vertex of 3 comma 8, again vertex of 3 of 8 minus 5 and plus 6. So this is going to be there. So if I just tell here as a maximum of, if I tell as a vertex, that is a 3 of 8. So if I see 3 of 8 is maximum we are having, that is a 7 comma. So if I evaluate, that is a vertex of 3 minus 8 minus 5 is what? 3. So 3 to 3 is how much? 3 to 3 is 0, right? So that is going to be okay, so 8 minus 5, right? So if I just tell here as a vertex of 3 minus things, it is going to be what? It is going to be 2. And if I just tell evaluate to 6, so 2 plus 6 will be 8, 8 and 7. So maximum is going to be 8. So I'm just going to select it, the vertex 8 over here. Okay, so this is how we are going to fill out the specific table now. So now after finding this, now we need to find what is the specific naps, 0 by 1, right? So I need to just tell what is going to be 0 by 1 over here. So I'm just going to tell, if I select the 8 here, so the maximum profit we can get up to 8 here, right? Even though if they are a weight m is equals to 8, I can fill the maximum weight up to 8 over here. So which all the weights you are going to select, so that your weight is going to be 8 over here. So if I just select here according to this specific scenario, I'm just going to select here as a 3, and I'm just going to select it here as the specific weight number 5. So if I select the weight 3 and 5, I can fill 8 maximum value, and the output 2 plus 6 is going to be 8. That is what we are getting it. So we got a 8, right? So calculate for which you can get the maximum weight. I can do 1, 2, 5. So 1, 2, 5 means 3 plus 5, it is going to be 8. So if I tell here as a weight 2 plus 3, 5, 5 plus 4, 9 it will cross. I cannot put 9. There is a maximum weight, that is only 8. So the next scenario, 2 plus 6 if I add, so that is going to be 8, and 3, 5 plus 3 also 8. So the output of overall here it is going to be, so I'm not going to select the weight number 2, I'm going to select the weight number 3, that is 1. Again I'm not going to select a weight number 4, that is going to be 0. Now I'm going to select the weight number 5, that is going to be 5. So it is, the output is going to be specifically 0 1 0 1. This is going to be the knapsack problem, that is 0 by 1, that we are going to get 0 1 0 1 is the best specific case for solving the specific items over there. Okay, so this is how the things is going to be there. I hope you got it, and if you want to choose the formula method, you can choose and solve, or I'll directly simply how the starting 3 rows we filled, right? That was a very easy task. So using that you can find the specific maximum weight over there. So in the next session we are going to still look on to the subset of problem. So we'll see how the subset of problems can be used, the same problem to solve using a subset. Take care, bye bye. Hey guys, welcome back to the session number 33.2, that 0 by 1 knapsack problem using subset now. So we saw previously how the knapsack problem can be used using a specific matrix method like this by 0 by 1 method. Now we are going to see same problem, we are going to use a different formula to solve it. So using a subsets over here. So here we are going to use the concepts of subsets. So let's begin with the example part over here. So then we'll move on to the coding part of it. So coming back to the specific scenario, like I have created a 0 by 1, that is a subset of problems over here. So I'm going to take the same profits over here. So I'm just going to take the specific same profit, that is P is equals to the profits we had, that is a 1, we had 2, we had 5, and we had specifically a 6, right? Again, we had the specific weights, that is a 2, 3, 4, 5 over here. So even here, I'm just going to tell the M value can be the maximum capacity of the bag is 8. And here, you should be knowing one thing. So always your profit and weight should be keep on, if the profit is increasing, if the weight is increasing, your profit also has to get increased. Okay, if the specific weight is increasing and your profit is getting if your weight is increasing, imagine your weight is getting increased and your profit P is getting decreased, then here we need to discard it. So we need to discard the previous element over here. This is the specific formula which we are going to use, and we are going to solve this specific problem over there. So let's try to solve. So let's tell here as a S of 0, that is going to be for the specifically for the beginning time, it is going to be 0 itself. I'm just going to tell it is going to be 0, 0 of S of 0 over here. Again, I'm just going to mention here as a S of n 1 of 0 over here. So here I'm just going to select the two specific weights over here. So I'm just going to select the weight that is a 1, 2 over here. Okay, so I'm going to just select it here. That is, I'm going to just select it as a 1, 2 over here. So in 1, 2, imagine how it is going to be there. So in the S of 0, I'm just going to select it, that is 1, 2 over here. So I'm just going to select this one. So now what I need to do here is, so first S of 0, and this is the one thing, right? So for this specifically two things, I wanted to add. So I'm just going to add, and after adding, I wanted to merge it over here. So I wanted to merge it over here. So after add, and if I try to merge it, so it will be like S of 1 is going to be, so I'm going to tell 0, 0. So I'm going to tell it as a 0, 0. First 0, 0 will be there. Okay. Comma. Again, I'm just going to tell 1, 2. So here I have merged it. Okay. So I have just merged it, the specific scenario over here. So it has been added and it has been merged over here. Okay. So it has been merged now. Now what we are going to do here is, so this is going to be the first case over there. So in the first case, it is going to be. So now again, I'm just going to select the S of 1 and done. So I'm just going to select a different color. So let me select S of 1 and I'm going to select the new vertex over here. So already we are going to add this one. So basically I'm just going to add and I'm just going to keep it over here. So imagine now I'm just going to select it, that is a 2, 3 over here. So I'm just going to add with this element here. I'll just tell here as a plus 2, plus 3, plus 2 and plus 3. So 2 plus 0 is 2, 3 and 2 plus 1 is going to be what? 2 plus 1 is going to be 3 and 3 plus 2 is going to be 5, right? So I'm going to tell 3 plus 2 is going to be 5. So this is going to be the first thing. So once I do this, again, I need to simply merge these things. So I'm just going to tell I need to merge this specific two things. I'm going to tell S2 is going to be, so obviously the 0, 0 will be there as it is. Again 1, 2 will be there as it is. So after that, with this new things is 2, 3 and we'll be having a 3, 5. So this is all the three things we got it. So just here the concept here is add plus merge over here. So here you see this is going to be your profit, this is going to be your weight. See, profit is getting increased, even your 3, 5 weight is also getting increases. This is getting satisfied here, right? So now let's imagine the next case here. So the next, I'm just going to take another new elements here. So I'm just going to take, so I'm going to tell 5, 4 over here now. So I'm going to mention here into the specific thing. So we have this, right? So now I'm going to tell here as a S2 of 1 dash is equals to, now I'm just going to add, that is 5, 4 here. So I'm just going to add this specific element, that is 5, 4 to it. So now after adding this specific 5, 4, so after adding a specific 5, 4, so how it is going to be there? So after adding a 5, 4, I'm just going to merge it again here. So I'll let little bit scroll it here. So I'm just going to merge these things. So after merging it, so here it will be as it is here. So I need to add it with plus 5, plus 4, plus 5, plus 4, again plus 5, plus 4, plus 5 and plus 4. So after adding it, what all the element I got? So I'm going to tell this is going to be your S3. Previously we got S2. So I'm going to tell we got something like that is 5, 4, right? Comma again 6, 4 plus 2 is going to be 6, 6 we got, right? Again the element 5 plus 2 is 7, 7, 4 plus 3 is 7, right? So we got something like a 7 comma 7, and again we got 5 plus 3, that is 8, 8 comma 5 plus 4, that is going to be 9. So we got this specific element 9 over here. So we got this many S3 over here, right? So this is how the things is going to be there. So after merging it, so we got this specific element over, that is a H3 of dash over there. So now what I need to do, so for the next thing I wanted to add, I need to put it the next elements here, right? So I wanted to put the next specific elements as well next. So for that, now I'm just going to do what? So for the next thing, I need to add the element. So first let's try to add the element, that is a S3 of dash, that is going to be. So I'm just going to select a different color. I'll just select it as a black color itself now. For the black color, now I'm just going to add, that is 6 comma 5 also. When I add a 6 comma 5 here, so I'm just going to tell here as a, I'm going to add the element, that is 6 comma 5. So after adding it, that is a 6 comma 5. So first let's try to merge it over here. So after adding, I'm just going to add it here. So I'll just add it here. So let's tell S3 is equals to going to be, so all the previously we had, that is 0 comma 0 will be there. Okay, so for basically after adding we got it, that is okay. So after adding this, so we got an S3, right? So after adding this, we need to add the first element which we had from beginning, that is 0 comma 0 we had, and what is that, 1 comma 2 we had. Okay, again what we had, that is a 2 comma 3 we had, then we had 3 comma 5 we had. Then after that we got, that is an element, that is a 5 comma 4 we had, and again 6 comma 6 we had, and again 7 comma 7 we had, again we had 8 comma 9 we had, right? So this is going to be your final specific capacity here. So in this case, now what we are going to do here is, so this is what we got it, right? After adding this, we got this one. So before merging it, now let's try to see the profit is getting increased and weight is also getting increased or not. Here 0, 1, 2, so you can see here the profit is getting increased, weight is getting in 3, 5, 4. So here you see the profit is getting, here you can see it is getting increased. Here also it is getting increased. Here the profit is increased, and here so the 5 is your profit, here increased. Again your weight is getting increased. Here you can see the profit is getting decreased. So here the profit is getting decreased over here. So whenever it is getting decreased, we need to discard the previous element. So I'm just going to discard this specific element here again. So when I come back here, you can see the profit we are getting here as a 9. Again 6, so it is increasing, 7 is increasing. Here for the specific weight 8, the profit is getting as a 9 here, right? So I cannot accommodate the 9 element here. So because W value is, I can up to accommodate up to 8. So W is getting 9. So what we are going to do, we are just going to discard this specific element also. So we are going to just discard this specific element as well. So after discarding it here, so what is the final element we'll be getting it? Then the S3 will be getting the final element, that is now after discarding it, so we got, that is 0 comma 0, and we got 1 comma 2, and we got 2 comma 3, and we got 5 comma 4, then we got 6 comma 6, then we got 7 comma 7. So this is the basic things over here. So after adding the S3 of 6 comma 5, so now we have added it. So after added, we checked whether which is the profit is getting decreased or increased. So for the 6 comma 5, now we need to add it over here. So I'm going to tell here as a plus 6. Again I'll just tell as a plus 5, plus 6, plus 5, plus 6, plus 5, again plus 6 and plus 5 here, plus 6 and plus 5 here, again plus 6 and plus 5 over here. So after adding it, now again after we have adding, now we need to add it now. So we have merged it. So here we did merging here, right? So now we have added it now. So while adding it, let's see what all the values we'll get. So we'll get 6 comma 5. Okay. Then we'll get 7 comma 7. Then we get 2 plus 3 is going to be 8 comma 8. Again we'll get 5 plus 6 is going to be 11 comma 9. Then we'll got 6 plus 6 is going to be 12 comma 11. Then again 6 plus 7 is going to be 6 is 12, 13 comma, and 7 plus 5 is going to be 12 over here. So this is the final things we are getting it here. So right, so this is the specific final things we are getting it here. In this case, now again I need to merge it now. So how we are going to merge it here? So in this case, let's discard again. So after adding it, we need to check whether based on the increasing of the profit, whether it is increasing or decreasing. Say 6, 7, 8, 11, 12, 13. Yes, this is in the increasing order. 5, 7, okay, 7 after 8 is also fine. After that you can see 9 is coming. So 9 is exceeding the weight, so I need to discard it this, and 11 also exceeding the weight, I need to discard it this, and 12 is also getting the increasing, so I need to discard it this. So these two items will get discarded. So the final element of the S3 is going to be 6 comma 5, 7 comma 7 and 8 comma 8. So here the specific adding is done now. So after adding it, So we need to merge now. So how we are going to do? We need to merge the specific things now. So we are going to merge the two specific things over here. So it is very simple. We need to merge with this was the final thing which we got on the previously, right? This and S3, and now we are getting this. So after this we need to just merge it over here. So the finally S4 is going to be what? 0 comma 0. So I'm going to mention neatly. So we are going to get it as a 0 comma 0 is the first element. Again same 1 comma 2 will be there as it is. 2 comma 3 will be there. So 3 comma 5 was it getting discarded after we had 4 comma 5 comma 4, and again 6 comma 6 was there, and next 7 comma 7. So next 7 comma 7 will be there. So after before the 7 comma 7 we have an element that is 6 comma 5, right? So again I'll write it here as a 7 comma 7 was there, and 6 comma 5 was there, again 7 comma 7 and 8 comma 8. So in this case now which we are going to discard it. So you can see 0 1 2 5 6 7 6. So it is getting thing, right? So profit is weight is getting discarded here, right? So this 6 comma 5 will get discarded over here. Okay, again 7 comma 7 is already there, so again I'll get discarded. So 8 comma 8. So in this case we are going to have the 8 comma 8. So 8 comma 8 is the specific. See, I can accommodate the 8 weight and I can accommodate the 8 profit. So this is the, imagine this is going to be your final thing, because we, for the maximum capacity of the weight 8, I am accommodating the profit also 8 over here. So this is going to be the profit one over here. So in this case I can just mention something like x1, x2, x3 and x4. In the 4 element the accommodation is going to be same again, that is a 0 1 0 1. It is going to be the best case. So previously whichever the method we solved, that we have solved using a tabular method. So we saw this is going to be the tabular method, and this is going to be the subset of method. In the subset we are just going to add first, then we are going to do what? When we are going to merge it over there. See, for 0 comma 0 was there, 1 comma 2 we have added. So after adding a 1 comma 2, what we did, we took the next element, we just added it to it. So after adding it we got some element. So then again what we did, we are going to check whether your profit is getting increased and weight is getting increased. If it is not, we are going to discard the previous value. If it is exceeding, we are going to delete that element. Then again we took the 2 comma 3 here, we added to the 2 comma 3 to the original one, the second element. Again we got some output. Then again we merge s1 plus s2, right? Then again we check whether the thing is properly or not. Then we took again the element that is a 5 comma 4, and for the s1 and s2 we added all 5 comma 4. After doing it, again we discarded few of the elements. After discarding it, again we did s1 plus s2 plus s3, so where we are getting all the element. Again we took the last element, that is 6 comma 5. We added that 6 comma 5 to the existing s3 element. After doing it, again we did s1 plus s2 plus s3 plus s4 in the all element. Again in that we discarded few of the things which is not getting satisfied our condition, and finally we got the specific output, that is 8 comma 8. So this is for the 8, we can accommodate up to 8 comma 8 is the best scenario to using this subset over here. So this is going to be the knapsack problem. So into the next session we are going to look on to the specific a coding part for it. Take care, bye bye. Hey guys, welcome back. So in this session, let's understand the Java coding problem for 0/1 knapsack problem. So it's very simple as we have discussed. So in the previously we saw, right, how we are going to get it. Same thing, we can we are going to use one specific formula, and we are going to apply the concept of recursion and get the maximum output of it. So let's look on to the specific example. So coming back to my Eclipse over here, I'm just going to create a new specific class for the GUVI DSA using Java. So I'll right click and create specifically a new class. So for the new class, I'm just going to right click, okay, get the new class over here. The class name, whatever you want to, you can keep the class name. So I'm going to keep it as the knapsack is the class name, and I'll just create a public static void main and click onto the finished over there. So now it's very simple program. Here we are going to just pass the weights and what is the values and what all the specific capacities to it. Okay. So here we are going to create one new specific class. So what are the class? I can just tell you that I'm going to create a new class that is a public static. It is going to return you some value that is going to be an int function. I'm going to tell it as a knapsack over here. Knapsack is your class name, right? In this we are going to get the weights first. I'm going to tell it as I need to get the weights. Then again I'm going to pass the array values here. So we have, whichever the example we saw, we are going to pass the same numbers and we'll see whether we have calculated correctly or not. Again, I'm just going to tell as int capacity over here. So we need to just tell what is the maximum capacity of your bag that is going to get holded, right? So it is going to be the specific function here. So in this, I'm just going to initialize what is the n value. Int n should be whatever your weights dot length will be, that is going to be your n value here. Okay. So inside this, I'm going to give the semicolon over here. So then I wanted to create one 2D array to store the maximum values at the each capacity. So for that, we are going to apply the concept of 2D array. So I'm going to tell as a 2D array. So we are going to define in this way. So I'm going to make it as a DP, that is going to be a new. Again, I'm going to make it as an int. So initially it has to be start with n plus 1. Then I'm just going to n plus 1 here. And the next one, it is going to be the what is the maximum capacity. So I'm going to tell as a capacity here. So what we are doing right in this is exactly similar to this one. So whatever we have created here. So what is it? Let me show into the table one. Whatever we created right, this is exactly created to the 2D table here. So we are just creating this 2D table to keep on filling the specific value. So that is, this is the line of code that is mentioned that is going to evaluating for that. Okay. Now we are going to build the array here. So we are going to let's build the array now. So we have created an empty array. Now we are going to build it. So I'm going to tell run a loop here. So for n time I need to run the loop, right? So I'm going to tell, so for int I value start with 1 and I value should be lesser than or equals to n. Then I'm going to make it as a I plus plus over here. Okay. So many times the loop has to run. So here I'm going to evaluate the loop based on the weights, right? So I'm going to mention here. So initially the specifically weight value is going to be 0, right? Then whatever the weight is there, right? Whenever you are filling the weight, that's what we saw. Whenever we are filling the weight, we need to make sure that the capacity of the bag should not get increased. If the capacity here is 5, I can select only the maximum up to 5 weights here. I cannot take the 10 weights, and I can, if maximum is a 5 here, I cannot take the specifically a weight of 4 and 3 and store the profit, right? I can make sure of that should be a one specific scenario. It is going to be one specific validation. So I'm going to tell you that weight should be lesser than or equals to capacity. It can be lesser or it can be equal to the what is the capacity we have created. We have been what are the capacity of the bag is there. Okay. So it is going to be a scenario. Then I'm just going to increase the specific weight. So just it keeps on filling the value here. Now while filling the value, so I'm going to make it as a semicolon over here. So now while filling the specific value, right? So if it is going to check one condition, if the specific weights, whatever the WEIGHTH weights is there, right? That weights of I minus 1, if it is lesser than or equals to weight, okay? So I can store up to the maximum weight, then only you need to do it. So if it conditions get satisfied, then we are going to store the specific values to it. So we are just going to store the specific value to it. Now what I am going to do here is I'm going to write the formula here. So what is the formula? This is the formula which we have evaluated. So we saw here, what are the formula? V of I minus 1 comma W. So you can see the maximum, the weight dp is weight of I minus 1 and W. You can see we are taking the max value, math.max value. So I'm going to tell here import, okay, java.util.start. Okay. So in this what we are doing here is it is going to be a vertex of max of dp of I minus I. You can see here we have created same thing, right? That is a I minus I, and v of I minus 1 w minus w of I. You can see after this you can see values of I minus 1 plus v of w and w minus weights of I minus 1. The same thing we have given, right? Whatever the formula you are seeing, the same formula which we have used for evaluation purpose for solving this table, right? So this is what we need. We are just using the same specific formula here, okay, for evaluating it. So this is going to be the if condition. Else I'm going to tell else what I need to do. So else just simply exclude it, right? If it weights is getting crossed, I'm just going to tell vertex, whatever the vertex will be there, right? For the I and the specific weight, I'm just going to make it to the minus negative ones over here. Just we are just discarding it, okay? I'm going to tell here as dp of specifically I minus 1, and I'm just going to make it as a weight over here. So whatever the weight will be there, just store it that specific weight to it, okay? This is what we are doing it. So after evaluating of all the program, so now I need to return the what is the last it is returning. I'm going to tell dp for the weight specifically n, and I'm just going to return the what is the capacity. So we are just going to return the specific capacity for it. Okay, so this is what the specific program is going to do. This is a very simple program. Now what we are going to do here is, now we are going to include the weights, and I'm going to include the specific capacities over here. I'm going to tell int I of weight here. So basically WISDH weights is equals to, so what are the weights you need to pass here? Let's pass the same weights whatever we have given, that is a 2, 3, 4, 5. Okay, I'm going to pass it here the same weight, that is a 2, 3, 4 and 5. Here the weights I am passing it here. So then again I'm just going to pass, that is a int of the values, that is going to be your profits, right? So what are the values which we are going to get the profits? What was that? That is 1, 2, 5, 6, right? So I'm going to tell here as a 1, 2, 5, 6 is going to be your profit, is going to be that. And what is the maximum capacity your bag can handle? I'm going to tell the capacity is equals to, int of capacity is equals to, so we are going, the capacity is of the bag is m, right? So I'm going to give capacity, it can handle only 8. So whatever we have seen the example, we are going to pass the 8 here. So now I'm just going to tell int of what is the max value we will be getting. Max value that is going to get from the specific, and I call the specific knapsack specific problem. Here I'm just going to pass the weights, I'm going to pass the values, I'm going to pass the specific capacity to it. So after it's going to return something. So let's see what is going to be the maximum capacity for it. I'm going to tell here as a maximum profit in knapsack. So I'm going to tell here as a maximum values, or you can say maximum profit in knapsack using knapsack. Okay, using the knapsack problem is going to be equals to whatever the max value we have got it. See, this kind of things we are going to make use on the real business. Like you can add the total profits we are getting from a different business, and what is going to be your maximum things. So in this case we are going to use kind of a max knapsack problem for integration. Let's try to execute the program. So when I try to execute here, it is giving an error, that is the index weight is out of range over here. So let's see what is the specific error we are getting it here. So when I pass the vertex, right, so here we are going to pass the capacity is n plus 1. So along with that I need to place 1 here as well, right? So when I'm doing plus 1 here also we need to place it 1, right? This is one mistake. So once I execute, guys, you can see I'm getting the maximum profit using knapsack for this specific problem is 8 here. So what we got when we tried to solve, you can see the maximum profit we got here also 8 here, right? So you can pass any kind of an inputs here and you can find what is the maximum profit. You are going to get it from the stuffs using a knapsack over there. So this is all about the knapsack. Thank you guys. Take care. Bye bye. Hey guys, welcome back to the session 34. So let's discuss about the multi-stage graph to find the shortest path over here. So let's see how we are going to solve the multi-stage graph using dynamic programming. So let's begin with an example, then we are going to move on to the coding part of it. So coming back to my specific writing part, so I've created one specific graph. So let's give some kind of a numberings to it, and let's solve the specific scenario over there. So I created one specific table where we are having some kind of, we are going to update the values of a table, and along with that we are going to see how this specific scenario can be solved over here. So for this, first and foremost, we need to write one specific graph to it. So I'm going to just little bit scroll on to the top. So let's see what all the values which can give it a perfect values. Let's give it to find the specific minimum cost for it. So I'm going to select the specific color here as a blank. So let's try to give the vertex here. So like, let's imagine this is going to be your vertex 1, this is going to be 2 here, this is going to be 3, and this is going to be your 4, and this is going to be your 5. And I'm just going to make this as a 6, 7, 8, and we are having a 9, 10, 11, and the vertex 12 over there. So here we are going to talk about the multi-stage, right? So we are going to talk here. So this basically is going to be your V1 stage, this is going to be a vertex 2 stage, this is going to be your vertex 3 stage, this is going to be your vertex 4 stage, and this is going to be your vertex 5 stage over there. So let's get to give some kind of inputs to it. Let's try to give the what is the cost of it. Imagine I wanted to go to 1 to 2, the cost is going to be 9 here. Let's imagine from the 2 to 6 it is going to be 4, and 6 to 9 it is going to be, let's imagine it is going to have a 6, here it is going to be have a 4 over here. Again from 1 to 3 I can go with the cost of it is 7, and 3 to 6 I can go with the cost of 2 over here. And imagine I can go to the vertex number 2 to 7, I can I can just go with the cost of 2 here, and along with that again 3 to 7, let's imagine we have a specific cost that is 7 here, and 4 to 8 imagine we have having 11, and even from 5 to this also we are having an 11. The cost is here as a 2. This is going to be your 8, and so on all over there. Okay, so I'm just going to write the other few cost as well. That is going to be 3, and from 7 to 9, imagine I have the specific cost here as 4 here. Okay, and the last stage, that is a 10 to 2, we are going to have a 2, and it's going to be have a 5, and let's make it a little more neat. So I'm just going to make this going to be you're having a 5 here, and it's going to be a 6 over here. So I wanted to add another connection, so that which I have left it. So I'm just going to add the another connection over here. So from the specific 6 to 10, we have another connection. Let's add the specific connection, that is a 6 to 10 we have. And again, we have a specific connection from 2 to 6, 2 to 7, and even we have a 2 to 8 as well. Okay, so we are taking a complex graph to understand. So with that, to understand, not a complex, it's easy, not much that much as difficult as you are thinking for right now. So imagine we have a cost from 2 to 8. Imagine we have the specific cost that is 1 here. Okay, I'm just going to mention here as a 1. So we have a 2 to cost is 1, and 6 to 10. Imagine we have the specific cost here as a 5 over here. Okay, so this is going to be the specific amount of graph. Yeah, so again 1 to 4 I have missed it. That is, I'm going to make it here as a 3 here, and yeah, that's it. Okay, so let's imagine in this specific table, let's try to update the value. So we have a specific vertex, and along that we have a specific what is the distance value over here. So we have a vertex 1, we have a vertex 2, we have a vertex 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12 over here. So we are having these many vertices over here. Okay, so now we have stages as well, that is a v1, v2, v3, v4, v5 is the stages, and we have written the specific vertices and cost, and we have added the things over there. Okay, now we wanted to reach from the source to sink over here. So imagine I wanted to reach from the vertex 1 to vertex 12, which is going to be the shortest path to visit this specific thing into a multi-stage. Here you see, to go to 1 to 12, we have a lot of stages to need to pass in, and which is going to be the minimum cost that I need to bear it, and I need to just go to here. Okay, so let's start with the first iteration over here. So let's see what is the formula. So there is a formula to the multi-stage graph in the DSA. So we are going to use, that is a cost of, that is where I comma j, that is going to be, we are going to get the specific minimum value from the cost of, that is we are going to tell here as a I comma L something, plus again we are going to write the cost of, that is going to be I plus 1 comma L. So this is going to be the entire cost of it. Okay, so this is going to be the entire cost of this specific formula. So here we are using the cost of I comma j is going to be minimum of cost of I comma L plus cost of I plus 1. So I'm going to erase this thing. Okay, so I'm going to tell here as a cost of I plus 1 comma L. So this is going to be the formula. Using this specific formula, we are going to fill all the boxes inside our array over here. So now let's take the first, and I'm going to take it here as a 5th stage. Let's take this 5th stage here. So v5 is going to be the 5th stage, right? So for that, I'm just going to evaluate for this specific formula over there. So let's imagine for the cost of, I'm just going to tell here as a cost of, that is 5 comma 12. What is the 5? 5 is going to be your stage, and 12 is the vertex number. 12 is the vertex number over there. So I'm just going to mention here for the beginning. So 5 is going to be your stage, and 12 is going to be your vertex number over there. Okay, so this, let's imagine the cost of 5 comma 12 is going to be, so right now I am into the cost of, I don't have anything to go ahead from this, so it is going to be a 0 over here. Okay, so I'm going to mention that is going to be cost is 0. So this 0, I'm just going to bind it over here. I'm just going to tell the cost is going to be 0 for 12, and what is the distance we are having right now? Right now we don't have any distance, so whatever the value of 12 will be there, I'm just going to simply update that 12 over here. Okay, d value. Next, so this is going to be the 5th stage. Now let's come back to the 4th stage, so where we are having a lot of operation to be involved over here. So for the first, specifically the second thing, I wanted to find the cost of, so now I'm inside the 4th stage, right? So I'm going to come back to the 4th stage. So I wanted to tell cost of 4th stage of a vertex 9, cost of 4th stage of a vertex 10, cost of 4th stage of the vertex 11. So I'm just going to mention as it is 4 comma 9. Okay, again I'm just going to tell here as a cost of 4 comma 10. Again I'm just going to tell the cost of, that is the 4th stage, that is going to be 11 over here, right? That is going to be an 11 stage over there. So right now we are having a single thing, it's going an outgoing bond. So inside of 4th stage, I need to evaluate the formula to it. So what is going to be the cost of fourth stage, that is a vertex 9, to reach this specific sink 12? That is, what is the cost? 4, right? So I'm just going to update, this is going to be the 4 over here. And what is the fourth stage of the vertex 10 to go to the source to sink from here to here? What is the cost? That is 2, right? I'm just going to mention it here as a 2 over here. And again, what is the cost of fourth stage of 11 4 to reach 11 from the fourth stage from the source to sink? That is going to be involved, that is of cost is going to be 5 over here, right? This is going to be your 5 over here. So this is what about these things we need to update it over there. So now I'm going to mention it over here. The cost is 4 to 9. So what is the cost for 4 comma 9? So for the vertex, the cost we got it here as a, specifically I'm just going to mention here as a 4. For cost for 10, we got it as the 2. See, this 4 I'm just marking here, and this 2 I'm just putting it over here, and this 5 I'm just going to mention it over here over that. That's it. Now what is going to be the distance over here? Basically we are reaching to the vertex 12, right? So basically D is basically to where you are reaching. This is a you can just maintain as a where like you are going to the sink over here, which is the sink. What is the basically stops over the sink, right? So here I'm just going to mention I'm going from the vertex stage 4, I'm reaching to the stage that is 5, that is to the source, that is the vertex, that is 12. So I'm just going to simply update these values over here. So 12 I'm reaching here, again here also I'm reaching for the 12, and I'm just going to reaching for the specific 12 over there. Okay, so now let's move on to the further stage now. So now V4 is completed. So we completed 5th stage and we completed the 4th stage as well. That's great. Now let's start with the little more complexity will come now. Now we are going to the 3rd stage now. So now we are going to the 3rd specific stage now. First, let's imagine I wanted to find the cost from, so in this 3rd stage, so now we can go from the stage number 3 to 6, right? I'm just going to tell I wanted to find the specific cost of a stage 3. See, this is the stage 3, right? This is going to be the stages. So I'm going to tell here as a stage, so stage 2, sorry, stage 1, stage 2. Again, I'm just going to mention here as a stage 3. I'm just going to mention here as a stage 4, and I'm going to mention here as a stage 5. Okay. So now I am reaching from the stage 3 now. So I'm going to the stage 3. So I'm going to mention as a stage 3. So what is the vertex? Vertex we are having a 6 over here. Now I wanted to go to 12. To go from 6 to 12, I have a 2 paths here. 6, 9, 12, 6, 10, 12. So this is the 2 path I am having to go from vertex 6 to the vertex number 12 over here. So now I'm just going to write the specific formula. I wanted to find minimum of, so from the specific stage I can go from 6 is the specific what 6 is a basically what the vertex number, right? So what is the cost so that is a 6 is the specific vertex, right? And comma 6 comma 9, I'm just going to mention here as a specific 6 comma 9 plus I can go from C of that, I can just say C of 4 comma 9 over here. So this is the one thing. Again, I'm just going to tell C of 6 to 10 plus C of 4 to 10. So this is going to be the specific formula. So where I need to tell here. So let's understand what is this 6 comma 9 4 comma 9 here. Okay, so basically here what you are seeing that is 6 to 9 here is basically the 6 is a vertex and you are reaching to the specific distance that is 9, right? You are going to the 6 to 9 over here. Plus after 9 you need to go to 12, right? So 9 is present at your stage 4, that is the 4 here. And what is the vertex? That is 9. That is the one scenario, right? See, first you need to take C of 6 comma 9. That means C of the vertex 6 to 9 I am going it. Again, the next vertex is lying in the stage number 4, right? So I'm going to tell 4 is the stage and 9 is the vertex to reach the next thing that is 12 over here. This is the one scenario. And what is the next? C comma 6 comma 10. See, the vertex 6 to the vertex 10 I am going it, plus the stage number 4 I am going to the vertex 10 to the from the reaching to the thing that is 12. So this is going to be the two specific scenario to traverse the specific multi-stage graph. Now I'm just going to see which is going to be the minimum cost over here. So in the specific minimum, I'm just going to mention here. So what is 6 to 9? What is the what cost we are having from 6 to 9? We are having 6, right? So we are having a 6 here. So 6 plus. So from the vertex 9 to 12, how much we are having? Stage number 4 to 12, we are having a cost that is 4, right? 6 plus 4. This is one minimum. Again, there is another minimum, that is 6 to 10. So 6 to 10, the cost is 5, right? I'm just going to tell cost is 5 plus 10 to 12, the cost is 2. So 5 plus 2. So which is going to be minimum now from here? 6 plus 4 is going to be 10 and 5 plus 2 is going to be 7 over here. So 10 and 7. So here 7 is the specific minimum value, we got it. So the cost of a stage 3 to the vertex 6 is going to be 7 over here. So I'm just going to mention the cost of the vertex 6. This is your vertex 6 and the cost we got it is the minimum is 7. So I'm just going to update the 7. So what is going to from which path you are going it? So 5 plus 2 is 7, which we have selected, right? So the stage 4 and we are going to the vertex 10, right? We are going through the vertex and that is 5 plus 2 is 7. This is the vertex we have selected. So I'm just going to put tick mark. This is the vertex selected. For the 6, 10, 12, we are going to map it here. Okay. So now I'm just going to mention here the vertex which you are parsing through is, that is 10 over here. That's all. Okay. So this is going to be your stage number 3 over here. Now the same way we need to do it for the 7 here. To do it for the 7, I need to, let's do one thing. Let's copy this entire thing over here and I'm just going to cut it. And so I'm just going to, what I'll do here is I'm just going to select everything from here to here and just move it towards the down. Okay. So I'm just going to move a little bit towards the down over here. So I'm just going to paste it from here onto the right side. Okay. So here it will be there, not to worry. So I'll be pasting over here. So this is going to be useful because I need to see this stage, right? Now 7 is done. Next. So now let's see for the next cost now. So now again, I'm just going to take the another cost over here. So here I'm just going to mention the specific cost of, now I need to, 6 is done. So 12 is done, 9 is done, 10 is done, 11 is done and 6 is done. Now I need to come for the 7 here, right? So I'm going to tell here the cost. So what is the stage now? The stage is 3, the cost is 7. So the vertex which we are selecting is, that is 7 over here. So now from this specific cost 7, I can go 7, 9, 12, 7, 10, 12. So this is a 2 specific scenario where I can go. So same thing I'm just going to tell. So I'm going to tell C of, I'm just going to select the vertex 7. After selecting the vertex 7, I'll be selecting the 9 over here, 7 to 9 plus along with that. So now I am just reaching to the stage number 4, right? So I'm going to the stage number 4 and through 9 I'll be going to this thing. So I'll be telling 4, 9. So this can be one scenario. Again, cost of, now I'm going to tell I'm going through 7, 10 plus again cost of, basically now 4th stage is the vertex 10 we are having. So now that vertex I'm going to mention here as a 4, 10. This is the 4th stage. This is the 10th vertex. I'm going to have it over there. So now I'm just going to find the, what is the minimum cost now. What is the cost for 7 to 9? So 7 to 9, what is the specific cost? That is going to have a 4 plus cost of 4, 9. Cost of what? Stage number 4, 9 to 12. Which is the cost we are having. So I can just take it from the table itself, right? So I wanted to, in the stage 4, I wanted to see what is the cost for 9. See, in the stage 4, in the specific cost of vertex 9, we are having the 4. I'm just going to take it from the table. So again, 7 to 10. So 7 to 10, the cost is, that is going to be 3 plus what is the cost of 4 stage and 10. So here only I can take the cost is 2, right? So for the vertex number 10, I have a cost 2, that is 2 over here. I'm going to take it here. So which is going to be the minimum here. The 5 is going to be minimum. 3 plus 2 is the specific 5. 5 is going to be the minimum. So I'm just going to select the specific vertex, that is stage 7. So for the cost of the specific through the stage 3 to 7, I can traverse to the 10. So it is going to be over here. So now after doing this, I'm just going to update the specific value to it. So after this, I'm just going to update the value for this specific cost 7. I got the specific that is 5 for the vertex number 7, right? I got the cost, minimum cost is 5. From where I am traveling to the vertex number 10. That is, I'm going to just mention it over here now. That's it, right? That is going to be the 7. 7 is also done. So same way, now I need to do it for the 8 now. So I'm just going to do it for the 8. So I'm going to tell here as a cost of the stage number 3. I'm selecting a vertex 8 here. So from this specific minimum, I can go to 8, 10, 12 or 8, 11, 12. So this is all I can traverse it. So I'm just going to mention here cost of 3, 8. So in this, I'm just going to find the, what is going to be the minimum over here. So in this minimum, I'm just going to mention here that is going to be the cost of, I wanted to take the vertex number 8 and I'm going to travel through, that is a vertex 10 plus cost of the stage number 4 is there, which is going to be the vertex 10 is at stage number 4, right? I'm just going to mention it over here. So again, I can traverse to another path, that is I'm going to traverse to 8 comma, so I'm going to traverse to 8 comma 11, right, plus the cost of the specific stage 4, and to the vertex 11 I'm going to traverse it. So if I just try to see what is the minimum cost I will be getting here, so it is going to be for the 8 to 10. So basically for the 8 to 10 we have the specific cost, that is a 5 plus cost of 4 to 10. So for the 10, what is the cost we are having? I can select it from the table. We have a 2 here. This is the one. And next 8 to 11, right? So 8 to 11 we have a cost, that is 6 here, plus what is going to be the cost of 4 to 11, the basically stage number 11 to 12. I can just get it from here, right? So I can just get what is the cost for the 5 we are having, right? So I'm going to tell 6 plus 5 over here. So which is minimum? 7 is going to be the minimum value. So I'm going to tell the cost for the vertex number, that is 8, we are going to got the specific cost, that is 7. So for the cost I got it as a minimum value, that is 7 here. And for the vertex number 8, so from where I am traveling it, so I'm traveling through this thing, that is a vertex number 10, right? So I'm just going to mention, so I'll be selecting a vertex that is 10 over here. So this is going to be your specific scenario for the specific cost, that is 3 comma 8. I hope you have understood. So it's very simple, but I have taken a very complex graph. So and understanding is as simple as that we are understanding right now. So now again I'm just going to cut this specific scenario. I'm just going to cut this. I'll just paste it somewhere after here. Okay, so I'm just going to paste it onto the bottom of it. Okay, so here I have pasted it here. So this is what the specific stages we are traveling it here. So now let's try to do it for the remaining one. So now I'm just going to do it for the specific. So this is also done. So this also is completed. Now we need to do it for 2, 3, 4, 5. Then we can able to see which is going to be the minimum cost now. Okay, so looks interesting. So bear for me for few more minutes. So I'm going to tell here as a, so I'm going to select the specific cost number 2, and what is the stage? Stage is also true. So I'm going to tell cost of 2 comma 2 here. So from the 2 I can find the specific scenario. From the 2, right, I'm going from 3 scenarios here. So 2, 6 I can go again, 2, 7 also I can go again, 2, 8 I can go. So here you don't need to worry from the 4 how you are going. So you'll go from 2, 6, 10, 12 or 2, 6, 9, 12. So this is a 2 possible, right? So that is why it is called as a multi-stage graph. We have a multiple stage, but we can get the minimum cost from the vertex 9. I can tell from the vertex 9 the minimum cost is directly 4. No need to think about what it is happening. So if you are reaching a vertex number 6, the minimum cost is 7 itself, like that. Okay. Now let's imagine here. So for the cost 2 minimum, I'm just going to tell. So let's select the 6 here, then 7, then 8 over here. So I'll just tell here, that is cost of from 2 to 6, cost of from 2 to 7, again cost of from 2 to 8, right? That's correct. Again plus. So again I'm just going to mention here as a cost and cost here. So basically, so from this specific 6, again I'm going to tell, so what is the stage we are having? So just we need to update the stage. So stage will remain same, put comma, and whatever the last value, that is a 6, 7, 8 is there, just replace to 6, 7, 8. No need to think anything. Okay. If you want to see from the graph, you can do it. Just see from which vertexes it is going, just update that. Then cost you can update by just seeing this one, and the stage update it here. That's it. Now if I just see here, so cost of 2 to 6, cost of 2 to 6 is 4, right? Then cost of 2 to 7, cost of 2 to 7, that is we are having 2. And cost of 2 to 8, we are having basically again 2, right? So sorry, the cost of 2 to 7, we are having 1 here. Okay, not 2. I'm going to mention 1 here. So 4 plus 2 plus 1 plus. Now this cost 6, 7, 8, I can get it from the table, right? See 6, 7, 8, we have the vertex 7, 5, 7. So simply I'll update here 7, 5 and 7. From table I am taking. I'm not going to look again from here graph. Okay. So now let's imagine which is going to be here. So 4 plus 7 is going to be 11. This is going to be 7. This is going to be 8. So I can just select the best, that is 2 to 5. So for the vertex number 2, so here you can see I'm going to update here inside it, that I'm going to tell. See for the specific vertex number 2, the minimum cost I can get is 7 here. So I'm just going to update the cost is 7. So from where you are going it, so 7 is going through the specific stage 3 and it is going through 7, right? It is going to the specific thing, that is 7, right? So that I can just update it into the specific table, that is 7, and I'm going through the specific vertex, that is 7 over here. That's it. That's very simple, right? So 2 is completed. Then let's take it for the 2 to 4. So now let's, okay, this is completed. So 2 to 2 is done. So now let's take it from the next, this is done, right? So next we need to take it the specific next specific call, that let's take it from 2 to 4, right? So I'm going to mention here the specific cost. So in this specific cost, now I'm just going to mention that is 2 to which I need to go, I guess. Okay, so 6 is done, 7 is done, 8 is done, right? So again I need to take this specific stage that is 2 here. So I'm going to take this specific stage that is 2. So after taking a stage 2, I'm just going to take the vertex that is 3 here now. So I'm going to tell 2 to 3 here. So from the vertex stage number 3, I can go from 3, 6, so on. Again I can go from 3, 7, so on. So I'm going to tell here as a minimum cost. I'll just tell here, I'll just tell C of, basically I am just traversing from the specific stage number 2. I'm selecting the vertex, sorry, I'm just going to tell the specific vertex 3. I'm just selecting the specific through 6, right? Again I'm just going to tell C of, basically I'm just going to select again the from the vertex 3 to 7 over here. Then plus I'm just going to put cost. I'm just going to put cost. So what is the stage here? The stage is going to be the specific stage is going to be second stage, right? So I'm going to just mention the specific stage is going to be yeah, sorry, I'm going to take the next stage, right? That is a 3, the stage, right? So 3 is going to be the stage. And what is the next thing? So whatever 6, 7 will be there, so just update here as a 6 and 7 over here. So if you evaluate this specific from 2 to 3, so for the first thing we'll be getting as a 3, then 9, then I'll be getting as a 6 over here. So 3, 9 in 3, 9, 6, basically that's what I directly I've just added it from 2 to from specifically 3 to 6. So we are getting this much. So in this, which is going to be the specific minimum for 2 to 3, for if I select the specific cost 3. So the 9 is going to, and 9 and 6 will be getting in specific thing, which is going to be the minimum over here. So yeah, so let's understand properly. Okay, so here we lost the specific tray. So let's imagine, see here 3, 6, right? Imagine I am telling here as I'm selecting the vertex number 3 and through 6 I am going it, that is done. Then cost of the specific stage number 3 and I am selecting 3 specific 6. Again the vertex from 3 to 7 I am going, then plus I need to see what is the cost of the stage number 3 to this specific, that is the specific stage number 3 to the specific 7 here, right? In this case we need to select it as a 7, not 6 over here. This is a one mistake. Now let's see what is the cost here. So basically from 3 to 6 we have the cost that is 2 plus cost of 3 to 6 I can see is from the specific table, right? So I can just see the cost is 7 here for the vertex number 6. Again next this is going to be 1, and next again 3, 7. So this stage from 3 to 7 we have the specific cost that is 7 here, 7 plus I'm just going to mention again what is the cost of 3 to 7. So what is the cost of 7 here? The cost is going to be 5, right? This is going to be cost from the stage 5. So I'm going to mention here as a 5 here. So which is minimum? 7 plus 2 is 9, and 5 plus 3, 5 plus 7 is going to be 12. So 9 is minimum, right? So basically 9 is minimum. So I'm just going to tell for the vertex number 3, the 9 is the specific minimum cost, and I am traveling through which? So which I got for the first one, and stage that is 6 to the vertex number 3 I am traveling it. So which is the specific what is the specific thing I am traveling? So I am traveling through the specific stage that is 6 over here. So this I have been updated over here. Okay, so you can see the stage 6 we are traveling, right? From that is what I have updated it here. So 3 is also done. So now let's see for this specific here itself the cost of the specific stage 2. I am telling the specific cost stage 2. I am selecting the vertex number 4 over here. So again I'm just going to tell minimum. So here I'm going to tell the cost of from the 4 I can directly, we have only one, that is I can just go to 8. So I'm going to tell here for the specific so okay, for the specific 8, right? So I'm going to tell here the cost of the specific 4 to 8, right? So I'm going to tell here the cost of that is a 4 to 8 I am going it here, plus cost of the specific stage number is 3 and the vertex is 8 over here. I have updated here. So here it is going to be minimum cost of 4 to 8 is going to be 11, plus that is going to, what is the cost of the vertex number 8? Already we have the 7. So 7 I'm just going to update, that is going to be 18 over here. So this is the 18. This is going to be the minimum cost. I'm going to update it here as 18. So 4 is also done. and from which I am traveling. So simply I am traveling through the vertex that is 8. We have only one, so I'm just going to mention it as a 8 over here. That's it. Okay, so this is, again I'm just going to select it, and again I'm just going to comment it back over here. So let's say I'm simply Control X, and I'm just going to put it at the after here. Okay, so this is going to be the stage now. So let's do it for the last things as well. So for the last thing, let's try to do it here itself. So let's say I'm just going to delete this specific scenario. Let me delete this thing. Now let's do it for the cost, that is 2, 5 and 1, 1. So if I just I'll do it a little bit fast so that I don't want to make you bored. So I'm going to tell here as a cost of, now I'm just selecting the vertex number 5 here. So the stage 2, the vertex 5, we are having 5 to 7 I can go. Again I can go to 5 to 8. So this is the 2 scenarios I can go, right? So I can just tell here we are going to get the specific minimum. So I'm going to tell here as a cost of, that is 5 to 7 plus cost of, we are going to take 3 to 7 over here, like this. Okay, so I'm going to tell 5 to 7, I'm just going it. This is the one specific scenario. So again I'm just going to tell C of, basically I'll be traveling from 5 to 8 as well, 5 to 8 as well, plus I'm just going to tell here as a cost of, that is I'm going to tell here what is the specific stage we are having. The stage is 3 and the 8 I will be simply updating here. So if I just see what is the minimum value, so we'll be getting here as a first for the 11 plus 5 and 8 plus 17. So here which is going to be the minimum? So this is going to be 16. This is going to be more than 20 plus, right? So I'll be simply selecting what? So I'll be simply selecting the next, that is a 15 one I'll be selecting here, right? So I'll just tell 15 has been selected. So for the 15, if I wanted to select, so which is the specific stage, the first one. So we are traveling through the stage, that is basically I am for the 15, right? So 11 plus 5 is going to be 16. 18 plus how much it will be? Around 25, right? So from which I am traveling it here. So cost of, see, 16 I have, 15 I have updated it here, right? The cost is going to be for the stage number 5 is going to be 15. So I have mentioned as 15, or what is it? So let's see what. So 5 to 7, right? So 5 to 7 we have an 11. Okay, 11 plus we are just choosing cost of 3 to 7. Cost of this stage 7 is going to be 16, right? So this is going to be the 16 is the cost we are getting it. Next, if I just say 5 to 8 is going to be 8 plus. So for the 8, cost of 3 to 8, 8 is 7, right? So it is not 17, it is basically a 7, not 17. Okay, 7, right? So 8 plus 7 is going to be 15 here. So 8 plus 7, it is going to be 15. Let me write it 8, 7 and 15 here. So it will be 8 plus 7, that is going to be 15. 15 is been selected. So 15 I have updated. So that is going through the vertex, that is 8 over here. So I'm just going to mention simply a 8 over here. So this is how the specific cost can be calculated over here. So I hope you are getting it easily, right? So now let's do it for the cost of 1, 1 over here. So if I take it 1, so I can go to 1 to 2, 1 to 3, 1 to 4 and 1 to 5. I'll just simply write it here. I wanted to find the minimum, that is C of 1, 2, C of 1, 3, again cost of 1, 4, again cost of 1, 5 here. So this is from this through I can go it. So plus plus plus. So again I'm just going to tell here as a cost. I'm going to mention here as a cost. I'm going to mention as a cost. I'm going to mention as a cost. So in this, which is the specific stage we are traversing, that is the stage number 2. So 2, 2, 2, 2, 2 is the stage over here. So from this I'm just going to mention the same thing, 2, 2. So in last state it will be same, 3 is 3. So 4 will come over here. Again 5 is going to come over here. So now if I evaluate, this is over here. So we are going to get the cost of 1 to 2 is basically in the graph. You can see the cost of 1 to 2 is 9. Again cost of 1 to 3 7. Again it is having 3. Again we are having cost of 1 to 5 is basically 2 over here. So now let's data I can get it from table. Cost of 2 to 2. Cost of 2 is basically 7, right? Again cost of 3 is we are having 9. Update it. The cost of 4 we are having 18. Update it. The cost of 5 we are having 15. Just update it. So from here, which is going to be the minimum. So in this case we are going to get the, so 9 plus 7. What is the 9 plus 7? It's going to be 16. So 7 sevens are 14, 8, 14, 15, 16, 16, 16, right? 3 plus 8 is going to be 21 and this is going to be 17. So in this we got two things over here. So basically I can traverse through 2 also I can go, even I can go it from 1 to 3. So I can say either select, I can go either from 2 or 3. I can go it from the either 2 or 3, whichever you want. You can just select it and I'm just going to keep it whichever you want, you can just select it. Okay, so I'll just tell what is the cost, minimum cost we are getting as a 16. I'll tell basically I can traverse through the vertex 2 or 3, whichever I want, I can just traverse it over that. Okay, so this is how the specific minimum cost is going to work. Now in this specific scenario, I can just tell here, which is this is how the specific thing I can reach it. So this is going to be the cost for the every each vertexes, and now I'm just going to mention here something. So I'm going to tell if I just tell d of 1 comma 1. So 1 is going to be your basically a distance, sorry, the vertex for the source 2. Basically I'm going to tell 1 comma 1, that is going to be 2, and I'm going to tell, I'll just select next 2 comma 2 is going to be 7. Again d of 3 comma 7 is going to be 10. Again d of 4 comma 10, I'm just going to tell 12 over here. So this is how I can reach it to travels from the source to sink into a very simpler manner over here. Okay, so this is how the thing is going to be there. So let's understand properly, like what that I have written 1 and 2 over there. So to reach from the source to sink, so let's try to I'll try again. So I'm going to select the specific stage number 1. Okay, this is going to be your stage. So if I just select the stage number 1, that is 1, so I'm going to just select either 2 or 80. What is the specific distance I can just select, that is 2 or 3, right? So let's imagine in this specific, let me select the vertex number 1. Okay, in the specific stage now, in the stage number 1, I'll select the source vertex, that is 1. The cost I'll be getting as a 16, that is basically I can go through the vertex, that is 2 or 3. So let me select it as a 2 here. So again I'm just going to tell this d of in this specific stage number 2, so this 2 has to come over here, so 2 comma 2. So for this specific vertex number 2, which is the, what is the cost, that is 7, and what is the specific d I need to select, this d I need to select it as the vertex I need to select it as 7, right? So I'm going to tell it as a 7, I am going to select it over there. So again d, so again I'll just tell in the stage number 3, so this is going to come over here, that is a 3 comma 7. So in this specific 3 comma 7, so now I am at the stage 3, so I will be selecting the vertex number 7 here. So what is the specific cost is going to be 5, and which is this vertex I need to select, that is 10 over here. So I'm just going to mention here as a 10. So again this in the stage number 4, so 10 is going to come over here. So in this specific stage number 4 for the vertex 10, so I need to go to the sink, that is going to be 12 over here. See, I traveled from the specific source to sink over here. So this is the specific cost over here. So if I try to draw, I'll be going from, see, I'll be going from basically 1 to 2. If I just go again 2 to 7, I'll be, so 1 to 2 I'll be going. So again I'll be going from 2 to 7, again from 2 to 7 to where okay, 7, so again 7 to 10 I'll be going it, again 10 to 12 I'll be going. So this is going to be the shortest path over here. This is going to be the shortest path. So what are the value we got, the costs, we can just mention the specific cost. This is going to be the minimum cost, so where I can traverse from source to sink over here. You try to test, or even everything, this is going to be the minimum cost. Even I said I can select 3 also, right? Even 3 also can be, 3 is also possible. I can go from the distance d, I can just tell from the vertex 1 I will be going sorry, the stage 1 I'll just select the vertex first. So in this stage I can select 3 also, I can just select 3 also here. Then again, so in the stage number 2 I'll be taking the 3 here. So if I take it as a source number 3, so I will be going to the vertex number d is going to be 6, right? So 6 I can go here. So again I'll be taking d of 2, so again this 6 I'll be taking here. So sorry, in the stage number 3, 6 I'll be taking here. So if I tell 3 of 6, I'll be traveling to 10. So again the same thing will come, that 4 comma 10, that will be going to sink over here. Even I'll be going, so vertex 1, I can just go to the vertex 3. So from 3, so this is 3, again from here I'll be going to 6, again 6 to 10, so I'll be telling here 6, again 6 to 10, again 10 to 12. So these are the two possible ways I can traverse to source to sink in the minimum cost over there. So shortest path over there. So this is all about this, specifically about the multi-stage graph. I hope you have understood. We saw all the specific thing line by line, and we have understood. It was a pretty good video and pretty good explanation for it. In the next session, we are going to look on to the coding part for it. Take care. Bye-bye. Hey guys, welcome back. So let's understand the coding example on multi-stage graph into this session. So let's begin with the Java program, and we're going to see how the code is going to be there. So in the previous session, we saw how the specific example for it. So already we saw, right, this is going to be the graph, so where we'll be having the stages and we are going to reach from the source to sink. And here is the formula. The main formula here is we are going to apply the specific minimum cost and we are going to get it, right. So that formula also we have been seen into the specific stage over here. That is going to be, we are going to see the cost of I comma L plus cost of I plus 1 comma L over there. We are going to see the what is the cost of here, and we are going to see the cost of the previous stages as well, and we'll move on to the coding part over here now. So coming back to my Eclipse part over here, so I have created this specific class that is a multi-stage graph over here. So let's try to import the specific package. So I'm going to use this specific array package over here. So I'm going to use import java.util arrays over here. So I'm going to import this java.util.arrays package. We are going to make use of the arrays over here. So here I'm just going to create one specific static final variable. It is going to be the specific static final. So we are going to create in. So we are going to create INF over here. So INF is going to be, it is going to hold the largest value of the specific integer. So I'm going to tell here as a integer dot max value. So I'm just going to declare the largest value into the INF over here. So then I'm just going to create one specific function to find the specific shortest path into our multi-stage graph. So that I'm just going to keep it here as the public static, and we are going to read, it's going to return you something. So the function name I'm just going to keep it here as this shortest path is the function name. So here it is going to take basically what are the graph values, we are going to add it into the graph. The second point here is it is going to take the how many stages are there inside your graph. So that is the two things it takes as a parameter. So I'm just going to pass the specific int of graph. It is a multi-stage graph, right? It is a multi-array. So I'm going to use as an int of graph. I'm going to use it here, and we are going to pass how many stages are there here as well. Okay. So once I get the input parameter from here, so I'm just going to store it into the n. What is the graph length is basically. So I'm going to tell graph graph dot length length. So it tells the basically from this specific scenario we can understand how many number of vertices are present inside the graph. So that is why we are taking the length of this graph over there. So then I'm just going to store the what is the cost for it and what is going to be the path for it. So what is the cost? I'm going to tell here that the cost I'm going to store it in the int cost is equals to. So here we declared, right. So we can see here we use the something table where we are storing the specific cost and which is the specific path we are following, which is the specific path we are following for the each vertex. So for this to store the data, we are going to create a single array, element array. So where we are going to store the cost and the specific d value as it. So cost is going to define the cost that I'm going to tell here as a new int of the n. The initial cost is going to be just storing as a n value. Then again the specific cost array. So basically we are just telling this the n is basically tells the 6, right. If we are having the how many vertices 1 2 3 4, if we are having a 12, we need to have a 12 spaces to store the data, right. That's why we are just using the n value to create the space of so and so how many vertices are there. And even for the path also it is going to be same. So int path is going to be new of, that's basically int of n over here. So this is the two things we have stored it here now. So now what we are going to do here is for the arrays. So for the arrays we are going for right now in this specific using an arrays here. So arrays dot we are going to fill the specific value of the cost comma inf here. Okay. So the cost I'm just going to store it into the arrays, and after that the whatever this false is there, right, I'm just going to tell I wanted to store the maximum value inside it. Okay, inf over here. So for all the arrays we are the whatever the empty array we created, right. So for that we are just filling for the maximum value as inf, so that later we are going to change it. First we are going to fill it with the inf values into the boxes over there. That's it. Okay. So then we are going to fill for the cost of n-1 value. So basically for the whatever the vertex name value will be there. So for the vertex, suppose if we having a 7 vertex, 7 minus 1 for the 6th vertex, the starting vertex which we are going to start. So for that we are going to start with the 0 over here. So in this what happens here, right. So cost of n-1 basically describe the cost of the last node itself. Okay, whichever the last node will be present. Here. So if I start, we have done from here, right. We always started with this last from the vertex 12 here. If you guys remember, we started calculating the path from 12 to here we went, right, till 1 while doing this specific problem while we are solving it. So whatever the last vertex data is there, that we are just storing over here, okay, as it's 0 as the cost of it. Okay, now we are going to run a loop and we are going to calculate the shortest path for the every node from the last to first basically. So that is what the multi-stage from last to first we were traversing, right? So for that we are going to run one loop over there. So I'm going to run the loop, that is a for loop. So for loop I'm going to tell here as int I value. So always I need to start from the first vertex is done. If I want to get the second last vertex, I'm going to tell I value start with n minus 2. Let's take it, and I value should be greater than or equals to 0. Then I need to decrement the every stages over here, right? So this was going to run a loop here. So inside that, now I need to just find the what is the minimum cost for it. So it's very simple. So you guys know, right? So what is the formula we have used? We are going to use the same specific formula, get the minimum value from this whatever we have created initialized here. So that only we are going to write it here as well. Okay, so we are going to write it here for I n minus 1 ij. So as it's a multi-stage graph, so it will be having a 2 inner loop. So one loop is for basically the first thing, then it is going to take it for the next specific index. That is, I'm going to tell int j is equals to I plus 1 and j value should be lesser than n, and it's going to be j plus plus over here. So now I'm just going to check one condition over here. If the specific graph, okay, if the specific graph of I and the specific graph of j is not equals to the specific INF. Okay, if it is not equals to the minimum, like whatever the cost we have declared, right? INF means there is no cost for the specific connection, right? That's we are giving as a maximum value for that. If the graph of I not equals to INF and %, I'm just going to tell the cost of the I value, the cost of the specific I value is greater than the specific graph of I comma j over here. So we are going to pass it. If the cost of whatever the cost we are getting, if it is greater than the graph of I plus j, along with that the specific cost of j over here. So if this specific condition satisfied, then we are going to change the specific value of the we are just going to declare its cost. So I'm going to tell here the cost of I should be what? Cost of I should be graff graph of I plus j, whatever we have got, plus what is the cost of the previous j over here, right? So j is basically declares the first, and it is going to declare the previous stage, and is going to declare the first stage over there. So along with that, here it has to be I comma j, not I plus. So it is going to be like this. Okay, so then we are going to tell, we need to declare what is the path of I as well. So I'm going to tell path of I is going to be whatever the j value we have declared it over here. So this is how the things is going to be there over there. So this is going to be the specific graph. So this is going to be this things over now. So now what I need to do here is we need to print the path as well, right? So we need to print the path, then we need to return what is the cost, maximum cost it is going to be there. So for now, I'm just going to tell I need to print, right? So I'm going to tell here as I'm going to create as an int of array. So for the result, so I'm going to create another path, that is the result of path is going to be, it is going to be new of int of the stages over here. So we are going to tell as an int of stages. So inside this, I'm going to tell the specific result path of the starting vertex whatever we have. So just make it that as 0. That's going to make it as the 0 over there. So then again I'm going to initialize all the values for it. Okay, so for the result path of 0 we have done as the 0 over here. Once we have done, so I'm going to tell here the for loop I'm going to run for int, that is I start with the I value 1. So basically we are just printing the what all the stages are there. Okay, so on the which stages I need to go. So I'm going to tell here as a I plus plus over here. So then you are going to tell whatever the result of, that is a path of the specific I value will be there, right? So for that I'm just going to apply the path of the RUSULT as result. So RURESULT result path. So it is going to be a little bit confusing for you. I'll tell you where we are getting the specific value. Okay, so we are going to write the specific formula. Let me write it first. So here I'm going to tell here I is equals to I plus 1, and the specific I value should be lesser than the stages and I plus plus over here. So this is going to be the formula, and this is going to be closing in this way. Okay, so here after getting this specific path, basically what we are doing the result path, right? So here whatever the result we were getting it in the previously, like imagine for the v3 stage 6 we need to see what is the result stage, which is the stage and what is the result, right? So that is what we were doing it while doing this 6, 6 like that. So for that we were doing, imagine if we having a two specific paths. So there can be a two different paths from one stages, right? So we are just going to calculate those things inside this loop, and we are going to store that what is the result path actually we are going it here. So here we are getting a result. So we are getting here as a result of path of I is equals to path of result path of I minus 1 over here. We have given correctly, but it's showing this error. It's telling the insert, okay, it's telling me some syntax error over that. So what is the error of here? So result of path I is lesser than stages, and I plus plus, and I value is 1. Okay, let's see what is the result. So I'm going to just print the what is the sy print print the specific, that is I'm going to tell here as a shortest path is going to be something like this. So after this, whatever the I'm going to run one loop, and there I'm going to return the what is the cost of it. Okay, so I'm going to just write it here. So we are return a loop again. So we are telling here like int of I is equals to 0, I is lesser than or equals to changes, and I plus plus. So whatever the result path, whatever the shortest path we got, for that we are just printing it, and we are just returning the what is the cost of 0 it over here. Okay, so I'm just going to close the specific flower bracket over here. Okay, so this is the specific functions that returns for the shortest path which we have written it over there. Now we need to pass one specific graph and adjacency matrix basically. Then we are going to print what is the minimum cost of it. For that, I'm just going to paste it here. So I have created one specific graph here. Okay, so that takes a multi-tile graph, that is a 1, 2, 5 and 4, 11, 9, 15. We have taken the biggest example here itself. So basically, whatever the graph we have created, right? So for that, we have just created the one specific value. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. So we are having a 9 more than 9 vertices, and we are having a 4 stages, and then we are just passing the minimum for the shortest path program. We are just passing the graph, whatever the graph enter, how many stages are there. So once it returns something, we are going to get the what is the minimum cost for this specific graph over that. So if I execute this specific program, I hope there won't be any errors. Wow, so you can see it is printing me the shortest path over here. So in this function, whatever the result path was there, it is printing the shortest path. It's telling me you can reach to 0 to the 7th vertex, that is from the 0, 3, 6, 7 is going to be the shortest path over here. You can take it, and the minimum cost, it is going to be 9 here. So it is telling me the shortest path also it has given, and along with that it's saying me what is going to be minimum cost as well. Okay, so this is how the things we got it. So you can see how we were getting 1 to 7. So how we got 1 to 7, 10, 12. This was the shortest path for us, right? But here if you draw the specific graph, and if you see the 4 stages, and it will be 0, 3, 6, 7 is going to be the shortest path. So if we wanted to calculate here also, so what is the maximum we found it here, the value. If you wanted to find here, you can just pass this vertices as a 12. You can pass the 12 as the data, and you can just pass what all the values of it in the graph. So then you will be able to find the cost whatever we have solved it over there. This is going to be the example for the multi-stage graph using a Java program. Thank you guys, take care, bye bye. Hey guys, welcome to the section 7, session number 35. So let's discuss about the travel salesperson problem into the session. So before going to the coding part, let's understand with an example how a traveling salesman person is going to use to find the specific shortest path from the source to destination over there. So it is a kind of a dynamic programming concept again. So we are going to find again the shortest path using TSP over here. So let's begin with the specific example for it. So coming back to my specific notepad over there. So I have created one specific graph that is a specific bidirectional graph. So here let's take an example here, and let's see how it is going to be there. Imagine I have a one specific element here as a 1 here, and I'm having an element that is 2 here, and here I'm having a 4, again I'm having something 3 over here. Okay, so here is the specific graph which we are having it here. So I'm just going to give some of the specific cost for this specific graph. So in the matrix, I'm going to give here as a 1, 2, 3, 4, and 1, 2, 3, 4 I have been created. So imagine we have a 1 to 1, we have a specific cost is 0, and we have from the 1 to 2, we have the specific cost here as a 10, and 1 to 3, we have something as a 15, and we have 20 here, and let's give it here as a 5, 0, 9, 10, and I'll be giving here as a 6, 13, 0 and 12 here, and let me give it here as a 8, 8, 9, 0. Okay, so you can just add the specific numberings over here. So basically 1 to 2 we have the cost that is 10, again from 2 to 1 we have the cost 5. Okay, thus I have just created one specific graph normally. So the main matrix I have created the cost matrix of this. So now I need to right? We need to use the traveling salesperson shortest path to find what is going to be the shortest path to traverse from the specific source. Imagine this is going to be your OU or SE source. So you need to visit all the nodes and again you need to come back to the same node. So the overall idea here is to start the node from the vertex 1 and I need to visit 2, 3, 4, again I need to come back to 1. To do this, I need to find the what is going to be the minimum cost to work on the specific part over there. Okay, it can be 1 2 3 4 1, it can be 1 3 2 4 1, it can be 1 4 2 3 1, it can be n possible ways, right? So whatever it is, so now we need to find in a such a way that should be a minimum cost. So that is the main goal for us now. So for that we are going to create another graph over here. So let's understand using the graphical point over there. So here we are going to start with the vertex 1 here, right? So I'm just going to use the colors over there. I'm going to use the vertex 1. So imagine I wanted to use the vertex 1 over here. So I'm going to start basically from the vertex 1 over here. And I wanted to go to the vertex 2 over there. So I'm going to make it as a vertex 2 here. Okay. So I'm going to just make it as a vertex 2 over here. So in this specific vertex 2, will be there. Again, let me put this specific thing to the little bit of bottom. So I'm just going to make use of here. So I'll be using here as a. So it is going to be the vertex 2. And here it is going to be the vertex 3 and here it is going to be the vertex 4 over there. So this is going to be the minimum shortest path over there. So I'm just going to tell here as this is going to be the vertex 1 to 1 and here I am going to make it as a vertex 1 to 3 and I am going to make it as a vertex 1 to 4 over there. So 1 2 3 4 we need to visit it. So again, so 1 2 I can visit from the vertex 1 to 2, vertex 1 to 3, vertex 1 to 4 that I have added it here. Again from 2 where all I can visit. So basically once I start again I won't go back to the 1. So either I can visit 4, either I can visit 3, right? So that is what I'll be mentioning here. So from the vertex 2 I'll be going to the vertex number 3 or I'll be going the vertex number 4 over there. And again from the 3 I can go to 2, I can go to 4, not to the 1 directly, right? So let me go it as a 2 here and let me get here as a specific vertex that is 4 over here. Okay. So in this specific vertex 4, me draw like this vertex 4 over here and from the 4 vertex I can go again directly to the vertex 2. I can go to the vertex 3, not to the 1 because I am coming from the 1 here, right? That's why again I am going to mention here that is vertex number 2 and the specific vertex number 3 over here. So once I visit 1 2 3 1 2 1 2 4 1 2 1 3 2 again 1 3 4 again 1 4 2 again 1 4 3, so it's the last vertex. No? So that the remaining vertex there I need to write it. First let me draw these specific lines to it. So here it is going to be here to here and here it is there and here it is going to be there, again this is there and this is going to be there over there. Okay, so let me draw again properly this stuff. Okay, yeah, so this is going to be the specific scenario for now. So again from the vertex number 3 I have visited vertex 1, vertex 2, vertex 3. So what is the remaining vertex? So the remaining vertex is 4. So I'm just going to mention it here as a 4. So I can read 3 to 4 here. Again 1 2 4 is done. So remaining vertex is that is going to be 3. So I'm just going to mention here as a 3 over there. Again 1 3 2 is there. So the remaining vertex is going to be 4. So I'm going to mention here as this is going to be the vertex 4. Again 1 3 4 is done. So remaining vertex is going to be 2. So remaining vertex is going to be 2. So I'm just going to mention that is going to be 2 here. I'm just going to mention the specific straight line. Again vertex 1 4 2 is done. So the remaining vertex is going to be 3. So I'll be adding the vertex that is going to be 3. And 1 4 3 is done. So remaining vertex is going to be 2 over here. So I'm going to add it, that is 2 over here. So once I have added it over there, so again it is going to visit at the last vertex, right? So we have started from the source SOU or SE source 1 2 3 4. So again I will be reaching to the, that is going to be, again I will be reaching to 1. So source 1 2 4 3, again I will be reaching to the vertex 1. So 1 3 2 4, again I wanted to reach to the vertex 1. 1 3 4 2, again I will be going to the vertex 1. 1 4 2 3, again I need to go to the vertex 1. Again 1 4 3 2, again I need to go to the vertex 1 here itself. So the main agenda here is to travel from the source to destination, right? So here we source is also same, the destination is also same, but we need to start here, again we need to go back over. So if I draw this specific tree, so what all the n possible ways, so this is going to be the n possible ways using a TSP program, so where we are going to reach it now. So in this way, now I need to find what is going to be the shortest form here. So which is going to be the shortest way of using this. So first I will tell directly, because if I tell with the formula you'll get confused. So first I will be teaching you the direct method, like using the formula itself, even that, but that formula we are going to discuss again in the end of this session. So first we'll understand into a easier way. So imagine what is going to be the cost for the specific cost here. So the first cost here for the 4 to 1, if I wanted to go to the 4 to 1, if I just see 4 to 1, what is the cost here? The 4 to 1, the cost is, first I am going to select this 4, okay. So 4 to 1 here is the cost is 8, so I am just going to mention the cost is going to be 8 here. So 3 to 1, what is the cost for 3 to 1? So 3 to 1, the cost here is 6. So what is the cost for 4 to 1? So 4 to 1, again the cost is going to be 8. So what is the cost for 2 to 1? The cost here is 5, I am just going to mention here. Again for 3 to 1 the cost is 6, I will be mentioning. Again from the cost that is a 2 to 1 it is going to be 5, I will be mentioning over here, okay. So this is going to be the minimum cost for reading the vertex, that is 4 to 1. So whatever from the table is there, I am just adding the data towards it directly. So that is the next step now. So what is the cost for 3 to 4? The cost of 3 to 4 here is 12, right? So in this 12 plus what is the previous cost of the vertex, that is 4 we got, 8 we got, right? So we need to do 12 plus 8, that is going to be 20 over here, okay. This is how we are going to calculate. Again 4 to 3. 4 to 3 the cost is 9, so I am going to mention here as a 9, plus what is the cost of previous, that is 6, I am going to mention 9 plus 6 is going to be 15 over there. Again the cost of 2 to 4, the cost of 2 to 4 is 10, 10 plus 8, here it will be 10 plus 8, that is going to be 18. Again the cost of 4 to 2, cost of 4 to 2 is going to be 8. So 8 plus 5, that is going to be 13, that have been added. Again the cost of 2 to 3, so the cost of 2 to 3 is going to be 9. 9 plus 6 I am going to mention here as a 15. Again the cost of 3 to 2, the cost of 3 to 2 is 13. So 13 plus 5, that is going to be 18 over here. This is going to be the cost of it. Next again, so what is the cost of 2 to 3? So the cost of 2 to 3 is going to be 9. I am going to mention here as a cost of 2 to 3 is going to be 9. So what is the previous cost? That is 20. So I will be mentioning here as a 20. That is going to be 29. And 3 to 2. So the cost of 3 to 2 is 13. So I will be mentioning here as a 13 plus. That is we are having 13 plus. What is the previous cost of 2? That is 18. So 13 plus 18 we will be there. So then again we have a 3 to 4. So what is the cost of 3 to 4? So the cost of 3 to 4 is 12, right? Again the cost of 3 to 4 is 12. Plus what is the previous cost, that is 18. So I am going to mention, sorry, the 13, right? So in this way I am just going to mention 12 plus 13, and the 3 to 2 was 13 plus 3 to 2 was how much? 3 to 2 is 13, yes, plus the previous cost 18. So this is going to be there. Again 3 to 4, 3 to 4 is 12 plus what is the previous cost, that is 13. So that I have been written over here. That is the same thing. Then next, what is the cost of 4 to which is the cost of 4 to 2 and 4 to 3? We are having a 2 cost here, it is there. So what is the cost of 4 to 2? The 4 to 2 the cost is 8 here. So I am going to mention here at the 8. 8 plus, I will be mentioning here of the 8. 8 plus, okay, 8 plus what is the previous cost, that is 15. I will mention here as a 15, comma. Again 4 to 3. So again we have another 4 to 3 is 9. So that is going to be 9 plus what is the previous cost, that is going to be 18 over here. So 15 plus 15 plus 8 is going to be how much? 23. So 9 plus 8 is going to be something like 27, right? So in this, which is the minimum? The minimum is 23. So I will be selecting this over here, okay. Here 13 plus 18 and 12 plus 13, which is going to be the minimum? 12 plus 13 is going to be minimum, right? That is going to be 25. So this is going, I am going to select it over there, okay. The 25 I am going to select the minimum one. So this is how the things is going on. So again from 1 to 2. So 1 to 2, what is the cost? 1 to 2 we have the cost, that is 10. Okay, if I just go to the 10, so 10 plus 29 will be there, comma. Again 1 to 3, the cost is 15 here. So 15, what is the cost previously? That is 25. This is another one, okay, comma. Again that is 1 to 4. 1 to 4 the cost is 20. 20 plus what is the minimum cost? The of the previous of 4, that is 23. So in this, which is minimum? So if I just give it here, it is going to be a 39. It is going to be 25 plus 50, it is going to be 40. Again if I just make it, this is going to be 43. So in this case, which is the minimum over here? So in this case, which is going to be the minimum over here? So here I had another thing, I have measured it out here. So here you can see we got 29, right? So 2 to 3 we got 29. So again I have not checked for the 2 to 4 here. So here we got 2 to 4. What is going to be 2 to 4 here? The 2 to 4 is going to be 10, right? So 10 was there plus the previous node value was 15. So here it will be getting 25. So in 29 and 25 which is smaller? 25 is right. So I am going to mention 25 is smaller. So I'll be selecting here rather than 29. So I'll be marking here. Okay, this is going to be rather than 29. I'm just going to select here as, so I'll be selecting the entire thing. So rather than doing this, I'm just going to tell the specifically 10 plus what is the previous value, that is 25. So in this 10 25, 15 25, 20 23, 10 plus 25 is smaller. So basically we are going to mention here the source is going to be 35 is going to be the minimum over here. 35 is going to be the minimum. So I'm just going to highlight this thing. Okay. So 35 has been selected over there now. So now we are going to, this is going to be the minimum cost now. So now we got all the tree, we created a tree, we found which is going to be the shortest for the each vertex by comparing each another vertex with a very simple formula. So now we got this specific as a 35 now. Now which is going to be the 35. So basically we are selecting 35 has been selected now. So 35 is coming from which node? 35 is 10 plus 25 from which node it is coming from? Basically it is coming from the vertex 2, right? So again I am just going to highlight. Okay, this is coming from the vertex number 2 here. So again, so 20 is less or 15 is less. So 15 we have selected, right? So 15 is the lesser than 20 is lesser or 15. From here 2 nodes are going, which is less, which is going to be less. The less is going to be 15. So 4 will get selected. Again here we are having only one node, so it will be get selected and 1 will get selected. So I can say in a final way that what is going to be the path. The path I am just going to start from the vertex 1. So I'll be going to the vertex 2. So I'll be going to the vertex number 4. I'll be going to the vertex number 3. I'll be going to the, again I'll come back to the vertex number 1. So this is going to be the shortest path for you. So now what is going to be the value for it, right? When I tell what is the value of what is going to be the shortest path now? So it is going to be something like a 35. So what is with the total value we got? That is basically 10 plus 25. We are, in this way we are going to get the shortest path, that is from the 35 I'll be getting the value for us. It is going to get the value. So how? Basically you can see we need to calculate. That is going to be for the vertex number 3 to 1, 6 will there, and here 6 plus, again what happened here? So 6 plus we have the shortest value, that is 15, right? So after 6 plus, so after calculating this we got 15, right? So again 6 plus, after that I'll be getting here as a 15 plus, after 15 we got an around 25 here. So again after that the last vertex we got it here as, after adding 10 we got 35. So here how the shortest path is calculated from the vertex to the 1 to the again vertex number 3. We are having this specific path. I'm just going to highlight this as well. Okay, this is how going to be the shortest path for us. So 1 2 4 3 1 is going to be the shortest path for us. So this is the way we have understood using the specific program, using the specific, just normally we have understood. Okay, this is how the specific things works. Now I'm just going to make you understand with the tree part. Okay, so how actual using a formula, how actually it has been calculated. Okay, I'm not going to much take time much more. So you can understand this part or you can skip as well. So but if you want to understand with the formula how these calculations happens using a DSA formula, we have one specific formula for TSP. Using that formula how it has been calculated, you can watch the further session on this. Okay, I'm going to scroll a little bit down on it now. So now what I'm going to do here is, so here I'm just going to copy this entire formula. So I wanted this specific thing again to be used. Okay, so I'll be calculating this. I'll be control C, control C I have done. So now I'm just going to paste it over here. Okay, so now again I'm just going to make use of this specific graph for using that understanding. Okay, so I'm going to just scroll this towards this little bit right now. Okay, so yeah, so little bit I'll take it on the top. That's fine. So now we need to understand using this specific formula. Okay, so how the formula has been calculated, let's see that specific part now. So here basically I'm going to start the specific thing from here. Okay, so I'll just select the brush here. Specifically I'll be selecting black itself. Okay, I don't want to use any other color. So here I'm going to use this specific formula. The formula here is g of I comma s we are going to take. In that minimum we are going to take it. So where k belongs to the all the x. So here the formula here is c of I comma j and plus g of, that is k of s minus, and we are going to use the flower bracket over here. So where k belongs to the values such like 1, 2, 3 and 4 over here. So this is going to be the entire formula which we have been calculated onto the top. So we are going to find the minimum cost, what is the cost of existing and what is the cost of previous, that's it. Okay, so now if I take it here, so let's take the example over here. So if I just take here as a 1 here, okay, then if from the specific value that is 1 over here, so from the specific value that is 1, if I just calculate, we are getting here as a 2, right, and here we are getting here as a 3 and here we are getting here as a 4, right. So this is the specific thing we are getting it. So 1, 3 and specifically 2 over there, right. So in this just going to select the stroke razor, so I'm going to delete this. So we'll be selecting again point razor. So let me draw again neatly. Okay, so we have 1, 2, 3 over here. Okay, so if I calculate for the 1 here, so if it is going to be something, if I calculate the formula, so I'm going to just tell in the G of specifically 1, we are having a 1 here, right. In this, what are the rest of the element? We are having 2, 3, 4. These are the rest of the element is equals to minimum of. So in this, I'm going to tell C of, that is basically we are using the C of 1. So cost of 1, what is the cost of 1 with the element that is k plus G of, so what is the k value will be there. So what is the plus G of k comma, so k belongs to here, k is basically what, so what are the k value, 1 I have taken means what are the remaining value of k we are having, that is 2, 3 and 4 are the remaining, that is going to be the k values. Here k of basically, and I need to tell here what is going to be the S here. So S is basically the remaining element, that is 2, 3, 4. So let's tell 2, 3, 4 minus, and what is going to be the specific next here. So I'm going to make it as a k here. Okay, so this is going to be the k. So this is going to be evaluation of the formula for the 1. See, I have taken 1 as the 1 here, that k belongs to 2, 3, 4. So 2, 3 k comma, whatever the S value was there, 2, 3, 4 I have given minus k. This is going to how the evaluation of the formula happens over there. Okay, so again I'm just going to mention here for the C2 here. So if I evaluate C2 as into the another formula, so I'll just mention C of 1, 2. So when I'm taking as a 2, I need to take the previous node also. What is going to be the C of 1, 2 plus here I'm going to mention here as the G of, basically G of, in this I'll be selecting a vertex 2. The remaining elements are 3, 4 over there. So this is going to be there. Again for the vertex 3, so C of 1, 3 plus G of, so we are selecting the node 3 and what are the remaining element, that is we are having a 2, 4, right. So if I select 3, 1, 3 is there, 2, 4 is not there, so I'll be adding this. So when I select the vertex number 4, C of 1, 4, this is going to be there plus G of 4, we are selecting it. Again, what is the remaining element? The 2, 3. This is going to be the remaining element over there. This is how the things has been calculated. So we'll see how it has been calculated again. So now I'm going to mention from the 2 we are getting here as a 3. So again I'll be getting here as a 4, right. So I'll be mentioning as a 2, 3, 4. So again we have the same thing. I'll be adding 2, 4 here, and again I'll just add a 2, 3 over here, right. So this is going to be there here. So I'm going to mention here to here to here. So it's going to build 2, 2, 3. So again so I'll be mentioning here as a 2, 2, 3 over here. So I'll just mention 2, 2, 4 over here again. So again I'll just mention 2, 2, 3. So I'll be mentioning here as a 2, 2, 3 to 4. Again I'll be mentioning here as a 4 to 2. So again I'll be mentioning here as a 4 to 3 over here. Okay. So this is how the things is going to be there. Now let's try to evaluate the further 2 here. So for the 3, what is going to be the formula? So I'll be selecting C of, now what is the previous node, that is 2, right. C of 2 to 3 plus G of what is the vertex we have selected, that is 3. What is the vertex remaining, that is 4. So I'll be adding here. So again C of what is the previous vertex 2, 4 plus G of what is the vertex remaining, that is we are going to, which is the vertex we have selected, that is a 4, and what is the remaining. So 1, 2, 3, 1, 2, 4 is there, the remaining is going to be 3, right. So I'll be adding it over here. Again for the vertex number 2, so C of the vertex, now what is the previous vertex, that is a 3, right. So vertex 3, and what is the vertex right now, that is 2 plus G of what is the vertex selected, that is 2. What is the remaining vertex, 1, 3, 2 is there, so remaining vertex is going to be 4 over here. Again for same here, so C of the vertex previous is 3 and the selected vertex is 4 plus G of the what is the selected vertex, that is going to be 4. What is the what is the non-existing vertex, that is 1, 2, 4 is there, 2 is not there, so I'll be adding it over here. So for this specific thing as well, so it is going to be, what is going to be the previous vertex 4, so So what is the previous vertex? That is a 4, right? What is the selected vertex? That is 2 plus g of selected vertex is going to be 2, and what is the non-existing vertex? That is 1 4 1 4 2 we have. The non-vertex is going to be 3 over here. So again for this, c of what is the previous vertex? That is 4, selected is 3 plus g of selected is 3. So what is the non-vertex? That is not there. So 1 4 3 is there, remaining is not there, that is 2 over here. So this is what it is going to be, the specific formula. Okay, so after the specific number that is a 3, so this is how the specific things is going to be calculated. Okay, now we'll understand how the specific cost is going to be there. So here, and first and foremost, I need to find the two scenarios over here. So I'll be telling here for the first, let's see how we are going to calculate the cost now. Okay, so for the 3, how we are going to get the cost now. So 4 we are having, right? So for the specific 3, what is going to be the value for this? What is going to be the value for this? What is going to be the value? So what is going to be the value? And here and here. So this is the first value, I need to find it. Then what is the cost 2 comma 3? So cost of 2 comma 3 9. So these things I can get it from the specific graph itself, right? So all the graphs I can get it from the value from the graph. Now we need to understand how we are going to calculate this. G of 3 comma 4, G of 4 comma 3, G of 2 comma 4, G of 4 comma 2, G of 2 comma 3, G of 3 comma 2. Again, how we are going to calculate G of 2 of 3 comma 4, how we are going to calculate G of 3 of 2 comma 4 and G of 4 of 2 comma 4. So this is the main agenda now, calculation part, right? So I'm going to select the another color now. So let me select the blue color now. So let's understand how we are going to calculate it over now. Okay. So now if I further evaluate to this, so if I just further evaluate to this G of 3 comma 4 here. So here I need to first find what is the value of G of 2 comma 2 to the sink, 2 to the sink over here. That is, we are going to make it as a pi here. So again I wanted to calculate for the specific again 3 comma pi here. Okay, so again I need to calculate for the 4 comma pi. This is the main thing I need to first calculate. So 2 of 0, basically it is going to be something like it, you can treat it as what is the cost of 2 to 1, what is the cost of 3 to 1, what is the cost of 4 comma 1. So I can get this from the graph. So 2 to 1 is basically we are having as a 5. So 3 to 1 we are having the specific here as a 6, and 4 to 1 we are having the cost, that is 8 over here. So we calculated 5 6 8, we got it, right? So in this way I can calculate. Now again I am going to calculate G of that is 2 comma 3. So first I will calculate for the G of 2 comma 3. This is 1. Okay, so how we are going to calculate 3 comma 2? So what is the cost of G of 2 comma 3 here? So for the 3 we got already an element, that is 6, right? Plus, so we got the specific, that is 6 here. For the if you want to calculate the value of the flower bracket, you need to see the specific thing. If you wanted to calculate for the 2, right, so you need to look onto this. If you want to calculate for the 3, right, you need to look onto this. If you want to calculate for the 4 flower bracket, right, you need to look onto this specific formula. So in this I am going to, for the 3, what is the thing we are having? We already have a 6 plus 2 to 3. So 2 to now we need to, we have a 6 here, right? Now I need to see what is going to be the cost of the that is 2 to 3, right? So we are having a cost of 2 to 3. So here we are having the specific, that is 3. Now I need to basically find what is going to be the cost. So we calculated the specific thing, that is 9 over here, right? Sorry, the 6 here. So now how we are going to get this specific part for the 2? So here we are going to see, that is 2 comma 3. So what is the cost of 2 comma 3 is, that is 9, right? So I am going to mention here as a 9 here. So that is going to be how much? That is going to be 9 plus 6, that is going to be 15 over here, right? So this is how the things is going to be, right? So G of this is going to be 15 here. Okay, this is going to be the 15. The 3 of 2 comma 3, it is going to be 15. Plus what is the cost of 4 to 3? First cost of 4 to 3 is going to be 9 over here. So here it is going to be 24, like this, right? Again, let's do it for this one, 4 comma 2 now. So if I just show you what is going to be the cost of, first I will be saying here as a cost of 4 comma the flower bracket 2. What is the flower bracket of 2 we got? That is 5, right? We got it as a 5. Plus what is the 4 comma 2 cost? The 4 comma 2 cost is 8 here. So I am going to mention here as a 8. So I am going to mention here as a 5 plus 8, it is going to be how much? That is 13. So this is how the calculation is going to happen over there. Okay, so this is how the specific calculation you have to do it. For it I need to just pass the value. So let me show you for the another, that is a g of 3. Let's take it of a g of 3. Okay, let's take it of a g of 3, and let's make it as the specific 2 over there. So g of 3 comma 2 is going to be 13. So what is the cost we got for the 2? That is, we got it here as a 5, right? So here we are getting as a 5 here, right? So in this case, again I need to just calculate to the further g of, I need to tell 2 of, that is 3 comma 4. So it is going to be 25. Again, if I just calculate g of 3 of 4, that is going to be 8. So here I am going to just tell 3 of the remaining vertex here as a 2 comma 4. So here we are going to get here as again 25. Again, I am just going to calculate g of 4 of remaining vertex, that is going to be 2. So 4 of 2 we got it here as that is all 5 here, right? 4 of 2 and we are getting as a 5 here. So for the 2, the floor bracket we got is an element, that is 5. So plus again we need to just tell, if I want to calculate g of 4 and we will be having 2 comma 2, that is going to be 23. So this is how the specific things we are going to calculate. So after calculating c of 2 comma 3, c of 2 comma 3 we are having 9. So I'm going to just 9 plus g of 3 comma 4. G of 3 comma 4 is basically we are going to get it from the specific formula, that is going to be 8. So this is how we are going to calculate the specific further things. And here the cost of 1 comma 2, the cost of 1 comma 2 is going to be here, the cost of 1 comma 2 is going to be 10. Cost of 1 comma 3 is going to be here as a 9. The cost of 1 comma 4, it is going to be here as a 10 over here. So plus you are going to, whatever the evaluation of the formula you are evaluating the value, that you need to place it, and you are going to get the previous result over here. So here is basically it will be what is the minimum cost of, from the 2 to 3, what is the minimum cost we got, we are just going to add it here. And 9 plus what is the minimum cost we got from 2 or 4, this we are going to add it here. So this is how the evaluations happens using formula. So the formula you can remember, this is going to be the Minion formula, and the understanding part is similar as that we have understood in a very simpler way. So onto the term, how it is going to get evaluated and how the specific things is going to happen. So this is all about the traveling salesperson. In the next session, we are going to look on to the coding part of it. Okay, bye-bye.
Hey guys, welcome back to the section 7. So the travel salesperson problem we saw in the previous session. Now we are going to look on to the coding path for it using Java program. So let's begin with an example over here. So coming back to our travel salesperson. So this is what the travel salesperson which we have looked in the previously. So where we are using this specific formula, finding the minimum of c of I comma j and g of k and s of s minus of modulus of k, where k belongs to the value 1, 2, 3, 4, 5. So we found it how it started. Like basically I wanted to start from the source and reach back to the source. That was our travel sales problem. We start from 1, I need to come back to 1 again, right? So no matter how many stages we can go, like what all the permutations and combination. So here we need to find the what is the shortest path so that I can traverse all the nodes and come back to the same node. So it is what the problem statement which we have solved previously. So now we are going to look on to the Java program for the TSP here. I'm going to just create one new class. I'm just going to create the specific class name here as a traveling salesperson. So I'm going to tell here as a traveling sales person. Okay, so I'm going to just traveling sales person as the program name here, the specific class name. So I'm going to just click on to the finish over there. So here now let's see how we are going to use. So here we are going to import one of the packages which we are going to use here as an import the specific java.utils .stars. I can just import all the packages. I basically use the arrays for that, and I need to declare the private static variable for it. So for the storing a maximum value for which the values are not given. So I'm going to tell here as a public static final, that is a int of and I'm going to install as an int of inf, that is going to have the integer dot max value over here. So I'm going to just store the max value into the inf over there. So then I'm just going to create one function to find the shortest path, that is a traveling salesperson. So I'm going to tell here as a public static, this is going to return you the path. What is the path? So it is the function name. I'm just going to return as a TSP. So basically it's take first as an argument I need to pass the what is the graph here, right? I need to just pass the graph graphs over here. That's what we did, right? We just created a specific graph for it, and we need to pass the what is the values for what is the cost, what is the cost is being there for the graphs here, right? So two things we are going to pass it. So first I'm going to just pass the specific graph here. So int of graph it's been taken here. So I want to just see what is the length of the graph. So the same thing which returns which we have seen into the multi-stage graph, the same program repeat. So here I'm going to tell as I need to find the what is the graph dot length is there. I'm going to store it into the here. Then I need to create the specific another one. I need to create one matrix, so a table to like what is the cross of matrix. So here we have created the table, that is the 4 cross 4 matrix table to store the value. So same thing here, we are just going to create it. So I'm going to mention here as a dp as the variable name, and I'm just going to create as a new, and I'm just going to tell as an int of n for the n cross. And what is the next value should be there? It should be basically should be 1 and double lesser than n. What is this? It creates the what is the next here, okay, 4 cross 4 like that, okay. And once we have created this dp over here, we need to initialize all the array. So I need to initialize this entire array, right, all the entire array with the maximum value. So later we'll update that values over here. So we are initializing the dp array with the inf value here. So for that I'm going to run a loop here. So for loop I'm going to tell here as a for int of for all the rows, for this specifically all the rows, take the dp as every scenario and just fill out that value. So I'm just going to tell here as a arrays dot fill method, so where I'm just going to fill out the row, and I'm just going to pass the what is the inf value, maximum values we are just passing to store it over there, okay. So this is what we are going into here. So now basically I wanted to start from the city, right. So here we need to tell from where you are starting it. So I wanted to start from the source, right. So we need to give which is the source is going to be there here first. So for that I'm just going to initialize the specific which is going to be the first city basically, right. So I'm going to tell from the array the 0th of 1, 0 of 1 over here. So the 0 of 1 that initially start with 0 over here, initialize with 0 over there, the value starting the specific city. We are just starting from the city. So I am starting from 0 to 1. So again I want to come back to the 0 to 1 itself, right. So now what I am going to do here is I need to iterate all the subsets of the cities over there. So I need to iterate towards all the subset of the cities. I'm going to run here as a for loop. I'm going to tell here as an int, that is a marks I am giving is here as a I. Okay, start from here, and I'm going to give it here as a marks is lesser than 1 is double lesser than n. This should be get satisfied, and plus that is a mask, that is mask value should be increment with the plus or equals to 2 over here, okay. So this is going to be the loop here, and I'm going to have an inner loop as well. So here int I'm going to tell as a int u is equals to 0, then u value should be lesser than n value, and u plus over here. So it's going to be the inner for loop. Then I'm just going to check one condition, if the specific city is reached or not, right. If there is a mass, if there is a city, right, and specifically, and if it is satisfying 1 double 1 lesser than or equals to u value, so it means like we are reaching to the next node. If it is not equals to 0, basically there is existing a city and the cost is not equals to 0, okay. If these conditions get satisfied, what we are going to do here is we are going to run the another loop over here. So we are going to just tell here as if this condition is satisfied, now right, I'm going to run the another loop over here. I'm going to type it here, not going to type, I'll just simply write it here like this, okay. So here I need to start with one basically, okay. Here we are telling if all the conditions satisfied, if the mask is basically, if they basically entire all these things is to travel the entire path, cell 1 2 3 4 1 2 4 5 6, that should be existing your data, and along with that we are checking the is not equals to inf value. So if we have updating the value, then inf value will get updated. If there the value is not updated, then only we need to initialize it here. So the overall formula for this, what was the formula? So we are using the min of c of I comma j, right. So you can see here we have used here. So overall formula, all the conditions satisfied. I wanted to find the minimum value from the dp of the vertices and the j value, the new city, and dp of u of y plus graph of u and v over here. This is going to be the main formula for iterating all over the cities and updating our initial array over here, okay. That is going to be the minimum things over here. So now I need to find the minimum cost to complete the tour here. So we are just traversing, and we are just updating the values here. So here you saw how we traveled it, right. So we were just traveling from here, like basically we traveled from here to here, here to here, here to here. Again we just like this, we went like this in this specific path. After pathing it, now I need to find which is going to be the minimum, right. So for that we need to write another function. So that function name I'm just going to write it here. So this is going to be the function find the minimum cost to complete the tour now. So the minimum cost we are giving again inf, and we are just checking which is not equals to inf value. In that case we can get the which is going to be the minimum way over here, right. So when I try to imagine, so if I just go to here, if I see here and here, if I just come here, right, we will be having a two paths here, which is going to be the minimum, So that I'm just going to find it, and I am going to update that specific things over here now, okay, in the minimum cost data. Then we are just going to return the what is the minimum cost we are having it here, okay. So it is going to be the scenario. Now let's try to give an example for the specific thing, the specific graph over there. So we are going to tell here as an int of I'm going to give the specific int of the graph. So we are going to give g or fh graph here is equals to, so here inside this graph I can just give what are the values you want, okay. So if you wanted to give the values, you can just give it. So you can just have a look on by giving the example whatever we have passed here, 0, 10, 15, 20, 5, 0. In the place of 0 you need to give inf over there, okay. So you need to give that specific path, then you will be getting the shortest path over here. So let's try to give the values. I'm just going to give here as inf comma 10 comma 15 comma 20 we are giving this, and put the comma, and again I need to pass the another one more parameter, that is I'm going to tell as a 10 comma inf comma 35 comma, again we are passing the 25 as the next parameter. Then next we are just passing next another things, that is we need to just pass here as the 15 here, and 35 I can pass anything whatever you feel good, you can just pass. inf is the next row, and the 30 I'm going to just pass it over there. So again I'm just going to pass the last values, that is 20 comma 25 comma 30 comma inf over there, okay. So I'm just going to pass, this is going to be the last value over there, okay. So once I have just passed this element, I'm just going to put the colon here. So once I pass this, now I'm just going to find what is the minimum cost. I'm going to tell has a int of min cost is equals to, so I'm going to pass for the TSP, I'm going to just pass the graph over here. So I'm just going to pass the graph for the TSP function, I'll be returning some value. So once I just try to print what is going to be the shortest minimum cost, I'm just going to tell here as a minimum cost is going to be the minimum cost whichever we got it over here. So I'm just going to paste it. So once I execute the program, so after this evaluating the entire program, you can see here it is giving me into the negative number here, okay. So there is some mistake. So let's see what is the mistake. So it should not give me into the negatives here, right? So let me check what is the error over there. So I'm just going to open the trial success span person here, and we'll see what is the bug we have created here. So here we are getting as the output 80. So basically what I did here is this integer max value is overlapping. So I'll be giving some large number rather than giving that very large. So after that I am getting the specific input output as 80 over there, okay. Now let's try to give this here. So 10, 15, 20, let's give here as a 10, 15, 20. Yes, this we have given same, right? 10, 30, let's see 10, 35, okay. So 5, 9, 10, right? So I'm going to give it here the 5, and here I'm going to make it here as a 9, and I'm just going to tell here as it is going to be 10 over there. So then what else we had? 6, 39, 12. So we are going to maintain this is going to be your 6, and it's going to be your 13, 6, 13, and it is going to be 12 is an input. Then for the last value, then that is 889, right? So we are going to give it here as a 889. So let's see whatever we have solved that we are going to get it as a correct or a wrong input, okay. So once I execute this program, I got the minimum cost is 35. If I come here, guys, you can see whatever we have solved it here, that was I'm absolutely perfect. So you can see I'm getting as a 35 here. So this is how the specific program for the traveling salesperson. So here we are evaluating. I know this little bit complex where we are having two for loops, if for, if, end here. This basically checks the graph's value one by one, how many iterations are there. Then we are going to apply the formula. So the overall, the main backbone of this program here is this specific formula, finding the minimum cost over there. Okay, this is the backbone of this, and this is the next backbone of this. The same thing. These and these are basically same. And here we are just checking the data here. That's it. Okay. So this is how this specific traveling salesperson's program is there. So I'll catch you with the next session. Take care. Bye bye.
Hey guys, welcome to section 8. So let's see the greedy method. So we saw all the dynamic methods. So where we are going to see like how we are going to take a specific decision based on the specific stage. So in this specific greedy method, we already know the difference here is the decision is already fixed. We are going to follow the same specific methods over there. So in the greedy method, we are going to look onto the two major concepts, that is the Huffman's coding and job sequence. So first let's begin with the Huffman codings. We'll understand with the specific example over there. So coming back to the specific notepad over here. So I have created one specific box. So where we are going to take one example and understand here. So here imagine we are going to send this specific message. I wanted to send this specific message, that is B, C, C, A and B and so on. So whenever I send this specific message, whenever I am just going to send this specific message from the source to destination,
there are the two things that is going to take place, that is the encoding plus decoding, right? So whatever the when at the sending place it is going to encode, at the receiving place it is going to decode over there. Okay, so this is the encoding and decoding happens. So from the client to server. So basically imagine when I am sending the specific message to the client to the server over here. So imagine in this specific it is each letter is going to take the 8 bits. Okay, imagine the each letter is going to take 8 bit. So I'm going to mention each letter is going to take the 8 bits over there. Okay, and what are the total letters here? So what are the total letters? Here it is having 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So we are having a 20 letters that is going to take the 8 bit over here. So it has to take 160 here, right? It is going to take the 160 bits of data to send the specific message from the client to server over here. So now we are going to make use of the Huffman's coding, and we are going to reduce it to the lesser number of bits. Okay, so this is the normal way. Okay, if I wanted to send 20 message, each letter will take 8 bit. So using normal method, we are going to use 160 bit, right? So it can be anything, like whatever it can be, that is A is the specific ASCII value. It can be what is the ASCII value of A, that is 65. It is, if I just tell what is the code, it will be 01000001. So this is going to be the ASCII code for it. And for the B, that is going to be a 66. The ASCII code can be 01000010. It is going to be the ASCII code for the specific character that is going to be for the B over there. So in the same way, it is going to calculate for the every letters, and it is going to be having over there. So imagine we are going to have, just I'll tell you in the normal way in 5 minutes, then we'll look on to the actual method over there. So here we have the specific characters, then we have something here as a frequency. Here we have the specific code over there. Okay, so how many characters we are having right now? We have the 5 characters, that is A, B, C, D and E. So these are all the existing character where we are having it. So A is repeated for 1 2 3 times, and B is repeated for 5 times, C is repeated for 6 times, 4 times, and E is repeated for 2 times. So this I have calculated. You can calculate how many times it is there. And we have a codes, right? So imagine it can be a code 000001010001111 something. Okay, I'm just giving a random thing right now. I'm not giving the actual one. Okay, so imagine for right now it is taking a 3 bits here. So it is taking the 3 bits here for the in the 8 bits, and we have reduced to the 3 bits over there. So when I say 3 bits for each letter, for the 20 specific character, it is going to be how much? It is going to be the 60 bits, right? It is going to be the 60 bits. It is only for the encoding. So for the sending purpose, we are using 3 bits, and that if I calculate it to the 20 character, it is going to be the 60 bits, right? 3 into 20, it is going to be the 60 bits for encoding only. It is only for encoding. Basically, I can just tell at the time of sending the message, at the time of the specific sending the message over here. So now we wanted to have another, for the decoding also we need to have, right? So again we have the specific 5 characters at the place of decoding as well. So at the place of 8 coding character, it is going to take 8 bits. It is going to be taking 8 bits over here. So while decoding, I'll be setting right here. You can see for every, while sending, we are assigning every character here as a 3 bit. While decoding, what we are going to do for the 5 characters, we are going to take only the 5 specific character, and we are going to use the 8 bits. Okay, while decoding it. Okay, so it will be like 5 cross 8, that is going to be the 40 bits over there. Okay, so it is going to be the 40 bits over here. So that is going to be for the decoding purpose. Plus again I am just going to tell, we have a 5 character, so we are having a 3 we are going to again we are going to make use of this 3 coding, right? We are going to make use of a 3 coding, that is going to be the 3, that is going to be 15. So it means 40 plus 15, that is going to be the 55 over here. So in this is going to be happen at the place of decoding. So this is going to be happen at the place of decoding. While sending, what we are going for all 20 character, we are sending decode. While decoding, we are just taking the 8-bit character of 5. Again we are going to take 3-bit character of the 5 characters over there. And when we add this both two, that is going to be 60 plus 55, we are going to have around 115 bits, right? Almost we have reduced it to this. You can see when I try to do in this method 160 bit, but here we are doing with the 150 bit. So here the specific we are doing with the more optimal way. So we are going to use the more optimal ways of solving this specific program. So now we are going to understand the actual program. So this is just an example I have given. Okay, now we are going to see the actual program of it. So let's see how that is going to be the actual method, how we are going to solve the Huffman's coding. So here we have just created another table. So for this table I am just going to copy this message here. So I'll be just control I'll just tell copy, I'll just paste it over here as well. Okay, so I'll just tell paste, I can paste it here. Okay, I'll just spell control V. Okay, here I am unable to copy. So here I have the message, right? So I'm going to just tell here, as if I just go to here, it's not taking it. Let me control get it over there. So I'm going to mention it here. So I'll be just telling here the control V over here. Yeah, it has been copied. Okay, so after here, so for this specific message now we are going to make use of a real problem statement. Now we are going to solve it over here. So first and foremost we are going to just tell the table. So we are having the specific characters here, and here how much count we are having it, and what is the code we are going to generate. So this is a real-time code we are going to generate now. So the characters we are having here as a character, B character, C character, D character, and E character. So how many times of A is repeated? 3 times. It is having A 5 times. C is repeated for the 6th time. D is repeated for the 4 times. E is repeated for the specifically 2 times over here. So now we are going to start from the specifically root, and we are going to go on like that. Okay, so now first I need to tell here a specific, like I'll just create one specific array here. So we have a specific array, right? That is 2 4 6 5 3. So what all the numbers are there, I'm going to write it into the ascending order. So I'll just tell here as a 2 here. So I wanted to create a good thing. Let's see, I can able to get a box here. Okay, I'm not getting. Okay, fine. So we are having a specific 2 here. So we are going to tell here as a specifically 3 here, and we have the specifically that is a 4. Okay, and we have the element that is 5 here. Then we have an element that is 6 over here. Okay, this is going to be, or these all the specific things we are having it. So here I'll just erase this specific thing. So let me use the point eraser. So we're going to erase the extra line, and I'm going to erase this as well. Okay, so I'm going to tell here we are having the element that is 2 over here as well. Okay, so 2 3 4 5 6 we are having it here. So now in this specific, what is the 2 here? 2 stands for a character that is E here. 2 stands for the character that is E, and 3 stand for the specific character count that is A. 4 stand for the specific, I don't know why it is creating this square. Okay, so for the 4 we are having that is a D. For 5 we are having that is a element B. For a 6 we have an element that is 6 3 here. Okay, now I'm just going to tell here we need to draw one specific tree over here, right? We need to draw one specific tree here. So what is 2 plus 3? 2 plus 3 is going to be 5 here, right? So I'm just going to tell here 2 plus 3 is going to be 5. So I'm just going to connect here. I'm going to connect it here to here. Okay, so I'm going to tell 2 plus 3 is going to be 5. We have been connected over here. So next I'll take again the 4 over here. So what is the 4 plus 5? It is going to be how much? 4 plus 5 is going to be 9, right? I'm going to connect. We are getting the 9 from adding these 2 things over here. Okay, so we are getting this 9, adding this specifically 2 things over here. So I'm going to just mention here 4 plus 9 over here. Okay, then next again, so we are having the element that is 5 here. So 9 plus 5 is how much? 9 plus 5 is going to be 14, right? And 9 plus 5 is going to be 14, and 5 plus 6 it is going to be 11. Again 9 plus 6 it is going to be around 15. So which is lesser? So if I add 5 6 it is going to be less, right? So I'm just going to add that is 5 plus 6, that is going to be the 11 over here. So I'm just going to add that is 5 plus 3 6 is going to be 11. So I'm just going to add it over here. So now we are having a only left out one thing, that is we are having a left out only one thing, that is 9 plus 11 we are going to mention here as a 20 here. So we got the element that is 20. So we got an element that is 20 over here. So we are going to connect from here to here, and I'm going to connect it from here to here over there. Okay, so here we have been connected. So now after connecting we got the specific tree now. So we got the specific root. So this is going to be the root, and whatever the left hand side is there, just make it as a 0 and 1s over there. Okay, so this is going to be 0 1 0 1 0 1 and 0 and 1 over here. So we got the specific bits over there. So now we got the specific bits. So what are the bits we got? We need to write it here. So for the element, what is the bit we are having it? 0 0 0, right? So from the element, the box to the root we need to tell. So here I'm just going to tell 0 0 0 we got for the element D. So for the A 1 0 0. So for the A that we got it here as okay, from root to the box I need to go, not from the specifically box to root. So from the root to box we need to go. Okay. So for the element A we have 0 0 1. So I'm going to mention here as a 0 0 1. Again for the element D we have 1 0. So for the element Z 0 1, right, 0 and 1 for the element D. So I'll mention here 0 1. And for the B we have again that is 1 and 0. For the B we are having that is 1 0. For the element C we are having 1 1, right. So you can see we got the real time what are the bits we got it here, right. So now we are having this 3. So we are having 1 2 3. So I'm going to mention 3 cross 3, that is going to be 9. So here we are having a 2 bit. So I'm going to use 2, and here what is the count? 5 times I need to use, that is going to 5 2s are 10. Again we have an 11 and 6 here, right. So that is basically not 11, it's 2 bit, right. So 2 into, we are need to use it for 6 times, 12. Again we have 2 into 4 times, that is going to be for 8. Again we have 3 into 2 times, 3 bits into 2 times, we are going to have a 6 over here. Now I need to calculate this. 9 plus 10 is 19, 19 plus 22 is going to be 31 plus 39 plus 45 here. So we got the 45 bits here. So you can see the 45 bits we are going to use for the encoding purpose. So for the encoding we found the specific way. Okay, we are going to use the 45 bits for the encoding purpose. So that's great, right. So using this Huffman coding, this method, we got the specific things over there. Now we need to do for the decoding purpose. So now how we are going to do it for the decoding is the question now. So for the decoding, how many characters we are having? So I'm going to mention here as for the specific decoding purpose, we are having the 5 characters, right. We are having this specifically, that is 5 characters over there. So imagine for the 5 characters we are going to use same bit, that is 8 bits for it. Okay, so it is going to be 5 into 8, that is going to be 40 bits over there. So we have a 40 bits. So along with this 40 bits, I wanted to, along this this specific 40 bits, I wanted to count how many bits we are using here. So 1 2 3 4 5 6 7 8 9 10 11 12. So the 12 bits we are going to use from this specific code. So we are going to use 40 plus 12. So this 12 is coming from the encoding, these bits which we have calculated. So that is going to be how much? 52 over here. So this is going to be the for the decoding purpose over here. So the encoding plus decoding. So I need to just tell here as a encoding plus decoding. How much we got? That is for the encoding we got it has a 45, plus for decoding we got it as a 52. So the total bits required for the encode and decode, that is going to be the 72 bits we need it. So we need to get the 72 bits over here. So this is going to be the final bits for transferring the message from 20 character that is required, that is 27 bits over here. So I can say this is going to be the optimal, this is going to be the optimal solution to send the specific message from the source to destination over here. So this is all about the specific Huffman's coding. So I hope you have understood. So in the next session we are going to look onto the Java programming part for it. Take care, bye bye. Hey guys, welcome back to the session 36. So let's understand the Huffman's coding example. So let's begin with the session over there. So all in the previous session we saw how the Huffman coding works. Basically it is a kind of a algorithm which converts for the encoding and decoding purpose with the help of a tree, and which gives the optimal solution over here. So it's going to be in this format over there. So it's kind of a very large program. So I'm going to avoid to type here, so because it's going to consume a lot of time. So we are going to understand the specific code here. Okay, so here I'm just going to create the specific class name here for the Huffman's coding. Here is I can just make it here as a Huffman coding over here. Okay, Huffman coding. I'm going to create this specific static class for it. Just finish it off over there. So here we need to import, we are going to use a lot of Java packages here. So the packages which we are going to use here is a comparator, hashing map, we are going to use maps, and we are going to use the priority queues over here. So all the packages we are going to use, that's comparator, that's basically and we are going to use the next, that is hashing map, then we are going to use maps here, then we are going to use the priority queues here. So the priority queues we are going to discuss into the next session, in the coming session, there how that's the priority queue works as well. Okay, So here we need to create one specific class node to represent the Huffman's tree. So that is going to be, we are going to have some reference tree, right? So for that I'm just going to create one class. To create a tree, we are going to have a class node over there. So this specific node has the specific characters. So char of ch, there will be a character ch here, and I'm just going to declare what is going to be the frequency of it. Because for eq is a frequency that declares a 0 and 1, right? And we will be having a left and right here, so I'm going to tell here as a node of left comma right here. Okay, this is going to be that. Then again I'm just going to initialize the constructor for is whatever the char of ch will be there, that, and for the frequency I'm going to tell as int of frequency over here. This is going to be the stuff. So I'm going to just initialize, that is this dot ch, that is equals to ch, and again this dot frequency is equals to frequency over here. This is going to get initialized over there. Okay, so then we are just going to create another multi constructor over here. If we are having a 2 parameter, initialize to 2 parameter, and if you are initializing for the frequency left and right, I'm just going to tell here as a int of frequency comma node of that is left comma again that is the node of that is right over here. Okay, so here we are just going to initialize again, that is this dot frequency is equals to frequency, and this dot left is going to be left is equals to left left over there, and again this dot right is going to be right over here. We have initialized it over here. Okay, so this is, I'm just going to make it as the static class over here, static class, that is going to be the for the node over there. So we are having it initialize it over there. Okay, so once we have done, once we have a class, I think, yeah, so I'll just make it here as a so like the static class, sorry. So this is going to be this class of it. Okay, so now let's try to initialize the next part of it. So this I can just put it inside the program. So I'm going to put this specific thing inside the program over into the Huffman's coding over here. Okay, so it's going to be one specific class that creates the node over here. So once it is done, so once this specific class we have created, now we need to create the comparator for the queues over there. So for that I'm just going to create another class, comparator priority queue. So for the class Huffman's comparator is a class I have given. So we are just implements the comparator. So basically this is going to compare the one node with it, another node, that is basically comparing the two specific nodes of the frequencies over there. That is where we are going to use the comparison over there. Okay, so once we have used this specific class implements it, so next we need to generate the Huffman's codes for the Huffman's tree over here. Okay, so next we are going to write the code for generating the Huffman's code for the Huffman's tree. So here I have created another method, that is the private static void generates, it basically generates the code. Basically here we are all is about to generate the code for the every character, right? So we are generating the code for this function generates the code. It basically takes the root and what is the string value, and it takes the mapping and what are the Huffman code we are going to tell. So if there is an empty, if there is a no root, it is going to return. If there are some root and we have a left and a right trees, we are just going to check if the root dot left is equals to null, or a root dot right is equals to null. So if this condition satisfied, we are just going to tell only we are having a root over here. Okay, if there is a leaf node, is root is only the leaf node again. So or else what we are going to do, we are going to generate the code here. So we are going to generate the specific code. We are going to call the same method. I am going to pass the left value for the all the left node. We can see we for the all the left we are just making as a zeros, right? And for the all the right values we are marking as the 1 here, right? So that is what we are generating here. For the left, mark it as a 0 Huffman's code, and make it for the right, for the 1 you can just mark it and just pass it to the Huffman's code over there, right? It is for the specific next function over here. So once we pass that, we need to build the Huffman tree to generate the Huffman code now. So we are just checking here. Now we are going to build the trees over here. It's going to be a pretty much long for this. So let me paste and explain you the code. So here you can see we are generating the Huffman tree and generate the Huffman, that's generates the Huffman's code over here. So we are using the mapping here and the Huffman tree, whatever we have generated. So we have created one hash map, right? Then whatever the character we are having, right? So imagine for the 3 character 0, 1, 2. If there is a 3, we need to mention how many characters are there, how much count is there. We need to make it as the 9, right? So the same thing we are doing it here. We are going to check the character and we are going to pass. We are going to get this, what is the text of the character, and we are going to check if it is existing 0 and just make it with the 1 over there. And we are going to create a priority queues to store the nodes into the Huffman's tree. We are just creating using a priority to create stores the Huffman's tree over there. And after that we are just mapping for the left specific characters, and we are mapping for the right, we are mapping only for the one node until the queues value becomes 1, right? So here what we did, we are going to start from basically we saw, right, we are going to, if we start from here, we'll just map it over here, and we are going to count the letters, and we are going to see what is the bit. And for decoding purpose, the same thing we are going to do it. Just we are going to tell how many characters are there and what is the number of bits it is using it over here. So here all the data we are just storing inside the priority queues, and where we are going to map the frequencies of nodes, and we are going to get the data, and we are just going to add that things over there. So we are going to iterate the every left and right nodes from here. So once we iterate, we are going to do what, we are going to remove the highest priority nodes, and once we done, we are going to just store it over here, right? So then here it is returns the root of, which is going to be the root of the tree. Then once we are getting, we are going to traverse from the root to bottom over there, which is going to, what is going to be the string for it. Okay, that and it returns the what is the Huffman's code over here. See here the codes we are going to generate it using the mapping priority queues and this concept. We are not going to give default values like that. It creates automatically from the specific scenarios over there. Okay, so here we are getting no encoding of Huffman's is accessible new Huffman's comparator. Okay, so once we have done, we are going to we need to write a functions for encode and the decode purpose. So let's write the function for the encoding and the decode purpose. That is going to be a very little long program. This is actually just I wanted to show you a picture how it is going to be there. So that's for that purpose we have initialized this. So you can see this is basically this going to takes the string text, map it with the Huffman's code. It creates the encoded text here. It's basically map for the all the characters, and it generates the what it's going to get the code from the for every character, and it is just going to store it into the encoded text. That's it, and it is going to map with the toString. And for the decoding purpose, again same thing happens. Takes the encoded text from the root, and we are going to create a decoded text something like this, and we are going to take the every text, and we are going to apply the decodant and see which is the left and right, if it is equals to 0 or not. If it is the case, we are going to store it, and we are going to just decode the text, and we are going to store it into the decoded text over there. So it is again, it is going to return you string. Encoding is also going to return you string. So whatever the message has been sent, it has been properly encoded and properly decoded. This is the two functions which we are having it. The major function here acts like the Huffman's code which we have created onto the top. That is going to be the scenario for it. Okay. So once we have done, now let's try to pass one data, and let's see how the output is going to be there. What is the encoded text and what is going to be the decoded text for us. So here we are going to pass some string values and call the method. So inside the public static void main, I'm going to tell a text string is a Huffman code is a data comparison algorithm. We are just calling a methods here. We are going to build the Huffman tree and generate the codes first. Then we are going to print all the codes we are having for the trees. Then we are going to see what is the encoded input text, and then we are going to see what is the out decode the specific things over here. So here we are just telling here as a node is equal to bit Huffman's tree over here. Okay, something we have missed it, I guess. So let's see what we have missed it over there. Yeah, so actually I just saved again properly, so it has been coming properly. The error has been gone. So you can see here the Huffman codes or it has created for this created the Huffman's code here. Let me put it here into the left hand side of it. So you can see it has been created the specific Huffman's code for the every characters, and it is a encoded text for it. This is a code which we have generated, and after generating the code, you can see after again while decoding the Huffman code is a data compression algorithm. So you can see so beautifully it has encoded the codes and generates the code, and it is giving the decoded program for us for the Huffman's problem over here. So this is how the things is going to be there. So I hope you have understood, and I know it's very pretty high level understanding for this program which checks this the data. So basically the overall thing is for encoding and decoding purpose, the Huffman's code, whatever we have learned, based on that we have written the code for it. Okay, take care, bye bye.
Hey guys, welcome back to the another session of this particular section. इस सेशन में हम बात करेंगे SQL एंड नो SQL डेटाबेसेस के बारे में, जहां पर SQL के लिए हम कंसीडर करेंगे MySQL को और नॉन SQL के लिए कंसीडर करेंगे MongoDB को। तो सबसे पहले ये समझते हैं कि डेटाबेस हम किसे कहते हैं और इसकी यूटिलिटी क्या है। तो जब भी हम किसी भी एप्लीकेशन पे काम कर रहे हैं, चाहे आप वेब डेवलपमेंट से कर रहे हो या आप किसी दूसरे डेवलपमेंट स्टैक का यूज़ कर रहे हो, डेटा एक बहुत ही इंपॉर्टेंट चीज़ है। अब डेटा जो भी हम यूज़र से कलेक्ट करते हैं उसको हमें कहीं ना कहीं तो सेव करना होगा, या फिर जो डेटा हमें यूज़र को दिखाना है हमारी वेबसाइट पे, हमारे एप्लीकेशन में, वो डेटा भी हमें कहीं ना कहीं स्टोर करना होगा। तो डेटाबेस ओवरऑल जो कॉन्सेप्ट है वो हमारा पूरा डेटा के अराउंड रिवॉल्व करता है, जिसका सिंपल सा मीनिंग है कि डेटा को प्रॉपरली सेव करना और उसमें ऑपरेशंस परफॉर्म करना। अब सेम चीज़ तो हमने डेटा स्ट्रक्चर्स में भी पढ़ी थी कि डेटा को स्टोर करना और उस पर ऑपरेशन परफॉर्म करना। तो ये चीज़ डेटाबेस से कैसे अलग है? जब तक बात डेटा स्ट्रक्चर हमारा एक कॉन्सेप्ट है कि किस तरीके से हम डेटा को स्टोर करेंगे, बट डेटा को स्टोर हम एक्चुअली में कहाँ करेंगे, उसमें हम ऑपरेशंस एक्चुअली में कहाँ करेंगे, वो हमारा जो कॉन्सेप्ट होता है उसे हम बोलते हैं डेटाबेस। सो डेटाबेस का मतलब है कि डेटा को एक प्रॉपर वे में अपने पास स्टोर रखना, जो भी यूज़र का इंटरेक्शन हमको अपने एप्लीकेशन में करवाना है, जो डेटा उसको दिखाना है या जो डेटा उससे हमें कलेक्ट करना है, उसको अपने पास एक जगह सेव करना और उस पर ऑपरेशंस परफॉर्म करना। ये हमारा जो पूरा कॉन्सेप्ट है, इस कॉन्सेप्ट को हम लोग बोलते हैं डेटाबेस। अब हमारे पास जो डेटाबेस हैं वो दो टाइप के होते हैं। एक डेटा टाइप हमारा होता है एसक्यूएल और एक डेटा टाइप होता है हमारा नॉन एसक्यूएल। एसक्यूएल नॉन एसक्यूएल में अंतर ये है कि एसक्यूएल हमारा स्ट्रक्चर्ड होता है और नॉन एसक्यूएल हमारा स्ट्रक्चर्ड नहीं होता है। वो फ्री होता है किसी भी टाइप ऑफ डॉक्यूमेंट को रिसीव करने के लिए। इन सभी चीज़ों को फर्दर डिटेल में पढ़ेंगे। सबसे पहले स्टार्ट करते हैं हम लोग एसक्यूएल को समझना कि एसक्यूएल क्या है और एसक्यूएल क्या नहीं है। तो एसक्यूएल का मतलब होता है स्ट्रक्चर्ड क्वेरी लैंग्वेज। इट इज structured query language. It is used for access and manipulate the database. तो structured query language हमारा ये एक बेसिकली लैंग्वेज है जो कि हमारी एक हेल्प करती है डेटा को स्टोर करने में, मैनिपुलेट करने में, जो कि हम एक डेटाबेस में स्टोर करेंगे। अब डेटाबेस कौन सा होगा? वो हमारा होगा माई सीक्वल। तो माई सीक्वल एक हमारा डेटाबेस सर्वर है जिसमें एसक्यूएल एक लैंग्वेज है जिसका यूज किया जाता है उसको ऑपरेट करने में। जैसे कि पाइथन आईडीई हमारी एक लैंग्वेज की आईडीई है जिसमें हम लोग पाइथन लिखते हैं। सेम तरीके से माई सीक्वल हमारा डेटाबेस सर्वर है जिसमें हम एसक्यूएल लैंग्वेज यूज करते हैं। अब एसक्यूएल कर क्या सकता है? तो एसक्यूएल कैन एग्जीक्यूट क्वेरीज अगेंस्ट अ डेटाबेस। जो भी आपने डेटाबेस बनाया है, जो भी आपने इंफॉर्मेशन अपने पास अपने डेटाबेस में सेव की है, उसमें क्वेरीज को एग्जीक्यूट करना। क्वेरीज को एग्जीक्यूट करने का मतलब है उस पर ऑपरेशंस परफॉर्म करना। अब वो ऑपरेशंस आपके हो सकते हैं कि आपको डेटा को रिट्रीव करना हो सकता है, आपको डेटा को इंसर्ट करना हो सकता है, आप डेटा को अपडेट करना चाहते हैं या आप अपने डेटा को डिलीट करना चाहते हैं। तो डिफरेंट डिफरेंट टाइप्स ऑफ ऑपरेशंस हैं। इंसर्ट करना हो गया, अपडेट करना हो गया, जो डेटा आपने रिकॉर्ड बनाए हैं उसको डिलीट करना, या फिर एक नया ही डेटाबेस बनाना, एक डेटाबेस में अलग अलग टेबल्स बनाना, है ना, क्रिएटेड सॉर्टेड प्रोसीजर्स इन डेटाबेस, प्रोसीजर्स को बनाना, व्यूज को बनाना, परमिशंस सेट करना कि किस डेटाबेस को कौन सा यूजर एक्सेस कर सकता है, कौन सा यूजर एक्सेस नहीं कर सकता है। तो ओवरऑल एसक्यूएल एक ऐसी लैंग्वेज है जिसका फुल फॉर्म होता है स्ट्रक्चर्ड क्वेरी लैंग्वेज, जो आपको हेल्प करती है जो भी आपके माई सीक्वल टाइप ऑफ डेटाबेसेस होते हैं, यानी कि जो स्ट्रक्चर्ड डेटाबेसेस है जिसमें से एक होता है माई सीक्वल, उस पे जो भी डेटाबेस आपने स्टोर किया है तो उसको स्टोर करना, उस पर ऑपरेशंस परफॉर्म करने के लिए जो एसक्यूएल है वो आपको इनेबल्ड करता है। तो ओवरऑल ये लैंग्वेज है जो कि माई सीक्वल सर्वर पे यूज की जाती है, जहां पर आप डेटाबेस में ऑपरेशंस परफॉर्म करते हो, डेटाबेस मेंटेन करते हो, डेटाबेस डिलीट करते हो, डेटाबेस को रीड करते हो, डेटाबेस को अपडेट करते हैं। तो ये हमारे डिफरेंट टाइप्स ऑफ ऑपरेशंस हैं जो हम लोग परफॉर्म करते हैं। इन ऑपरेशंस को एक्चुअली में बोला जाता है क्रड, जहाँ पे क्रड CRUD, जहाँ पे C का मतलब होता है क्रिएट, R का मतलब होता है रीड, U का मतलब होता है अपडेट और D का मतलब होता है डिलीट। तो जितने भी हमारे डेटाबेसेस होते हैं उनमें ये क्रड ऑपरेशंस परफॉर्म होते हैं। अब कुछ मेजर ऑपरेशंस जिसमें हमारे कुछ कमांड्स आ जाते हैं, जिसमें DDL, DQL, DML, DCL, TCL आ जाते हैं। DDL का मतलब डेटा डेफिनेशन लैंग्वेज, DQL का मतलब डेटा क्वेरी लैंग्वेज, DML का मतलब डेटाबेस मॉडिफिकेशन लैंग्वेज। इस तरीके के सारे फुल फॉर्म है। अब इनका मतलब क्या है? DDL का मतलब है डेटाबेस डेफिनेशन लैंग्वेज, जिसमें कुछ कमांड्स आ जाते हैं जैसे क्रिएट हो गया, ड्रॉप हो गया, ऑल्टर हो गया, ट्रंकेट हो गया, रीनेम हो गया। तो यानी कि ये जो आपकी डेटाबेस को डिफाइन करने की जो प्रॉपर्टीज है, आप डेटाबेस क्रिएट कर सकते हो, डेटाबेस ड्रॉप कर सकते हो, डेटाबेस में ऑल्टरेशन कर सकते हो, डेटाबेस को ट्रंकेट कर सकते हो, डेटाबेस को रीनेम कर सकते हो। जहां तक बात है क्वेरी की, DQL की, तो उसमें आपका होता है सेलेक्ट कमांड। सेलेक्ट कमांड के हेल्प से आप डेटाबेस को क्वेरी करते हो। फिर हमारे आते हैं DML। DML में हमारा इंसर्ट, अपडेट, डिलीट, लॉक, मर्ज। ये आपको ऐसे कमांड्स आपको SQL लैंग्वेज में मिलते हैं जिसमें आप डेटाबेस में मॉडिफिकेशंस या बोले म्यूटेशंस लाते हो। फिर हमारे DCL और TCL कमांड आ जाते हैं। TCL हमारा ट्रांजेक्शंस कंट्रोल कमांड्स होते हैं, जिसमें कमिट हो गया, रोल बैक हो गया। अब कमिट एंड रोल बैक ये बेसिकली फॉर एग्जांपल आप बैंक में कोई ट्रांजेक्शन करते हो, अगर ट्रांजेक्शन फेल होता है तो आपका जो ट्रांजेक्शन है वो रोल बैक हो जाता है। तो ये सारे ऑपरेशंस को मेंटेन करने के लिए भी हमारे पास कुछ कमांड्स हैं, ठीक है। अब MongoDB की बात करते हैं। तो MongoDB हमारा जो होता है वो नॉन एसक्यूएल डेटाबेसेस होते हैं, जबकि जो MySQL है वो हमारा एक एसक्यूएल डेटाबेस होता है। दोनों में अंतर ये होता है कि एक स्ट्रक्चर्ड होगा। स्ट्रक्चर्ड होने का मतलब है कि इसमें हर एक चीज़ को पहले डिफाइन किया जाएगा, उसका एक स्ट्रक्चर मेंटेन किया जाएगा, और MongoDB में ऐसा नहीं किया जाता। तो MongoDB समझने से पहले हम MySQL को इंस्टॉल करते हैं, MySQL पे ऑपरेशंस परफॉर्म करते हैं। इंस्टॉल करने के लिए हम MySQL की ऑफिशियल वेबसाइट dev.mysql.com पर जाएंगे। इस वेबसाइट में हमको वो सारी इन्फॉर्मेशन मिलेगी, किस तरीके से इसको हम डाउनलोड कर सकते हैं, किस तरीके से इस पर ऑपरेशन परफॉर्म करने हैं। तो डाउनलोड के लिए हम जाते हैं MySQL कम्युनिटी डाउनलोड्स पे। इस लिंक पे क्लिक करेंगे, हमको ढेर सारे ऑप्शंस मिलेंगे। तो हम यूज़ करेंगे MySQL इंस्टॉलर फॉर विंडोज़, क्योंकि बाय डिफ़ॉल्ट हम विंडोज़ सिस्टम को यूज़ कर रहे हैं। फिर आप यहाँ पर MSI इंस्टॉलर किसी भी विंडोज़ के आपके OS के साइज़ पे आप कर सकते हो। हम यहाँ पे यूज़ करेंगे 32 बिट MSI इंस्टॉलर, ठीक है। ये क्योंकि मैंने पहले से इंस्टॉल कर रखा है, इसलिए मैं पहले अपने सिस्टम से इसको डिलीट कर दूंगा, ताकि इसका इंस्टॉलेशन हम दोबारा से कर सकें, ठीक है। आपने नहीं किया है तो आपको डिलीट करने की कोई आवश्यकता नहीं है, हम डायरेक्टली इसको यूज़ करेंगे। ओके, तो आगे बढ़ते हैं। यहाँ पर आप जैसे इंस्टॉल पे क्लिक करोगे, इंस्टॉलर आप रन करोगे, ठीक है। यहाँ पर हम कस्टम को सेलेक्ट करेंगे ताकि हम एक एक कॉन्फ़िगरेशन अपने नाम से कर पाएँ। नेक्स्ट जाएंगे, यहाँ पर ढेर सारे ऑप्शंस मिलते हैं कि आप क्या क्या इंस्टॉल करना चाहते हो। जैसे कि MySQL सर्वर, कोई आपको एक सर्वर लेना होगा, जो उसको आप यूज़ करना चाहते हो उसको सेलेक्ट करके आपको राइट हैंड साइड ड्रैग कर देना है, तो वो सेलेक्ट हो जाएगा। उसके बाद MySQL सर्वर के बाद हमें जाना होगा MySQL कनेक्टर्स में, MySQL एप्लीकेशंस में। एप्लीकेशन के लिए हम वर्कबेंच यूज़ कर लेंगे। वर्कबेंच हम एक जो सबसे लेटेस्ट वर्जन है वो सेलेक्ट कर लेंगे। वर्कबेंच सेलेक्ट करने के बाद हम नेक्स्ट जाएंगे MySQL शेल और MySQL फॉर VS कोड। ये क्योंकि मेरे में इंस्टॉल्ड है इसलिए मेरे को ऑप्शन नहीं दिखा रहा है, आपके में इंस्टॉल नहीं होगा, आप इसको यूज़ कर सकते हो। नेक्स्ट हम MySQL सेल पे जाएंगे, उसका लेटेस्ट वर्जन सेलेक्ट करेंगे और नेक्स्ट पे क्लिक कर देंगे। नेक्स्ट पे क्लिक करने के बाद ये हमसे डायरेक्टरी बोल रहा है कि आपका ये प्रोग्राम फाइल्स के अंदर सेव हो जाएगा। क्योंकि मेरे में सेव है तो मेरे को वार्निंग दे रहा है कि आपके में ऑलरेडी एग्जिस्ट करता है। आपके सिम में अगर इंस्टॉल नहीं होगा तो डायरेक्टली आप इंस्टॉल कर सकते हो। अदरवाइज़ अगर मैं अपने सिस्टम से इसको डिलीट कर दूँ, डिलीट करने के बाद अगर हम नेक्स्ट करेंगे तो ये मेरे में भी इंस्टॉल हो जाएगा। तो मेरे में MySQL डिलीटेड है, मैं इसको डिलीट कर देता हूँ। ऑलरेडी से इंस्टॉल था तो इसको डिलीट कर देंगे और दोबारा से जाकर इंस्टॉलर पे यस पे क्लिक करेंगे, एग्जीक्यूट कमांड पे रन करेंगे, तो जितने भी पैकेजेस, जितने भी हमने चीज़ें सेलेक्ट की हैं वो सारे इंस्टॉल होना स्टार्ट हो जाएंगे। जहाँ पर हमने MySQL सर्वर लिया है, वर्कबेंच लिया है, MySQL सेल लिया है, ये सारे हमने लेटेस्ट वर्जन को पिकअप किया है। आपके टाइम पे जो भी लेटेस्ट वर्जन आपको आपके स्क्रीन पे दिखाए वो सारे लेटेस्ट वर्जन आप यहाँ पर यूज़ कर सकते हो। एग्जीक्यूट पे क्लिक कर देंगे, इंस्टॉलेशन हमारा प्रोसीड हो जाएगा। यहाँ पर उसके बाद नेक्स्ट पे क्लिक करेंगे। नेक्स्ट पे क्लिक करने पे ये हमसे कॉन्फ़िगरेशन बोल रहा है, तो जो भी डिफ़ॉल्ट कॉन्फ़िगरेशंस हैं उन्हीं को हम लोग यूज़ करेंगे। अब यहाँ पे हमें एक पासवर्ड सेट करना होता है। ये पासवर्ड यूज़ होता है जब आप इस MySQL सर्वर को एक्सेस करोगे, तो इसके लिए आप कोई भी एक कस्टम पासवर्ड अपने लिए बना सकते हो। मेक श्योर पासवर्ड आप जो बनाओ वो आपको याद रहे, क्योंकि अगर आपने कोई एक ऐसा पासवर्ड बना लिया जो आप भूल गए तो आपको दोबारा से इंस्टॉलेशन करना होगा पासवर्ड को रीसेट करने के लिए। इसलिए पासवर्ड दोनों सेम होने चाहिए। पासवर्ड आपका सिंपल रखिए, क्योंकि कोई यहाँ पर आपकी हैकिंग नहीं कर रहा है। आप सिंपल सा पासवर्ड रखिए जो आपको याद रह सके। ऑलराइट, तो यहाँ पर हमने पासवर्ड सेट कर लिया है। पासवर्ड जब आपका मैच हो जाएगा, नेक्स्ट बटन जो होगी वो आपकी इनेबल्ड हो जाएगी। यहाँ पर ये आपको वार्निंग भी देता है, प्लीज़ रिमेंबर टू स्टोर द पासवर्ड इज इन इनसिक्योर प्लेस, ठीक है। ऑलराइट, तो यहाँ पे पासवर्ड हम लोग सेट कर लेंगे। पासवर्ड मेरे में बार बार चेंज होगा तो मैं वापस से जाऊँगा और एक नया पासवर्ड एंटर करूँगा। सिंपल सा पासवर्ड रखना है, कोई भी कॉम्प्लेक्स पासवर्ड रखने की ज़रूरत नहीं है, क्योंकि पासवर्ड याद रहना बहुत ज़रूरी है। तो यहाँ पे दोबारा से पासवर्ड रीसेट करते हैं। पासवर्ड इज़ वीक बट फाइन, हमें कोई बहुत हाई पासवर्ड डालने की ज़रूरत नहीं है। यहाँ पर इन सभी चीज़ों को सेलेक्ट कर लेंगे, ताकि ये कॉन्फ़िगरेशन स्टेप्स हैं जो कि यूज़ होंगी। आपकी कॉन्फ़िगरेशन फाइल बनेगी, लॉग फाइल बनेगी, डिफरेंट डिफरेंट टाइप्स ऑफ फाइल, डिफरेंट डिफरेंट कॉन्फ़िगरेशंस यहाँ पर होती हैं बिहाइंड द सीन। तो अब जैसे मैंने कनेक्ट किया था, आप देख सकते हो MySQL फोल्डर जो वो दोबारा से बन गया है, ठीक है। तो ये आपके लिए भी बन जाएगा और यहाँ पर जो कॉन्फ़िगरेशंस हैं वो बिहाइंड द सीन की जा रही हैं। ऑलराइट, तो इस तरीके से हमारा जो इंस्टॉलेशन है बहुत ही ईजी स्टेप्स में हम MySQL को इंस्टॉल कर सकते हैं। MySQL में हम SQL लैंग्वेज का यूज़ करेंगे। जिससे हम डिफरेंट डिफरेंट डेटाबेसेस बनाएंगे और उन डेटाबेसेस पे हम डिफरेंट डिफरेंट एसक्यूएल कमांड्स का यूज़ करके उस पर डिफरेंट डिफरेंट क्वेरीज जो है वो रन करेंगे। ठीक है, तो सबसे पहले वी एस कोड खोल लेंगे। वी एस कोड में बेसिकली हम कमांड लिखेंगे जिनको कि हम टर्मिनल पे एग्जीक्यूट करेंगे, क्योंकि कमांड्स हमारे लिए रहने ज़रूरी हैं ताकि जब आप फ्यूचर में इसको देखो तो आपके पास रहें। तो कमांड्स लिखने के लिए हम यहाँ पे एक नई फाइल बना लेंगे जिस फाइल को नाम देंगे mysql.sql। क्योंकि ये पाइथन की फाइल नहीं है तो आप इसको, ये एक एसक्यूएल फाइल है, इसमें एसक्यूएल की कमांड है, इसलिए हम इसको .sql दे रहे हैं। ये हमारा सिंपल सा सिंटेक्स है। ये बस एक कन्वेंशन हम लोग फॉलो कर रहे हैं कि जिस फाइल में हमारे एसक्यूएल की कमांड है उसको हम .sql से लिखेंगे। ये कमांड वीएस कोड से रन नहीं होंगे। इस कमांड्स को रन करने के लिए हमें अपने MySQL सर्वर को स्टार्ट करना होगा। उसके लिए हम सी में जाएंगे, क्योंकि हमें पता है हमारी सी ड्राइव के प्रोग्राम फाइल्स के अंदर MySQL इंस्टॉल हुआ है, तो वहीं पर जाएंगे। MySQL के अंदर जाएंगे। MySQL के अंदर आपको जब जाएंगे तो ढेर सारे ऑप्शंस मिलेंगे। हम सर्वर पे जाएंगे। ठीक है, MySQL सर्वर पे जाएंगे तो यहाँ पे बिन फोल्डर मिलेगा। इस बिन फोल्डर को डॉक्स फोल्डर है, एटसेट्रा फोल्डर, ढेर सारे फोल्डर्स हैं। हमें बिन फोल्डर के अंदर जाना है, प्रोग्राम फाइल्स के अंदर MySQL के अंदर MySQL सर्वर और फिर बिन फोल्डर। बिन फोल्डर को ओपन करेंगे तो यहाँ पे आप देख सकते हो ढेर सारी फाइल्स हैं, राइट, ढेर सारे आपके फाइल्स हैं। अब आपको इसको CMD में ओपन करना है, यानी कमांड प्रॉम्प्ट में ओपन करना है। तो एक ऑप्शन आपके पास ये है कि आप इस पूरे पाथ को सेलेक्ट कर और इस डायरेक्टरी पे इसकी जगह आप CMD लिख दोगे। CMD कमांड हमारा होता है जो कि डायरेक्टली आपको इस डायरेक्टरी का कमांड प्रॉम्प्ट खोल के दे देगा डायरेक्टली। बट अगर आप ऐसे नहीं करना चाहते, आप एक मैनुअल अप्रोच लेना चाहते हो, तो मैनुअल अप्रोच लेने के लिए सबसे पहले आप CMD ओपन करोगे, जो कि आप सर्च बार में जाके आप सिंपल अगर कमांड प्रॉम्प्ट या CMD टाइप करते हो तो जो CMD एप्लीकेशन है वो आपके लिए ओपन हो जाएगा, लाइक CMD आई विल टाइप। तो CMD हमारे सजेशंस में आ रहा है। अब अगर आप इसको ओपन करोगे CMD को, कमांड प्रॉम्प्ट को, तो ये आपके एक बाय डिफ़ॉल्ट सी ड्राइव की डायरेक्टरी पे होता है। तो हमने जो पाथ हमें जहाँ जाना है उसको आप CD करके डाल दोगे तो उस डायरेक्टरी में ये आपको ले जाएगा। अभी ये डायरेक्टरी इनवैलिड है, दोबारा से कॉपी करते हैं पाथ को, कमांड प्रॉम्प्ट में जाते हैं, CD करके जो भी आपका पाथ है उसको आप पेस्ट कर दोगे। ठीक है, तो अभी क्योंकि ये हम सी ड्राइव के अंदर थे, वहाँ से एकदम से डायरेक्टरी चेंज नहीं हो सकती, इसलिए वो इनवैलिड पाथ है। तो बेटर ये होता है कि आपको जहाँ पे जाना है, हमें पता है सी के अंदर हमारा प्रोग्राम फाइल्स है, प्रोग्राम फाइल्स के अंदर MySQL है, तो डायरेक्टली आप यहाँ से उसको स्टेप बाय स्टेप उसके अंदर पहुँचो। तो CD किया, CD हमें पता है कि प्रोग्राम फाइल से P लिखेंगे, टैब दबाएंगे, सजेशंस आते जाएंगे, प्रोग्राम फाइल्स में अंदर आ गए, फिर से CD लिखेंगे, उसके बाद हमें पता MySQL में जाना, MySQL लिखेंगे, एंटर करेंगे, MySQL के अंदर आ गए। MySQL के अंदर हमें पता है माई सर्वर में जाना है, वहाँ पे चले गए, फिर से CD लिखेंगे, बिन में जाना है, बिन में आ गए। तो ये आपका एक होता है इनडायरेक्ट वे टू ओपन अ CMD, और डायरेक्ट वे ये है कि आप मैनुअली फाइल मैनेजर से उस फाइल तक जाइए और डायरेक्टली जो आपका पाथ है वहाँ पर उसको सेलेक्ट करके CMD टाइप कर दीजिए, तो आपका जो कमांड प्रॉम्प्ट है वो उस डायरेक्टरी पे ओपन हो जाएगा। अब यहाँ पर हमें MySQL सर्वर है उसको स्टार्ट करना है। स्टार्ट करने के लिए हमारे पास एक स्पेसिफिक कमांड हमको देना होता है। ठीक है, क्योंकि MySQL सर्वर अभी आपके सिस्टम इंस्टॉल है लेकिन वो अभी कनेक्ट नहीं हुआ है। तो कनेक्ट करने के लिए DB को MySQL से हमारे पास एक सिंपल सा कमांड है, जो कमांड हमारा होता है MySQL, यानी कि MySQL -u रूट -password। -u और -p का मतलब है यूज़र नेम और पासवर्ड। तो जब आप इसको एंटर करोगे तो ये आपसे पासवर्ड बोलेगा। अब यहाँ पर आपको वही पासवर्ड एंटर करना है जो आपने इंस्टॉलेशन के टाइम पे दिया था, इसीलिए हमारा पासवर्ड ईजी होना चाहिए ताकि हम बार बार उसको यूज़ कर पाएँ और हमें याद रहे। ठीक है, यहाँ पे CLS कमांड और क्लियर कमांड दोनों ही नहीं चलते हैं क्लियर करने के लिए। तो बेटर ये है कि आप मल्टीपल टाइम्स एंटर कर लो, तो आप ऑटोमेटिकली आपको एक क्लियर स्क्रीन मिल जाएगी। ठीक है, या Ctrl+C कर देंगे तो बार बार आपको वापस इंस्टॉल करना पड़ेगा, इसलिए बेटर है कि आप मल्टीपल टाइम्स एंटर को क्लिक किए रहे, तो काफ़ी ज़्यादा ये स्क्रॉल डाउन हो जाएगा, तो आपको एक क्लियर स्क्रीन आपको मिल जाएगी। ठीक है, तो इस तरीके से हमारा जो MySQL सर्वर है वो स्टार्ट हो चुका है, हमने उससे कनेक्ट कर लिया है। अब हम पूरी तरीके से रेडी हैं डेटाबेस बनाने के लिए, डेटाबेस में टेबल्स इंसर्ट करने के लिए, और जो डिफरेंट SQL कमांड्स हमने लिस्ट में देखे थे उन सभी कमांड्स को यूज़ करने के लिए। तो सबसे पहले ये देखना कि कोई डेटाबेस बना हुआ है अभी तक कि नहीं, उसके लिए हमारे पास सिंपल सा कमांड होता है शो डेटाबेसेस। शो डेटाबेसेस आपको जितने भी आपके MySQL में जितने भी डेटाबेसेस अभी तक बने होंगे वो सारे डेटाबेस आपके लिस्ट हो जाएंगे। ठीक है, जैसे कि यहाँ पे देख सकते हैं इंफॉर्मेशन स्कीमा, MySQL परफॉर्मेंस स्कीमा, SYS, ये डिफरेंट डेटाबेसेस हैं जो माई सीक्वल सर्वर पे बने हुए हैं, तो इसने हमको इसको लिस्ट कर दिया। अब हमें क्या करना है, हम CRUD ऑपरेशन को फॉलो करेंगे, जहाँ पे सबसे पहले होता है क्रिएट करना, फिर होता है रीड करना, फिर अपडेट और डिलीट। तो क्रिएट करने के लिए हमारे पास क्या कमांड होगा, हम एक सिंपल सा कमांड, अगर हमने अपने डेटाबेस का नाम GUVI दिया है तो यहाँ पर सिंपल दे देंगे क्रिएट GUVI, यानी कि क्रिएट डेटाबेस, और डेटाबेस का नाम जिस भी नाम का आप डेटाबेस बनाना चाहते हो, तो वो आप जैसे ही उस कमांड को दोगे तो वो आपका क्या कर देगा, एक नया कमांड यानी कि नया डेटाबेस जो होगा वो क्रिएट कर देगा। तो CRUD ऑपरेशंस का सबसे जो पहला ऑपरेशन होता है वो होता है क्रिएट करना। तो क्रिएट डेटाबेस कमांड को रन करेंगे, ये बोल रहा है क्वेरी ओके, 1 रो अफेक्टेड, यानी कि हमारा जो क्वेरी था वो चल गया है। अभी डेटाबेस बना है कि नहीं, शो डेटाबेसेस से इसको वेरीफाई कर लेंगे, तो हम देख सकते हैं कि जो डेटाबेस की लिस्ट आई इस बार, उसमें जो GUVI है वो ऐड हो गया। उसके बाद यूज GUVI कर लेंगे, तो अभी तक जितने भी डेटाबेसेस स्कीमा है उसमें से एक टाइम पे आप एक ही डेटाबेस को एक्सेस कर सकते हो। तो जिस डेटाबेस को एक्सेस करना है उसके नाम के साथ यूज लिख देंगे, तो वो आपको यूज GUVI कर दिया। उसके बाद अगर आपको देखना है कि इस डेटाबेस में कोई टेबल है कि नहीं, तो टेबल को देखने के लिए शो टेबल्स को यूज करते हैं। ठीक है, शो टेबल्स को अगर हम यूज करेंगे तो उस डेटाबेस में अगर कोई टेबल बनी हुई है तो वो सारी टेबल्स क्या हो जाएंगी, लिस्ट हो जाएंगी। जैसे कि हमने देखा था कि यहाँ पर अभी कोई भी टेबल बनी नहीं, इसीलिए हमको एम्प्टी सेट मिला था, क्योंकि अभी तक हमने कोई टेबल बनाई ही नहीं। तो डेटाबेस बन गया, टेबल्स हमने देख ली अभी तक नहीं बनी है, तो सबसे पहले काम करते हैं क्रिएट करने का, एक टेबल क्रिएट करेंगे। डेटाबेस बन गया है, अब हम क्रिएट करेंगे टेबल को। तो कमांड क्या होता है, क्रिएट टेबल। क्रिएट हमारा कमांड है, टेबल बता रहा है कि टेबल बनाना है, टेबल का नाम हमने दे दिया कॉन्टेक्ट। अब क्योंकि ये स्ट्रक्चर्ड है तो यहाँ पे हमको जो उस टेबल का जो भी स्कीमा है वो मेंटेन करना है, उसको हमको डिफाइन करना है। जैसा कि हमने बताया कि सबसे पहला इस टेबल में एक कॉलम होगा कॉन्टेक्ट आईडी, जिसमें जो वैल्यू जाएगी वो इंटीजर टाइप की जाएगी। नेक्स्ट हमने दे दिया नेम, कि नेम जो होगा वो var_char20 होगा, यानी कि वेरिएबल्स, यानी कि आप कितने भी कैरेक्टर यूज़ कर सकते हो, कोई भी कैरेक्टर यूज़ कर सकते हो, लेकिन उसकी जो मैक्सिमम लिमिट है वो 20 है। सिमिलरली ईमेल दे देंगे, ईमेल को भी var_char दे देंगे, आप कोई भी कॉम्बिनेशन ऑफ कैरेक्टर्स को यूज़ कर सकते हो, इसकी भी मैक्सिमम लिमिट हमने 20 दे दी। सिमिलरली या इसको 50 कर देते हैं। सिमिलरली ईमेल के बाद हम यहाँ पे दे देंगे फ़ोन नंबर, और फ़ोन नंबर को भी हम var_char ले लेंगे, और इसमें हम लिमिट देते हैं 12 की। तो ये हमने 4 फील्ड दे दी। अगर आप एक और फील्ड देना चाहते हो डिस्क्रिप्शन दे सकते हैं, तो डिस्क्रिप्शन में इसको भी हमने var_char रखा, और यहाँ पे हम लिमिट दे देंगे 100। ठीक है, तो ये हमने एक स्कीमा क्या किया, डिफाइन किया है। अब इस टेबल में जितने भी रिकॉर्ड आएंगे उनमें सिर्फ इतना ही डेटा होगा। ठीक है, इस कमांड को कॉपी करते हैं और पेस्ट कर देंगे CMD में, तो हमारा देखो आगे क्वेरी ओके, यानी कि कमांड चल गया है, 0 रोज अफेक्टेड। इस बार हम टेबल्स को एक बार वेरीफाई करते हैं। शो टेबल्स कमांड का यूज करेंगे ताकि हम टेबल्स की लिस्ट को देख सकें। शो टेबल्स करेंगे, अब आप देख सकते हो टेबल्स इन GUVI डेटाबेस के अंदर हमने कॉन्टेक्ट नाम की टेबल बना ली है। ये सारी चीज़ें हमेशा केस इनसेंसिटिव होती हैं, तो जरूरी नहीं है कि आपने टेबल का नाम अगर अपर केस में रखा है तो वहाँ पे भी आपको अपर केस मिले, केस सेंसिटिव ये चीज़ नहीं होती। ठीक है, ओके। अब यहाँ पर बात करते हैं DSC कॉन्टेक्ट की। DESC हमारा बेसिकली उस कॉन्टेक्ट टेबल का डिस्क्रिप्शन आपको देता है। तो DESC, क्योंकि हमारा टेबल का नाम कॉन्टेक्ट है इसलिए हमको कॉन्टेक्ट यूज करना होगा। DESC इस कॉन्टेक्ट टेबल का डिस्क्रिप्शन देगा, और उस डिस्क्रिप्शन में ये सारे इन्फॉर्मेशन देता है कि फील्ड कौन कौन सी है, जैसे कि फील्ड हमारी ये सारी हैं, किस फील्ड का क्या टाइप है, फिर उसमें कोई नल वैल्यू एक्सेप्ट हो सकती है कि नहीं हो सकती है, और भी जो एक्स्ट्रा इन्फॉर्मेशन है वो हमको उस पर्टिकुलर टेबल की सभी फील्ड्स के बारे में मिल जाती है। तो ओवरऑल डिस्क्रिप्शन क्या है आपके उस टेबल का, वो हमको DESC कमांड का यूज करके मिल जाता है। ऑलराइट, अब हमने डेटाबेस बना लिया, हमने डेटाबेस के अंदर एक टेबल बना ली। अब टेबल के अंदर बारी है चीज़ों को इंसर्ट करने की। उसके पहले अगर आप कोई दूसरी टेबल बनाना चाहते हो, आप मोर देन 1 टेबल बना सकते हो डेटाबेस के अंदर। जैसे हमने यहाँ पे टेस्ट टेबल बनाई है, इसको इस कमांड को अगर कॉपी करके हम यहाँ पे पेस्ट कर देंगे तो जो टेस्ट नाम की टेबल है वो भी हमको मिल जाएगी। ठीक है, दोबारा से कॉपी करते हैं, क्रिएट टेबल टेस्ट, नेम var_char20, और यहाँ पे अभी भी ये सिंटेक्स एरर दे रहा है, क्योंकि अगर आपका जो लाइन नंबर 20 पे जो हमने 20 के बाद कॉमा दिया है वो इनवैलिड है। अगर आपके पास सिंगल कॉलम है तो आपको कॉमा देने की जरूरत नहीं है। इस बार क्वेरी हमारी ओके हो गई। इस बार अगर हम टेबल्स को यूज़ करेंगे, शो टेबल्स, तो आप देख सकते हो GUVI डेटाबेस के अंदर हमको 2 टेबल मिल चुकी हैं, कॉन्टेक्ट और टेस्ट। अब अगर किसी टेबल को डिलीट करना है तो आप ड्रॉप टेबल और टेबल का नाम यूज़ कर सकते हैं। उसको करने के बाद अगर फिर से शो टेबल्स करेंगे तो हम देख सकते हैं कॉन्टेक्ट जो टेबल थी वो हमारी डिलीट हो चुकी है। तो इस तरीके से टेबल को ड्रॉप करने के लिए कमांड होता है ड्रॉप टेबल और टेबल का नाम। यहाँ पर हमने टेबल का नाम टेस्ट दिया था तो हम यहाँ पे टेस्ट पास कर सकते हैं। ऑलराइट, डेटाबेस बन गया, टेबल बन गई, टेबल डिलीट हो गई। अब हम उस टेबल में डेटा को इंसर्ट करते हैं। ठीक है, ऑलराइट, इंसर्ट करने के लिए हमारे पास कमांड होता है इंसर्ट का। ठीक है, जो कि हमारा एक DML कमांड है, क्योंकि ये हमारे डेटा के जो डेटाबेस जो है उसमें हमारे मॉडिफिकेशंस हमको हेल्प करता है। तो यहाँ पर इंसर्ट कमांड को यूज़ करेंगे। इंसर्ट कमांड आपको हेल्प करता है आपके टेबल में रिकॉर्ड्स को इंसर्ट करने के लिए। ठीक है, अब इसका सिंटेक्स क्या है, सिंटेक्स इसका समझ लेते हैं। सिंटेक्स में सिंपली आपको इंसर्ट लिखना होता है और उसके बाद इनटू के बाद जो भी आपका कॉन्टेक्ट यानी कि जो भी आपका टेबल का नाम है वो देना होता है। इंसर्ट आपका कमांड है और उसके बाद उस टेबल में जो भी फील्ड्स हैं, जिन फील्ड्स में आप इंसर्ट करना चाहते हो, जिन फील्ड्स का रिकॉर्ड आप अपडेट करना चाहते हो, अपडेट करने का मतलब यहाँ पे जिन फील्ड्स को आप डेटा देना चाहते हो उन फील्ड्स को आप यहाँ पे लिस्ट करोगे, जैसे कि नेम, ID, ईमेल, फ़ोन नंबर, डिस्क्रिप्शन। तो यहाँ पे कुछ हमारे मिसमैच हैं, उनको हम पहले क्लियर कर लेते हैं। जैसे कि ID नहीं है, कॉन्टैक्ट ID है, और कॉन्टैक्ट ID हो गया, नेम हो गया, ईमेल हो गया, फ़ोन नंबर नहीं है, हमने यहाँ पे फ़ोन नाम का कॉलम बनाया हुआ है तो हम यहाँ पे फ़ोन नंबर को रिप्लेस कर देंगे फ़ोन से, और डिस्क्रिप्शन को डिस्क्रिप्शन ही रहेगा क्योंकि वो डिस्क्रिप्शन ही है। केस इनसेंसिटिव होती हैं चीज़ें, तो ज़रूरी नहीं है कि आपने अगर वहाँ पे लोअर केस रखा है तो यहाँ पे भी आप लोअर केस रखो। आप यहाँ पे रैंडम केस, अपर केस, लोअर केस कोई भी यूज़ कर सकते हो। तो सबसे पहले हमने सारे कॉलम के नेम दे दिए, उसके बाद वैल्यूज़ देनी होती हैं। वैल्यूज़ में जिस ऑर्डर में आपने कॉलम नेम्स स्पेसिफाई किए हैं उसी ऑर्डर में उनकी वैल्यूज़ आपको स्पेसिफाई कर देनी है। जैसे हमने ID दे दी 1, नेम अनीस, ईमेल, फ़ोन नंबर और डिस्क्रिप्शन में आई लाइक टीचिंग। ये सारी जो वैल्यूज़ हैं वो मैप हो जाएंगी। अब जब हम इस कमांड को रन करेंगे, कॉपी कर लेते हैं इस कमांड को, CMD में चलते हैं और उसको रन करेंगे, तो ये जो रिकॉर्ड है वो हमारा क्या हो जाएगा, इंसर्ट हो जाएगा उस टेबल में। ठीक है, सिमिलरली आप ढेर सारा डेटा करना चाहते हो तो हम बार बार इसको रन कर देंगे, हम जो डेटा है उसको चेंज कर लेंगे। नेम दे दिया अरफा, ईमेल arfa@gmail.com, चंदन यहाँ पे दे दिया आदित्य, और जो इनकी ईमेल्स हैं उनको भी अकॉर्डिंगली मॉडिफाई कर दिया, chandan@gmail.com एंड adi@gmail.com। फ़ोन नंबर्स में कुछ म्यूटेशंस कर लेते हैं, अलग अलग फ़ोन नंबर सबको दे देते हैं और सबकी हॉबीज़ में चेंज कर देते हैं, आई लाइक डांस, आई लाइक सिंग, और लेट सपोज फॉर अल्फा आई लाइक जिम। तो ये हमने 3 नए डेटा इंसर्ट करने हैं, तो इंसर्ट इनटू, और ये तीनों कमांड्स हम कॉपी कर लेंगे एक साथ, और इन तीनों कमांड्स को कॉपी करके हम जब CMD में पेस्ट करेंगे तो 3 और रिकॉर्ड हमारे सेम टेबल में इंसर्ट हो जाएंगे। कॉपी करते हैं, अब कॉपी करने के बाद हम CMD में जाएंगे, पेस्ट कर देंगे तीनों कमांड, एंटर करेंगे, तो हर एक कमांड के लिए हमको क्वेरी ओके मिला है। इसका मतलब कि हमारे सारे कमांड, सारा डेटा इंसर्ट हो चुका है। अब जो डेटा इंसर्ट हुआ है उसको हमें रीड करना होगा, तो रीड करना हमारा दूसरा ऑप्शन होता है जिसको हम लोग बोलते हैं रीड करना। उसके लिए हमारे पास जो कमांड है वो CRUD ऑपरेशंस में हमारा SQL में सेलेक्ट है, तो अगर सेलेक्ट एस्ट्रिक फ्रॉम कॉन्टेक्ट कर देंगे तो उस टेबल का जितना भी रिकॉर्ड अभी तक उसमें सेव हुआ है वो सारा रिकॉर्ड आपको लिस्ट हो जाएगा। ठीक है, तो सेलेक्ट एस्ट्रिक फ्रॉम कॉन्टेक्ट यानी कि सेलेक्ट देना है, एस्ट्रिक देना है, टेबल का नाम देना है और बीच में फॉर्म दे देना है। तो सेलेक्ट और यहाँ पे एस्ट्रिक, अगर आपको सारा डेटा चाहिए तो एस्ट्रिक, अगर आपको स्पेसिफिक फील्ड चाहिए तो स्पेसिफिक फील्ड्स को स्पेसिफाई कर सकते हैं, फ्रॉम और उसके बाद टेबल का नाम। अब मान लेते हैं अगर आपको कोई स्पेसिफिक फील्ड चाहिए, जैसे कि हमको अगर ईमेल और नेम चाहिए तो उसके लिए लिखते हैं सेलेक्ट ईमेल कॉमा नेम फ्रॉम कॉन्टैक्ट। ठीक है, तो अगर आपको कोई स्पेसिफिक फील्ड चाहिए आप स्पेसिफिक फील्ड्स को स्पेसिफाई कर दो, आपको सारी फील्ड चाहिए तो आप सिंपल एस्ट्रिक लिख दो या स्टार लिख दो। ठीक है, इस कमांड को दोबारा से रन करते हैं, कमांड कॉपी करके दोबारा से पेस्ट करेंगे, सेलेक्ट ईमेल नेम फ्रॉम कॉन्टैक्ट। ठीक है, मैनुअल भी टाइप कर सकते हैं। तो यहाँ पे देख सकते हैं जो पूरे डेटाबेस में, पूरे टेबल में जितना भी रिकॉर्ड है उस पूरे रिकॉर्ड का हमको सिर्फ नेम और ईमेल हमको मिल गया। ठीक, तो इस तरीके से सेलेक्टेड रिकॉर्ड्स को भी हम फेच कर सकते हैं। हर बार हमको पूरा का पूरा रिकॉर्ड फेच करने की रिक्वायरमेंट नहीं होती, जैसी रिक्वायरमेंट है उसलिए हर एक रिक्वायरमेंट को सॉल्व करने के लिए हमारे पास कमांड्स हैं। ठीक है, तो ये हमारा हो गया फेच रिकॉर्ड। अब अगर हमें डेटा को अपडेट करना है यानी कि अपने डेटाबेस में कुछ मॉडिफिकेशंस करने हैं तो उसके लिए हमारे पास होता है कमांड जिसको बोलते हैं अपडेट। तो अपडेट टेबल का नाम, किस टेबल में आपको अपडेट करना है, फिर आपको हम दे देते हैं सेट कमांड। सेट कमांड से हमको ये बताता है कि कौन सी फील्ड को आपको सेट करना है। तो मान लेते हैं हमको कॉन्टैक्ट आईडी फील्ड को सेट करना है और इसको इक्वल के बाद जो भी वैल्यू आप इसको देना चाहते हो, हम मान लेते हैं हमको 2 देना है, क्योंकि अभी तक हमने देखा है कि कॉन्टैक्ट आईडी सबको हमने 1 दे रखी है। अभी हम क्या करेंगे, एक एक करके सबकी कॉन्टैक्ट आईडी चेंज कर लेंगे। तो आपको एक ऐसी फील्ड देनी होगी जिसकी कंडीशन ना मैच करो। आप मोबाइल दे सकते हो, ईमेल दे सकते हो, नेम दे सकते हो। तो ईमेल हमको प्रोमिनेंट लग रहा है, ईमेल को यूज़ करते हैं। तो हम कमांड दे रहे हैं यूज़ अपडेट कॉन्टैक्ट सेट कॉन्टैक्ट आईडी इक्वल्स टू 2, जहाँ पर यानी कि वेयर ईमेल की वैल्यू क्या है, arfa@gmail.com। तो जिस टेबल के रिकॉर्ड में ईमेल की वैल्यू अरफा है, उस टेबल के रिकॉर्ड में जो कॉन्टैक्ट आईडी नाम की फील्ड है उसकी वैल्यू आप चेंज कर दो 2 में। कमांड को कॉपी करके रन करेंगे, क्वेरी ओके मिला। अब अगर हम सारे डेटा को एक बार फेच करें, सेलेक्ट स्टार्ट फ्रॉम कॉन्टैक्ट करें, तो आप देख सकते हो जिस रिकॉर्ड में अरफा है उस फील्ड के उस रिकॉर्ड में जो कॉन्टैक्ट आईडी है वो 2 हो चुकी है, राइट। सिमिलरली अगर हम सभी के लिए कर दें, हम कॉन्टैक्ट आईडी 3 कर दें और कॉन्टैक्ट आईडी 4 कर दें। 3 कर देंगे हम लोग चंदन के लिए और 4 कर देंगे आदि के लिए, ठीक है। तो ईमेल आईडीज इनकी रेस्पेक्टिवली कॉपी करके यहाँ पे कंडीशंस में अपडेट कर देते हैं। chandan@gmail.com को भी कॉपी करके जहाँ पर हमको कॉन्टैक्ट आईडी 3 करनी है वहाँ पर उसको चेंज कर देते हैं। तो इस तरीके से आप एक पर्टिकुलर टेबल के रिकॉर्ड को कंडीशन के बेस पे हम लोग क्या कर सकते हैं, मॉडिफिकेशंस उसमें परफॉर्म कर सकते हैं। और इसी को हम लोग बोलते हैं डेटा को अपडेट करना, ठीक है। इन सभी कमांड्स को प्रॉपरली कॉपी नहीं हुआ है, दोबारा से कॉपी करते हैं। कॉपी करने के बाद यहाँ पर CMD में आके पेस्ट कर देंगे, रन करेंगे। दोनों ही क्वेरीज के लिए हमको क्वेरी ओके मिला। अब अगर हम रिकॉर्ड को फिर से पूरा रिकॉर्ड फेच करते हैं, सेलेक्ट एस्टेरिक फ्रॉम कॉन्टैक्ट करके, आप देख सकते हो सबकी जो कॉन्टैक्ट आईडी है, जो कंडीशंस हमने दी थी उन्हीं कंडीशंस के साथ हमारा जो कॉन्टैक्ट आईडीज हैं वो क्या हो चुकी हैं, अपडेट हो चुकी हैं। तो करंट ऑपरेशंस में हमने क्रिएट देखा, रीड देखा, अपडेट देखा। अब आ रही है डिलीट की। तो डिलीट करने के लिए हमारे पास सिंपल सा कमांड है, डिलीट और टेबल का नाम। अगर आपको स्पेसिफिक रिकॉर्ड डिलीट करना है तो आप डिलीट फ्रॉम कॉन्टैक्ट। अगर आपको कोई एक पर्टिकुलर रिकॉर्ड डिलीट करना है तो आप डिलीट फ्रॉम कॉन्टैक्ट वेयर, फिर से आपको कंडीशन देनी होती है। तो कॉन्टैक्ट आईडी इक्वल्स टू 4 अगर कर देंगे तो टेबल का जिस टेबल के रिकॉर्ड में कॉन्टैक्ट आईडी की वैल्यू 4 होगी वो रिकॉर्ड हमारा डिलीट हो जाएगा। क्वेरी रन की, क्वेरी ओके मिला। फिर से हम पूरा डेटा देखते हैं तो आप देख सकते हो इस बार हमको सिर्फ 3 रिकॉर्ड ही मिले, क्योंकि जिस रिकॉर्ड की आईडी 4 थी वो हमारी क्या हो चुकी है, डिलीट हो चुकी है। तो इस तरीके से हम SQL कमांड्स का यूज़ करके MySQL सर्वर में सारे CRUD ऑपरेशंस क्या कर सकते हैं, परफॉर्म कर सकते हैं। अगर आप कंडीशंस चेंज करते जाओगे, जैसे जैसे आप कंडीशंस देते जाओगे, वैसे वैसे आपको जो ऑपरेशंस हैं आपके टेबल में होते जाएंगे, ठीक है। तो ये हमारा सारी चीज़ें हम लोगों ने देखी MySQL सर्वर के बारे में, SQL के कमांड्स को यूज़ किया और किस तरीके से हम डेटाबेस को बनाते हैं, उनको मॉडिफाई करते हैं, उनको अपडेट करते हैं, इवन उनको डिलीट भी कर सकते हैं अगर वो रेलिवेंट नहीं रह चुके हैं। ये सारे ऑपरेशंस हम डेटा से रिलेटेड हर एक डेटाबेस सर्वर पे कर सकते हैं और हर एक सर्वर पे करने के लिए उसके लिए हमारे पास एक पर्टिकुलर लैंग्वेज है। जैसे कि MySQL के लिए हमने SQL को देखा। MongoDB को समझते हैं। MongoDB is a database consist of collections and documents। तो MySQL में जिस चीज़ को हम डेटाबेस बोलते हैं उस चीज़ को MongoDB में हम कलेक्शन बोलते हैं। फिर जिस चीज़ को MySQL में हम टेबल बोलते हैं उस चीज़ को MongoDB में हम लोग डॉक्यूमेंट्स बोलते हैं। तो MongoDB में हमारे क्या होते हैं, कलेक्शंस होते हैं और डॉक्यूमेंट्स होते हैं। जहाँ पर जो डॉक्यूमेंट है वो सिंपली हमारा एक जेसन ऑब्जेक्ट होता है जिसमें जो डेटा है वो हमारे की और वैल्यू के पेयर के फॉर्म में रहता है, ठीक है। तो यहाँ पर ये MongoDB बेसिकली जो मेन डिफरेंस है MongoDB और MySQL में वो ये है कि MongoDB आपका स्कीमा लेस है, उसमें कोई भी एक स्पेसिफिक स्ट्रक्चर नहीं है कि हर डेटा का जो रिकॉर्ड है उसमें यही स्ट्रक्चर फॉलो होना चाहिए। MongoDB में आपको लिबर्टी होती है, आप अपने जो डॉक्यूमेंट है यानी कि जो टेबल है, जो आपका रिकॉर्ड्स हैं, वो हर रिकॉर्ड एक दूसरे से वेरी कर सकता है, क्योंकि यहाँ पर वो सिंपली जेसन को फॉलो करता है। एग्जाम्पल के लिए जेसन एक कैसा दिखता है ऑलरेडी हम पढ़ चुके हैं, बट फिर भी हम इसको समझ लेते हैं। तो ये हमारा ओवरऑल एक जेसन है जिसमें हमने फील्ड्स को और यानी कि जो डेटा है वो की वैल्यू पेयर के फॉर्म में रखा है। अलग अलग नाम की फील्ड है, हर फील्ड में एक अलग डेटा टाइप की वैल्यू है, जो कि जेसन की ब्यूटी है। यहाँ पर आपको सिंपली बस एक पैटर्न फॉलो करना होता है कि एक की होगी, उसकी एक वैल्यू होगी। अब वो वैल्यू किसी भी डेटा टाइप की हो सकती है, उससे हमें फ़र्क नहीं पड़ता, राइट। तो ओवरऑल यही एक मेजर डिफरेंस है हमारे MongoDB में और MySQL में कि MongoDB आपको लिबर्टी देता है कि आपके हर एक रिकॉर्ड में कोई भी डेटा आप रख सकते हो। यहाँ पर ज़रूरी नहीं है कि हर एक रिकॉर्ड में एक स्पेसिफिक पैटर्न ही फॉलो हो। एग्जाम्पल के लिए अगर हम उसके लिए पहले हम इसका समझ लेते हैं कि ये काम कैसे करता है। तो मोंगोडीबी में क्या होता है, सबसे पहले आपका डेटाबेस तो है ही। अब डेटाबेस के अंदर हमारे क्या होते हैं, कलेक्शंस होते हैं। कलेक्शंस आपके यूजर्स, प्रोडक्ट्स, यानी कि जो इन्फॉर्मेशन आपको सेव करनी है उस इन्फॉर्मेशन के लिए आप एक स्पेसिफिक कलेक्शन बना लोगे। हर एक कलेक्शन में आपको एक क्या होते हैं, डॉक्यूमेंट्स होते हैं जो कि स्कीमा लेस है, यानी कि हर एक डॉक्यूमेंट एक दूसरे से वेरी कर सकता है। यानी कि हर एक रिकॉर्ड में आप कुछ तो इन्फॉर्मेशन कॉमन रख सकते हो, लेकिन जरूरी नहीं है कि आप सारा इन्फॉर्मेशन आपकी एक कॉमन पैटर्न को ही फॉलो करे। ठीक है, इसको बेटर समझेंगे अगर हम इसको एक टेबल के रिकॉर्ड से कंपेयर करेंगे। क्योंकि टेबल के रिकॉर्ड में क्या होता है कि हमारे जो फील्ड्स हैं, जो हमने सेट कर दी, जो स्कीमा हमने डिफाइन कर दिया। फॉर एग्जांपल अगर हमने स्कीमा बना दिया कि आईडी होनी चाहिए, नेम होनी चाहिए, एज होनी चाहिए, सैलरी होनी चाहिए, तो टेबल बनाते समय हमने जो स्कीमा डिफाइन कर दिया, अब उस टेबल में जितने भी रिकॉर्ड आते हैं उन सभी में क्या होता है कि वही पैटर्न फॉलो होता है, सिर्फ उतनी ही इंफॉर्मेशन आप सेव कर सकते हो। लेकिन मोंगोडीबी में आपको लिबर्टी है कि मान लेते हैं पहले रिकॉर्ड में आपने आईडी, नेम, एज और सैलरी डाली, लेकिन दूसरे में आपने आईडी, नेम और एक दूसरी वैल्यू दे दी, इज एक्टिव या कोई भी इंफॉर्मेशन दे दी, राइट। अगर हम माई सीक्वल डॉट एसक्यूएल में जाएं तो वहां पर हमने देखा था, जो हमने इंसर्ट कमांड किए थे, तो जो हमने स्कीमा फॉलो किया था वही स्कीमा, जो भी हमने स्कीमा बनाते समय जो भी हमने फील्ड्स नेम डाली, और वही फील्ड्स नेम हमको यूज करनी पड़े जब भी हमने डेटा को इंसर्ट किया। लेकिन मोंगोडीबी में आपको ऐसा नहीं करना, ना ही आपको कोई स्कीमा आइडेंटिफाई कराना है, ना ही आपको कोई स्कीमा को डिफाइन करना है, और ना ही आपको उसको फॉलो करना है, राइट। यहाँ पर आप फ्री हो, आपको सिर्फ कलेक्शन का नाम याद रखना है। उस कलेक्शन में आपको एक सेट ऑफ इंफॉर्मेशन देनी है। वो इंफॉर्मेशन के जो रिकॉर्ड्स हैं, जो हर एक यूजर की जो इंफॉर्मेशन है, वो एक दूसरे से वेरी कर सकती है। फॉर एग्जाम्पल यहाँ पे जो पहला आईडी है उसमें हमने एज और सैलरी दी है, लेकिन जो दूसरा रिकॉर्ड उसमें हमने एज नहीं दी ना सैलरी दी, और तीसरे रिकॉर्ड में हमने पिन नंबर दे दिया, एज दे दी। आप यहाँ पर देख सकते हो कि जो मोंगो डीबी है उसमें आपको कितनी ज्यादा लिबर्टी मिल रही है कि ये एक स्कीमा लेस है। यहाँ पे आपको कोई एक पैटर्न फॉलो नहीं करना, आपके बस एक कलेक्शन में कुछ डॉक्यूमेंट्स जाएंगे, वो डॉक्यूमेंट्स में एक सिमिलर ग्रुप ऑफ इन्फॉर्मेशन होगी, लेकिन हर एक डॉक्यूमेंट एक दूसरे से वेरी कर सकता है। की फीचर्स है, हाई परफॉर्मेंस है, क्राउड ऑपरेशंस आप कर सकते हो, हाई अवेलेबिलिटी है और स्केलेबिलिटी है। एडवांटेजेस की बात करें तो एडवांटेजेस में वही है कि डॉक्यूमेंट्स का रिस्पॉन्ड टू नेटिव डेटा टाइप्स इन मैनी प्रोग्रामिंग लैंग्वेज, यानी कि आप किसी भी प्रोग्रामिंग लैंग्वेज उसको यूज कर सकते हो। किसी भी टाइप का डायनेमिक्स स्कीमा सपोर्ट पॉलीमॉर्फिज्म, पॉलीमॉर्फिज्म का मतलब भी हमने समझा था कि अलग अलग फॉर्म में रह सकता है। वही चीज कि हर एक जो डॉक्यूमेंट है वो एक दूसरे से क्या हो सकता है, वेरी कर सकता है। अब प्रैक्टिकली इसको समझते हैं, लेकिन प्रैक्टिकली समझने से पहले एज यूजुअल हमको जिस तरीके से हमने माई के लिए माई को इंस्टॉल किया था, यहाँ पर हमको मोंगोडीबी को इंस्टॉल करना होगा। उसके लिए हम मोंगोडीबी की ऑफिशियल वेबसाइट mongodb.com पे जाएंगे। यहाँ से हम सारा अपना जो इंस्टॉलेशन की प्रोसेस है वो स्टार्ट करेंगे। ठीक है, तो यहाँ पे जाते हैं मोंगोडीबी के कम्युनिटी सर्वर में। कम्युनिटी सर्वर में जब जाएंगे तो यहाँ पर आपको ऑप्शंस मिलेंगे इसको इंस्टॉल करने के लिए। मोंगोडीबी कम्युनिटी सर्वर, यहाँ पर आप नीचे स्क्रॉल करेंगे तो आप देख सकते हो कि ये आप इनको कमांड से भी इंस्टॉल कर सकते हो, या फिर मैनुअली आपको जो MSI इंस्टॉलर मिलता है, MSI इंस्टॉलर को इंस्टॉल करके आप अपने अपने सिस्टम में मोंगोडीबी को सेटअप कर सकते हो। कोई भी आपका जो भी OS है उसके हिसाब से आप ड्रॉप डाउन से सेलेक्ट करके जो वर्जन आप यूज़ करना चाहते हो वो वर्जन को यहाँ से सेलेक्ट करके आप सिंपल इंस्टॉल पे या डाउनलोड पे क्लिक करोगे तो इसका जो MSI इंस्टॉलर है वो क्या हो जाएगा, डाउनलोड हो जाएगा। ठीक है, तो इस तरीके से सबसे पहले आप देख सकते हो ये फाइल हमारी डाउनलोड हो रही है, जिसका साइज अराउंड 485 MB है। तो ये बड़ी फाइल है, तो इसके लिए आपका इंटरनेट कनेक्शन अच्छा होना जरूरी है। एक बार उसको डाउनलोड हो जाने देते हैं, उसके बाद इसके आगे की कहानी हम लोग कंटिन्यू करेंगे। ठीक है, तो सिंपली आपको MSI इंस्टॉलर को जब इंस्टॉल कर लोगे तो जैसे हमने माई सीक्वल सर्वर में हमने डिफरेंट कॉन्फ़िगरेशंस की थी, डिफरेंट टाइप्स ऑफ चीज़ें, सर्वर किया था, सेल किया था, वर्कबेंच की थी, सिमिलरली यहाँ पे भी हमको अलग अलग टाइप ऑफ एप्लीकेशंस को डाउनलोड करना होगा। तो यहाँ पर हमारा ये फाइल ऑलमोस्ट डाउनलोड हो चुकी है। डाउनलोड होने के बाद इसको हम लोग ओपन करेंगे। जब हम ओपन करेंगे तो इसकी जो इंस्टॉलेशन विंडोज़ हैं वो हमारे सामने आएंगी, जिसमें हम कुछ अपने इनपुट्स देंगे कि हमको क्या करना है क्या नहीं करना। सिमिलर टू माई सीक्वल सर्वर, यहाँ पे भी एक सिमिलर पैटर्न है इसके इंस्टॉलेशन में। तो ये इंस्टॉलर हमारा ओपन हो रहा है। मीनवाइल ये आपको अलाउ करता है, कोई भी आप OS यूज़ कर लो, कोई भी वर्जन आप यूज़ करना चाहो वो यूज़ कर सकते हो। ठीक है, लिंक सिंपल हमको mongodb.com पे जाना है। तो ये इसका इंस्टॉलर है जो हमारा इंस्टॉल हो चुका है। ये बोल रहा है वेलकम टू MongoDB 6.0.5 सेटअप विजार्ड। नेक्स्ट पे क्लिक करते हैं। लाइसेंस को हमको एक्सेप्ट करना होगा, नेक्स्ट करेंगे। यहाँ पे हमको कस्टम करना है। कस्टम में हमको हेल्प मिल जाती है कि आप जो चाहो सिर्फ उतना इन्फॉर्मेशन रखो, सारा आपको बल्क नहीं रखना अपने पास, ठीक है। तो सर्वर है, राउटर है, मिसलेनियस टूल्स हैं, तो सारे फीचर विल बी इंस्टॉल्ड व्हेन रिक्वायर्ड। तो ये सारी चीज़ें हैं। यहाँ पर आप डिस्क यूसेज देख सकते हो कि इसका क्या यूज़ रहेगा। और ये कहाँ पे जा रहा है, ये हमारा जा रहा है प्रोग्राम फाइल्स के अंदर MongoDB में। वो हमारा गया था, वो भी प्रोग्राम फाइल्स के अंदर ही गया था, उसका फोल्डर बना था MySQL से, इसका फोल्डर बनेगा MongoDB से। नेक्स्ट करते हैं। यहाँ पे हम बोल रहा है इंस्टॉल Mongo एज सर्विस, तो यहाँ पे रन सर्विस ऑन नेटवर्क यूज़र, रन सर्विस एज लोकल यूज़र, तो क्योंकि हमको अपने लोकल पे यूज़ करना है तो हम लोकल सेलेक्ट कर लेंगे। यहाँ पे सर्विस का नाम MongoDB रहेगा। डेटा डायरेक्टरी, जितना भी डेटा आप डालोगे वो इस फोल्डर में जाएगा, डेटा फाइल में जाएगा। जो भी लॉग्स होंगे वो लॉग फाइल में जाएंगे। तो लॉग्स हमारे लिए बन जाते हैं ताकि अगर आपका कभी इंस्टॉलेशन सही नहीं चल रहा है तो वो आप देख सको, ठीक है। इंस्टॉल MongoDB कंपस, तो इंस्टॉल MongoDB कंपस बेसिकली ये एक एप्लीकेशन हमको मिलता है जो कि पूरा GUI बेस्ड है, यानी कि ग्राफिकल यूज़र इंटरफेस मिलता है हमको, जिसमें आपके उस MongoDB सर्वर के जितनी भी चीज़ें हैं वो आप ग्राफिकली अपने UI पे देख सकते हो। एक बहुत ही यूज़र फ्रेंडली UI है, UI एप्लीकेशन है MongoDB कंपस, जो आपके सिस्टम में MongoDB की जितनी भी इंफॉर्मेशन है, कौन कौन से कलेक्शंस हैं, किस कलेक्शन में कौन कौन से डॉक्यूमेंट्स हैं, कितना डॉक्यूमेंट है, कितना नहीं है, सारी चीज़ें आप वहाँ से कर सकते हो। इवन आप वहाँ से अपने ऑपरेशंस भी परफॉर्म कर सकते हो, बट हम यहाँ पे CMD का ही यूज़ करेंगे, ठीक है। तो ये आपका MongoDB कंपस जो है वो ओपन हो गया है। तो सबसे पहली चीज़ आप जो देख रहे होगे, यहाँ पर आपको एक URL दिख रहा है। ये URL बेसिकली इस MongoDB सर्वर से कनेक्ट करने का URL है, जो कि जब हम MongoDB शेल को इंस्टॉल कर लेंगे उसके बाद जब हम कनेक्ट करेंगे तो यहाँ पर हमको ये URL जो है वो पास करना होगा। MySQL के केस में हमने पासवर्ड बनाया था, एक कमांड था, उससे हमारा MySQL हमारा कनेक्ट हो गया था। यहाँ पर जो प्रोसेस है वो उसके थोड़ा सा अलग है। तो सबसे पहले कंपस में आप देख सकते हो ढेर सारे रिसेंट्स एक्सेस किए जा चुके हैं, जो जितने भी कनेक्शंस हैं, ठीक है। तो ये एक GUI बेस्ड एप्लीकेशन है जो कि हमको हेल्प करता है MongoDB की सारी इन्फॉर्मेशन को एक्सेस करने के लिए। उसके बाद एक इन्फॉर्मेशन है, वो ये कि आपको ये पता करना हो कि MongoDB आपका चल रहा है कि नहीं चल रहा है। वो सारी इन्फॉर्मेशन के लिए टास्क मैनेजर पे जाते हैं। उसके पहले हम कमांड प्रॉम्प्ट को हमको रन करना होगा, बट हमको इसको एज ए एडमिनिस्ट्रेटर रन करना होगा क्योंकि कुछ परमिशंस हैं जो कि हमको देनी होंगी, ठीक है। उसके साथ साथ आप यहाँ पर टास्क मैनेजर पे अगर जाओगे तो टास्क मैनेजर पे जाके आप सर्विसेज पे जाओगे, तो क्योंकि MongoDB अब आपका इंस्टॉल हो चुका है, तो अगर वो इंस्टॉल हो गया है, रन कर रहा है कि नहीं रन कर रहा है, वो आप यहाँ से वेरीफाई कर लोगे। क्योंकि जब आप कनेक्शन सेट करोगे, अगर MongoDB रनिंग नहीं है तो मैनुअली या फिर कमांड से आपको क्या करना होगा, MongoDB को पहले रन पे लाना होगा, उसके बाद आपका जो MongoDB से कनेक्शन आपका एस्टेब्लिश हो पाएगा। तो यहाँ पे हम देख सकते हैं रनिंग हो रहा है। अगर आप इसमें राइट क्लिक कर दो तो आप इसको स्टॉप भी कर सकते हो, या अगर रनिंग है तो आप इसको रीस्टार्ट भी कर सकते हो, ठीक है। स्टॉप कर दिया तो स्टार्ट भी कर सकते हो, मतलब कि ये सिंपली आपका मैनुअल वर्क है। ये सेम ऑपरेशन हम CMD के थ्रू कमांड से भी कर सकते हैं, और वो कमांड्स हमको CMD में देने होंगे, लेकिन जब तभी दे पाएंगे अगर हमने CMD को उसको एडमिनिस्ट्रेटर में रन किया है। तो वो कमांड्स कौन से हैं वो देख लेते हैं। PPT में वो कमांड्स हमारे पास पड़े हुए हैं। तो वो कमांड होते हैं नेट स्टार्ट MongoDB। नेट स्टार्ट MongoDB आपके MongoDB सर्वर को स्टार्ट कर देगा, और नेट स्टॉप MongoDB आपके MongoDB सर्वर को स्टॉप कर देगा। ये दोनों कमांड आपको कमांड प्रॉम्प्ट में एज ए एडमिनिस्ट्रेटर रन करके देने होते हैं, या फिर आप अपने विंडोज़ पावर सेल का यूज़ करके, अगर आप विंडोज़ के लैपटॉप को यूज़ कर रहे हो तो आपको विंडोज़ पावर सेल ओपन करके ये कमांड आपको देने हैं। तो यूज़ करते हैं। कमांड हमारा सबसे पहले क्या है, नेट MongoDB स्टार्ट, या नेट स्टार्ट MongoDB, नॉट MongoDB, इट्स MongoDB। सो इसको हम रन करेंगे तो क्या बोला, द रिक्वेस्टेड सर्विस हैज ऑलरेडी बीन स्टार्टेड, क्योंकि हमारा जो MongoDB सर्वर है वो रन कर रहा है तो दोबारा से स्टार्ट नहीं कर सकता। तो सबसे पहले इसको स्टॉप करेंगे, उसका कमांड है नेट स्टॉप MongoDB। जब हम स्टॉप कमांड दे देंगे तो हमारा जो MongoDB सर्वर है सर्विंग स्टॉपिंग, एंड सर्वर वॉज स्टॉप सक्सेसफुली, तो सर्विस हमारी स्टॉप हो चुकी है। अब अगर हम स्टार्ट कमांड देंगे तो हमारा जो स्टार्ट कमांड है वो काम कर जाएगा, और MongoDB सर्विस को दोबारा से क्या कर देगा, स्टार्ट कर देगा। तो इस तरीके से आप MongoDB को स्टार्ट या स्टॉप कर सकते हो। अब ये स्टार्ट स्टॉप हमको तब करना होता है जब हम नेटवर्क कनेक्शन स्टेब्लिश करेंगे, उसके लिए हमको MongoDB शेल को यूज़ करना होगा। तो MongoDB शेल को इंस्टॉल करने के लिए हम MongoDB शेल के URL पे जाएंगे और यहाँ पर MongoDB शेल को डाउनलोड करने के लिए हमारे पास ऑप्शंस है। तो हम विंडोज़ और जो भी वर्जन है लेटेस्ट, और इसमें जो पैकेज हमको मिलता है वो जिप फोल्डर मिलता है, इसको डाउनलोड कर लेंगे। इसका फाइल साइज़ कोई बहुत ज़्यादा नहीं है, 33 MB का फाइल साइज़ है। ये जब एक बार डाउनलोड हो जाएगा तो इसको हम लोग ओपन कर लेंगे। क्योंकि ये जिप में हुआ है तो इसको हमको एक्सट्रैक्ट वगैरह करना पड़ेगा। तो एक बार इसको डाउनलोड हो जाने देते हैं। डाउनलोड हो गया है और एक काम करते हैं, यहाँ पर एक फ़ोल्डर बना लेते हैं जहाँ पर हम शेल को इंस्टॉल कर लेंगे, जिसको हम नाम देते हैं MongoDB शेल को। ठीक है, तो जो भी शेल का जितना भी डाउनलोड है वो हम इसको यहीं पे कर देंगे और यहाँ पर उसको एक्सट्रैक्ट करके ले आएंगे। बेसिकली डाउनलोड्स पे जाते हैं, MongoDB शेल हमारी डाउनलोड हुई होगी, जिप फोल्डर ही हमें वो पड़ा हुआ है, इसको हम लोग ओपन कर लेते हैं और इस फोल्डर में आके क्या कर देंगे, इसको यहाँ पे एक्सट्रैक्ट कर देंगे। एक्सट्रैक्ट यहाँ पे क्लिक करेंगे तो जो भी उस जिप फोल्डर के अंदर जितनी भी फाइल्स थी वो सारी की सारी फाइल्स हमारी यहाँ पे क्या हो जाएंगी, एक्सट्रैक्ट हो जाएंगी। यहाँ पे भी हमको एक बिन फोल्डर मिलता है। बिन फोल्डर के अंदर जाएंगे तो यहाँ पे एक हमको फाइल मिलती है mongodb.exe। ये हमारी एक एग्जीक्यूटेबल फाइल है जो कि MongoDB जो सेल है उसको एग्जीक्यूट करती है। यहाँ पे सेंड रूम का ऑप्शन पे क्लिक करके एक शॉर्टकट बना लेंगे अपने डेस्कटॉप के लिए, ताकि बार बार हमें क्या हो, यहाँ पे आना ना पड़े। हमको एक शॉर्टकट मिल जाएगा तो डायरेक्टली उसको क्लिक करेंगे तो हमारा जो MongoDB.execute फाइल है वो हमारी रन होना स्टार्ट हो जाएगी। ठीक है, तो इसलिए हमने यहाँ पे MongoDB शेल के लिए एक अलग से फोल्डर और इसके लिए एक अलग से शॉर्टकट बना लिया है। ऑलराइट, तो इस तरीके से हमने शॉर्टकट बना लिया है। अब हम इस फाइल को प्रोग्राम फाइल्स के अंदर भी वेरीफाई कर लेंगे। MongoDB फोल्डर आपका बन गया होगा। MongoDB फोल्डर के अंदर सर्वर है, सर्वर जिस भी वर्जन को सेलेक्ट करोगे उसके अंदर बिन फोल्डर होगा और यहाँ पर आप देख सकते हो सारी फाइल्स आपकी यहाँ पे अवेलेबल है। तो इससे हमको ये कंफर्म होता है कि हमारा इंस्टॉलेशन सक्सेसफुल हो चुका है। डिफरेंट टाइप्स ऑफ फाइल्स आपको यहाँ पे मिल जाएगी। लॉग फाइल मिलेगी आपको, यहाँ पे डेटा फाइल मिलेगी, डिफरेंट टाइप्स ऑफ जो फाइल्स हैं वो आपको यहाँ पे मिल जाएंगे। तो यहाँ पर हमारा जो इंस्टॉलेशन है वो सारे हमारे कंप्लीट हो चुके हैं। ठीक है, ये डिफरेंट फाइल्स हैं। यहाँ पे भी आपको एक MongoDB mongo.execute फाइल, mongoose.execute फाइल मिलती है। तो ये हमारे डिफरेंट एप्लीकेशंस हैं MongoDB के, जो ओवरऑल हमको जब रन करने होते हैं तभी हमारा जो ओवरऑल कनेक्शन है वो पूरा स्टेब्लिश होता है। ओके, तो बढ़ते हैं आगे। और यहाँ पर जो हमारा जो mongo.execute है, डिफरेंट फाइल्स हैं। तो शॉर्टकट को क्लिक करेंगे तो हमारा जो MongoDB शेल है वो हमारा रन होना स्टार्ट हो जाएगा। बिन के अंदर जाएंगे, mongoose.execute फाइल को यहाँ पे ओपन करेंगे तो जो हमारा जो MongoDB की जो सेल है वो यहाँ पे क्या हो गई है, रन हो रही है। ठीक है, तो यहाँ पर आप देख सकते हो कि प्लीज़ एंटर द MongoDB कनेक्शन स्ट्रिंग। तो ये कनेक्शन स्ट्रिंग हमको कहाँ से मिलेगी, हमने MongoDB कंपस जो एप्लीकेशन है उसमें देखा था कि कनेक्शन स्ट्रिंग जो है वो आप हमको विजिबल थी। तो यहाँ पर सर्च करते हैं MongoDB कंपस, या सिंपल आप कंपस टाइप करोगे तो सजेशंस में आ जाना चाहिए। MongoDB कंपस मिल गया, इसको ओपन करते हैं। जब इसको ओपन करेंगे तो वहाँ पर हमको जो कनेक्शन स्ट्रिंग है वो हमको डिस्प्ले हो जाएगी। वही कनेक्शन स्ट्रिंग हमको यहाँ पे पास करनी होती है। तो स्ट्रिंग को कॉपी कर लेते हैं, कमांड प्रॉम्प्ट में चलेंगे, इस स्ट्रिंग को वहाँ पे MongoDB शेल में जो हमारा जो विंडो ओपन है उस विंडो में पेस्ट कर देंगे। तो हमारा जो कनेक्शन है वो सक्सेसफुल स्टेब्लिश हो जाएगा। ठीक है, ये नेटवर्क के ऊपर नहीं है, ये डेटाबेस का आपको कोई नेटवर्क पे एक्सेस नहीं कर सकता, ये सिर्फ आपके लोकल पे चल रहा है, इसीलिए लोकल होस्ट का और उसका पोर्ट वगैरह वगैरह है। तो यहाँ पर इसको हम टेस्ट करते हैं। टेस्ट करने के लिए mongoad इज़ नॉट डिफाइंड। ठीक है, तो ये इससे पता चल गया कि हमारा जो कनेक्शन है वो हमारा सक्सेसफुली स्टेब्लिश हो चुका है। ठीक है, ऑलराइट, तो बढ़ते हैं आगे। यहाँ पर हम शो डेटाबेस कर लेंगे। तो यहाँ पर हमारा बोल रहा है शो DBS। ओके, तो यहाँ पर हमको जो डिफरेंट डेटाबेसेस हैं जो बाय डिफ़ॉल्ट बन के आते हैं, जैसे एडमिन, कॉन्फ़िग, लोकल, वो डेटाबेसेस हमको यहाँ पे दिख रहे हैं। तो MySQL केस में कमांड था हमारा शो डेटाबेस, यहाँ पर हमारा उन्होंने शॉर्ट फॉर्म में कर दिया शो DBS। ठीक है, तो शो DBS यानी कि जितने भी आपके MongoDB में जितने भी डेटाबेसेस बनेंगे वो सारे डेटाबेसेस आप क्या कर लोगे, यहाँ से लिस्ट उनकी चेक कर सकते हो। ऑलराइट, तो अब हम CRUD ऑपरेशंस को MongoDB में किस तरीके से परफॉर्म करेंगे इस पे बढ़ते हैं आगे। और CRUD ऑपरेशंस एज यूजुअल क्रिएट, रीड, अपडेट एंड डिलीट, इन सभी चीज़ों को हम किस तरीके से परफॉर्म करेंगे अपने MongoDB में, उन सभी चीज़ों को डिटेल में देखते हैं। ठीक है, तो इन फ्यूचर आपको शॉर्टकट वगैरह बना लेने चाहिए ताकि आपको बार बार उस फोल्डर में ना जाना पड़े, इसलिए शॉर्टकट हमको हेल्प करते हैं। और जब भी आप रन करोगे तो आपको सिंपल क्या देना होगा, कनेक्शन स्ट्रिंग देनी होगी। जब आप कनेक्शन स्ट्रिंग दोगे तो आपका जो कनेक्शन है वो सक्सेसफुली स्टेब्लिश हो जाएगा। ये कनेक्शन स्ट्रिंग आपको अपने कंपास में मिल जाएगी। ठीक है, और अगर आपका कभी कनेक्शन स्टेब्लिश नहीं हो रहा है तो सर्विसेज में जाके आपको MongoDB सर्विस को चेक कर लेना है कि वो रनिंग है कि नहीं। अगर वो रनिंग नहीं है तो या तो आप मैन्युअली या फिर आप कमांड से उस MongoDB सर्विस को आप अपने सिस्टम पे स्टार्ट या स्टॉप कर सकते हो। तो यहाँ पे चेक करते हैं, जो हमारा MongoDB है, MongoDB ये हमारा अभी क्या है, रनिंग है। क्योंकि रनिंग ही था इसीलिए हमने जैसे ही स्ट्रिंग पास की हमारा कनेक्शन इमीडिएटली स्टार्ट हो गया। अगर ये स्टॉप्ड होती तो हमारा जो कनेक्शन है वो स्टेब्लिश नहीं होता। तो ये कुछ की इन्फॉर्मेशन है। सेल का हमको शॉर्टकट बना देना है, हमारा जो MongoDB है वो रनिंग होना चाहिए, एंड वी आर ऑल सेट टू स्टार्ट कोडिंग। तो सबसे पहले शो DBS करते हैं। शो DBS करेंगे तो ये जितने भी हमारे MongoDB में लोकल पे आपके जितने भी डेटाबेसेस बन चुके होंगे वो सारे डेटाबेसेस आपको यहाँ पे दिखाएंगे, जैसे एडमिन, कॉन्फिग, गुवी, कैपस्टोन, लोकल, माई गुवी, सारे आपको जो डेटाबेसेस हैं वो यहाँ पे दिख रहे हैं। ठीक है, तो एक नई फाइल बनाते हैं। इस नई फाइल में हम सारे MongoDB के जो भी ऑपरेशंस परफॉर्म करेंगे उनको यहाँ पे लिस्ट कर लेंगे, ताकि वो आप अपने जब फ्यूचर में परफॉर्म करो तो उसके रेफरेंस आपको मिलना चाहिए। तो सबसे पहला कमांड हमारा होता है शो DBS का, जो हमको हेल्प करता है सारे डेटाबेसेस को लिस्ट करने में। फिर यूज़ और उस पर्टिकुलर डेटाबेस का नाम जिसको आप यूज़ करना चाहते हो। तो अभी हम यूज़ करेंगे कंपनी को। ठीक है, तो यहाँ पर हम सबसे पहले शो DBS तो यूज़ कर लिया, अब करते हैं यूज़ कंपनी। तो यूज़ कंपनी करेंगे तो जो कंपनी डेटाबेस है वो आपका स्विच हो जाएगा, और अब आप जो भी कमांड डालोगे तो वो कंपनी डेटाबेस पे ही आपके सारे कमांड चलेंगे। यहाँ पे जिसको हम डेटाबेस बोल रहे हैं वो बेसिकली टेक्निकली उसको हम लोग कलेक्शन बोलते हैं। तो शो DBS और उसके बाद उस DBS यानी कि डेटाबेस के अंदर आपको जितने भी कलेक्शंस होते हैं वो सारे मिल जाते हैं। जिस कलेक्शन को यूज़ करना है यूज़ कमांड, और उसके बाद उस कलेक्शन का नाम। जैसे हमें कंपनी को यूज़ करना है तो हम यूज़ कंपनी करेंगे, तो हमारा जो पूरे डेटाबेस में जो कंपनी कलेक्शन है वो हमारी स्विच हो गई है। अब हम जो भी ऑपरेशन परफॉर्म करेंगे वो कंपनी कलेक्शन में परफॉर्म होगा। तो सबसे पहला हमें क्या करना है, CRUD ऑपरेशंस करने। तो सबसे पहले हमें इंसर्ट करना है, या टेक्निकली बोलने क्रिएट करना है। तो उसके लिए हमारे पास इंसर्ट करने के लिए क्या होता है, हमें यूज़ करना है db.employee। एम्प्लॉय बेसिकली यहाँ पे कलेक्शन का नाम है जो हम यूज़ कर रहे हैं। उसके बाद हमें इंसर्ट फंक्शन यूज़ करना है। अब इंसर्ट के लिए हमारे पास डिफरेंट ऑप्शंस हैं। अगर आपको सिंगल इंसर्ट करना है तो होता है इंसर्ट वन, और उस फंक्शन के अंदर आपको अपना जो डॉक्यूमेंट है वो आपको भेज देना है। अब डॉक्यूमेंट क्या होते हैं, जेसन होता है, तो जेसन बना लेते हैं। जेसन बना रहे हैं हम लोग, हमने नेम दिया है अनीश, रोल दे देते हैं डेवलपर, सैलरी दे देंगे समथिंग लाइक 50,000। ये जो एक ऑब्जेक्ट बन रहा है ये ऑब्जेक्ट क्या है, ये जेसन ही तो है। तो जेसन हम इंसर्ट वन के अंदर पास कर देंगे, कॉपी करके पेस्ट करेंगे, रन करते हैं। एक्नॉलेज्ड ट्रू मिला, यानी कि ये जो रिकॉर्ड हमने एक भेजा, जो डॉक्यूमेंट एक भेजा, वो डॉक्यूमेंट एम्प्लॉय नाम की कलेक्शन में क्या हो गया, इंसर्ट हो गया। ठीक है, अभी हमने इंसर्ट वन किया है तो एक ही जो डॉक्यूमेंट है वो इंसर्ट हुआ। सिमिलरली हमारे पास क्या होता है, इंसर्ट मेनी। इंसर्ट मैनी आपको हेल्प करता है एक साथ ढेर सारे रिकॉर्ड को इंसर्ट करने में। अब अगर मल्टीपल रिकॉर्ड्स हैं तो सीधी सी बात है आपकी एरे लगेगी। ओके, ठीक है, तो अब एक रिकॉर्ड हम भेज रहे हैं अनीश, जो भेज चुके हैं। अब यहाँ पे नेम चेंज कर लेते हैं, लेट इट बी अरफा, फ्रंट एंड डेवलपर, और सैलरी ले लेंगे समथिंग लाइक 150। ये हमारा एक रिकॉर्ड है। और इस डॉक्यूमेंट में हम क्या करेंगे, एक नई फील्ड ऐड कर देते हैं, एड्रेस। ठीक है, तो एड्रेस में यहाँ पे दे देंगे बंगलोर, और एड्रेस दे देते हैं या फिर स्किल्स दे देते हैं। तो ये बेसिकली ये ब्यूटी है हमारे MongoDB की, कि आप हर एक डॉक्यूमेंट, एक कलेक्शन के अंदर जितने भी डॉक्यूमेंट हैं वो एक दूसरे से टोटली डिफरेंट या फिर सिमिलर हो सकते हैं। एक्चुअली में सिमिलर होंगे क्योंकि एक कलेक्शन एक ग्रुप ऑफ इंफॉर्मेशन को होल्ड करेगा, बट जो वेरिएशंस हैं वो डेटा में हो सकती हैं। एक और रिकॉर्ड बना लेते हैं, क्योंकि इंसर्ट में नहीं कर रहे हैं तो कॉपी करके पेस्ट कर लेंगे। यहाँ पे कुछ मॉडिफिकेशंस कर लेंगे, जैसे कि नेम दे देते हैं चंदन, रोल दे देंगे फ्रंट एंड डेवलपर, एंड सैलरी लेट इट बी समथिंग 25। और स्किल्स में क्योंकि फ्रंट एंड है तो HTML और CSS दे देते हैं। और यहाँ पर हम एक नई की दे देते हैं, जिसको नाम देंगे समथिंग लाइक एड्रेस, और एड्रेस में हम दे देंगे एक इसमें एक ऑब्जेक्ट बना लेते हैं, इसको फर्दर हम नेस्ट कर देते हैं, और सबसे पहला देंगे कि इसका देंगे एड्रेस 1, और एड्रेस 1 में लेट सपोज चेन्नई, और एक और की वैल्यू पेयर यहाँ पे दे देंगे विथ कॉमा एड्रेस 2, और यहाँ पर दे देंगे बेंगलोर। ठीक है, तो इस तरीके से हमने क्या किया, इंसर्ट मेन्यू से एक ही बार में हम ढेर सारे जो रिकॉर्ड्स हैं वो क्या कर सकते हैं, यहाँ पर इंसर्ट कर सकते हैं, और हर रिकॉर्ड एक दूसरे से सिमिलर हो सकता है, सेम हो सकता है, और इंटायरली डिफरेंट भी हो सकता है। तो इस तरीके से हमने इंसर्ट 1 आपको हेल्प करता है एक रिकॉर्ड को इंसर्ट करने में, इंसर्ट मेन्यू आपको हेल्प करता है ढेर सारे रिकॉर्ड को इंसर्ट करने में। कॉपी करते हैं, पेस्ट करते हैं, कॉपी सही से नहीं हुआ, दोबारा से चलते हैं VS कोड में, फिर से कॉपी करते हैं Ctrl+C और Ctrl+V करेंगे तो यहाँ पे पेस्ट हो जाएगा। अब रन करेंगे तो आप देख सकते हो एक्नॉलेज्ड ट्रू मिला। अब हम करते हैं CLS, और अब यहाँ पर सबसे पहले रिकॉर्ड तो हमारे इंसर्ट हो गए, क्रिएट हो गया। अब करते हैं फेच यानी कि रीड करते हैं। तो यहाँ पे लिखेंगे db.employee, ये एक सेम सिंटेक्स हमेशा चलेगा। db के बाद आपको एक कलेक्शन का नाम देना होगा, उस कलेक्शन पे आपको जो परफॉर्म करना है वो लिखेंगे find.pretty। तो बहुत ही प्रेटिएट फॉर्म में ये आपको जो भी इंफॉर्मेशन है, जो भी अभी तक आपने उस कलेक्शन में इंसर्ट किया है, वो सारा इंफॉर्मेशन आपको दे देगा। तो जैसे हमारा होता है सेलेक्ट एस्ट्रिक फ्रॉम टेबल नेम, यहाँ पे होता है db.employee यानी कि db डॉट कलेक्शन का नाम, और find.pretty हमारा एक कॉस्मेटिक चेंजेस होता है डेटा में, ताकि आपको एक ये ब्यूटीफाइड जेसन दिखाए, क्योंकि सारे डॉक्यूमेंट्स हमारे जेसन के फॉर्म में ही होंगे, तो एक ब्यूटीफाइड जेसन हमको दिखाता है। तो इस तरीके से आप फेच कर सकते हो। उसके बाद अगर आप को डिलीट करना है या अपडेट करना है, सबसे पहले अपडेट करने का देख लेते हैं। अगेन सेम सिंटेक्स, db डॉट कलेक्शन का नाम हमारा एम्प्लॉई है। उसके बाद हम अपडेट 1 फंक्शन को यूज़ करेंगे या अपडेट फंक्शन को यूज़ करेंगे। अपडेट करने के लिए हमारे पास ढेर सारे फंक्शंस हैं, अपडेट 1 हो गया, अपडेट मेनी हो गया। अगर आप मेनी करते हो तो आप कोई कंडीशन दोगे तो ठीक, नहीं दोगे तो ये कंडीशंस जो आप अपडेट करोगे वो सारे डॉक्यूमेंट्स पे आप एम्प्लॉई हो जाएगी। ठीक है, तो पहला ऑब्जेक्ट इसमें जाता है कि अगर आपने कोई कंडीशन देनी है तो ठीक, नहीं देनी है तो सेकंड में आपका जाता है सेट। ठीक है, सेट में क्या है कि जो इन्फॉर्मेशन आप अपडेट करना चाहते हो वो आपको यहाँ पे देनी है। तो हम यहाँ पे एक नया चीज़ इंसर्ट करना चाहते हैं, जहाँ पे जो कंट्री हमारी की नेम होगी उसकी जो वैल्यू है वो इंडिया हो जाए। अगर ये की एग्जिस्ट नहीं करेगी तो वो इस की को बना देगा। ठीक है, तो इसका कॉपी करते हैं और सेव करते हैं, तो आप देख सकते हो कि कितने मॉडिफाई हुए, 3 हुए, यानी कि तीनों रिकॉर्ड हमारे मॉडिफाई हो गए। अब जरा दोबारा से सारा डेटा निकालते हैं, तो आप देख सकते हो किसी में भी कंट्री नाम की थी नहीं, लेकिन कंट्री नाम की क्या हो गई, बन गई है। राइट, तो इस तरीके से हमारा जो अपडेट है वो हम MongoDB में कर सकते हैं। अगर आप यहाँ कोई कंडीशन दे दोगे कि उसके लिए करो जिसकी ईमेल ये हो या जिसका नाम ये हो, तो वो चीज़ जो जो आप सेट में भेजोगे वो सिर्फ उस पर्टिकुलर के लिए वो अपडेट कर देगा। ठीक है, बढ़ते हैं आगे डिलीट के लिए। डिलीट का सिंपल db डॉट कलेक्शन का नाम एम्प्लॉय, और यहाँ पर आप कर सकते हो डिलीट। और अगर आप यहाँ पे कोई कंडीशन दे दोगे, डिलीट 1, डिलीट मैनी, डिलीट ऑल, अगर आप यहाँ पे कोई कंडीशन दे दोगे तो वो उस रिकॉर्ड को डिलीट कर देगा। जैसे अगर हम कोई एक आईडी पास कर दें, तो आईडी यहाँ पर ये एक हमारी ऑब्जेक्ट आईडी है, यानी कि उस डॉक्यूमेंट की आईडी है, उसको यहाँ पे हम पास कर देंगे, और इस तो क्या कर देगा कि इस पूरे कलेक्शन से उस डॉक्यूमेंट को डिलीट कर देगा जिसकी आईडी इससे मैच हो जाएगी। आईडी मैच नहीं हो रही क्योंकि सिंटेक्स एरर है, तो यहाँ पर आपको कर्ली ब्रैकेट या फिर फ्लावर ब्रैकेट्स को यूज़ करना होता है। ठीक है, अब हमने फ्लावर को यूज़ कर लिया है। कॉपी करते हैं, पेस्ट करते हैं, इस बार रन करेंगे तो हमको क्या मिल गया, एक्नॉलेज्ड ट्रू मिल गया, यानी कि वो रिकॉर्ड हमारा डिलीट हो चुका है। अगर हम सारा रिकॉर्ड देखें तो हमको सिर्फ इस बार 2 रिकॉर्ड ही मिल रहे हैं, तो इससे हमारा वेरीफाई होता है कि जो रिकॉर्ड्स है वो हमारे डिलीट हो गए। ऑल राइट, तो इस सेशन में हमने MySQL सर्वर, MongoDB दोनों सर्वर को इंस्टॉलेशन देखा, दोनों में किस तरीके से हम CRUD ऑपरेशंस को परफॉर्म करते हैं, वो सारी चीज़ें हमने डिटेल में समझी। मिलते हैं आगे आने वाले सेशंस में, तब तक के लिए टेक केयर, बाय बाय।
Hey guys, welcome to the section A, session number 37. So let's understand the job sequence problem using greedy method. So it is our most interesting concept in a DSA. So let's begin with an example part over there. So coming back to the specific notepad over here.
So I'm just going to create one specific table, so where I can have some kind of a jobs over there. So I'll be creating some kind of a jobs and profits here. So I'll be creating like a little bit like this. So here we are having to divide it into the 3 sections. So first section, I'm just going to tell, okay, there are all the specific jobs over there, and whatever the profits over, you are going to get it here. And I'm going to mention here the jobs, profits, and the specific deadline for it. So imagine I have a one more job, that is why I'm going to do it for the J1 jobs over there, and we'll be having a J2 job, and we'll be having a J3 here, and J4 and J5 over there. Okay, so this is going to be the specific scenario. So let's take this example and understand. So we are going to have, as I said, we are having a jobs here. We are going to tell, we are going to have the profits, we are going to have the specific deadline over here. So before that, I'm going to tell you one thing. Like imagine you're going to have the specific, if someone offers you some kind of a package like 10 LPA, 20 LPA, 30 LPA, 40 LPA. So which you are going to use, whichever will be the highest, you are going to take that specific job, right? Take that specific package. If imagine if that specific is gone, so then you will come to the next lowest package, right? So same way, even whatever the jobs I'll be giving you, like imagine I'll be giving you J1 job, J2 job, J3 and J4 jobs. So the 4 jobs has been offered you. So J1 is telling I'll be giving here as a 20 lakh, he is giving 30 lakhs, he is going to give 20 lakhs again, he is going to tell you again 15 lakhs over there. So first you will be looking onto the job number, that is J2 here, and you have only 1 year of time. So you have only 1 year of time. You got the 4 jobs as a freelancing and you wanted to complete. So in the 1 year you will be occupying, imagine the job 2 you are going to select, which is giving 30 LPA, you will be doing into the 7 months over there. So now you are having 3 months still now. So in 3 months you will see which is the job you can do it. Either a 20 LPA, 20 LPA, 15 LPA. 20 LPA jobs take at least 6 months. You don't have time, you have only 3 months. And again next 20 LPA job, it will take more than 8 months. Again, you don't have only 3 months. And 15 LPA job can be done in 3 months. So you are going to select this job as well. So you are going to select J2 and J4, and you got the profit of 45 lakhs, and you are selecting in this way. So this is one overview of it. So we'll see how exactly a job sequence is going to work over here. So imagine here going to have a specific job 1, you are going to have a job 2, and we have something job 3 over here, job 4 and the job 5 here. And the job 1 profit is giving you 20 rupees, and job 2 is getting here as a 15, and a job 3 is going to get it as a 10 and 5 and 1 over here. Okay, so job 1 is saying my job has to be done in 2 years, and he's saying I can wait only up to 2 specific hour over here. So you can just tell here as what a deadline is there, right? So the deadline you can treat it as hours. Okay, you can treat it as hours for right now. So it's telling job 1 is telling I can wait up to only 2 hours. If you want, if you can do the job, you do it, or else I cannot wait. And job 2 is also saying I can wait up to 2 hours. So job 3 is saying I can wait only 1 hour. Job 4 is telling I can wait up to 3 hours. In 3 hours you can do it whenever you want. Again, job 5 is saying it can be doing into the 3 hours itself. Okay, so now if I try to do this specific thing, so we have the specific maximum 3 hours, right? So I'll just tell 2, 0, 1, 2 and 3 over here. So we're going to mention here 0 to 1, and there is a job between 0 to 1 to 2, and there is a time between slot 1 to 3 over here, right? So we have the specific slots available in this way here. So here what I'll be doing here is let me draw these things so properly. So let's tell here like this 0 to 2 to 3 over here. Okay, so now in this case I'm going to tell, okay, first I'm going to look onto the, so this is me. Okay, so I'm going to tell, I'm going to draw, this is going to be me. So I'll be like, I'm putting one microscope 2 here to the specific thing. Okay, I'm just first what I'll be seeing here is who is giving me more money. So first I'll look onto the, every person will see that itself, right? Where I'm getting more money, where I'm getting more profit, that job I'm going to select it, right? So I'm going to put the I for the job 1. Okay, job 1 is giving 20 rupees. That's great. It takes 2 hours in my slots. It is available. Yes, my entire slot is available. So I'm just going to block the calendar for this. I'm just going to tell I'll be blocking this specific job J1. So that is going to take it for the specific J2 here, right? So I'm going to block it. I'm going to tell, okay, job 1 has been occupied now. Job 1 is occupied over there. Then next, this is done. So next I'll be looking which is giving more profit. The 15 is giving more profit, right? So 15 is giving as a more profit. So for 15, I'll just
see what is the deadline. Deadline is 2. Okay, 2 hours is already occupied. So I'll tell, okay, I can have any previous slot so that I can complete before the J1 job. Yes, I have one slot available from 0 to 1. It is a free slot. As the job 2 saying me, he can wait up to 2 hours, right? So what I'll do here is, I have a previous slot available. I am going to complete the job 2 first and I'll be sending him back. Then I can complete my job 1 as well, right? So I have a slot available. So he can wait up to 2 hours. Even the slot is available. So I'm just going to occupy the job 2 over here. This has been done. So I'm going to tell the job 2 is also selected with the profit of 2 over here, right? So then, sorry, with the profit of 15. Next, I'm going to see the job. Next, I'm going to look on to the 10. Okay, I'm getting a 10 profit. So job 3 is saying me, he can wait only up to 1 hour. He is saying he can wait up to only 1 hour. Between 0 to 1, he can wait. He cannot wait more than. But already 0 to 1, the slot is already booked. And 1 to 2 is already, leave it about 1 to 2. In the 0 to 1, already the slot is booked. So I don't have time to do it for the job 3. So this job, I'm just going to reject it. Okay. The next profit is more. That is 5. 5 is the next profit. I'm getting more, right? So it is job 4. Job 4 is saying I can wait up to 3 hours. Okay, he can wait up to 3 hours. My job 0 to 1 slot is filled, 1 to 2 slot is filled. But he is saying I can wait up to 3 hours. So the slot is available. So I'm just going to mark the job 4. I'm just going to mark it over here. So the job 4 is selected. So the all is getting filled. So job 5 is telling I can wait up to 3 hours. But I don't have any slot. So it is going to get rejected. It is going to get selected. So in this case, job J1, job J2 and job J3 has been selected. So I can just tell J2 plus J1 plus J4 has been selected. So the profit which we are getting here is 25 plus 15 plus 5. So overall we got 35. We got the profit of 40 rupees over there. So this is how we are going to get the specific thing to us, right? So this is how the specific scenario we are going to get it. Okay. So for this, I'm just going to draw one table and explain you into the another way as well if you want. So you can see, you can understand. So basically the real time we are going to work it in this specific scenario. So we'll be having one specific table. So inside this specific table where we are going to apply one kind of a formula and we are going to write it over here. So I'm just going to tell here we are having the job J1 here and I'm just going to tell this is the jobs which we are getting occupied. Okay. And this is going to be your job sequence and we are going to tell what is the profits we are going to get it. I'm going to just draw the specific header part. So this is going to be for the J1 and this is going to be for your J2 and this is going to be there for your J3 over here. So now let's try to add the specific data inside it. So I'm just going to tell this is going to be your jobs. This is going to be your slot. This is going to be your job sequence. This is going to be your profit which you are getting it. So we have a J1 job, J2, J3 and J4 jobs over here, right? So inside this J1, J2, J3 jobs. So inside this specific slot, I'm just going to tell in the first J1 job is getting selected, right? Because I'm going to tell J1 job has the 120 slot. So I'm going to tell the slot between 1 to 2, I'll be selecting it. So what is the job sequence? The job sequence is only J1. What is the profit we got? The profit we are getting 20. So this is done. So in the job J2, already J1 job is going on. So job J2, I'm going to select, I'm going to tell job J2, can I select it or not? In the job J2, we are having how much? That is we are having. So we have another job, right? So I'm just going to mention here as another box over here. Basically, this is going to be another box. Okay. So this I missed it. That is going to be the job J5. So in this, I'm going to tell in the job J2, 1, 2 is already going. Can I do it into the 2? So we are available. It is 2 hours, right? We are having a availability of 2. So I have a slot 0 to 1 again. So I'll tell, okay, select this slot between 0 to 1. I can do it. So I'll be telling J2 I'll be selecting, and along with that previously J1 is already going job. So J2 I'll be selecting. The profit we got it here as mainly for the job J1 already 20 we got, and we got for the job J2 15. So the profit here is total, or that is 35 over here. Now just come to the job J3. So in the job J3 I'll tell 1, 2 is already going on, 0, 1 job is already going on, J1 is selected, J2 is already selected. Here now I'm going for job 3. Job 3 is saying he can wait only up to 1 hour. So for the 1 hour, 0 to 1 hour, already this slot is filled. So I'm just going to ignore this. I'm just going to tell I'm not going to select this specific job over there. So I'm going to ignore this specific job. So let's tell it into this red color. So I'm just going to tell, so this specific jobs, I'm just going to ignore it. I'm just going to tell this specific job, I'm not going to specifically select it over there. Okay. So this is how the
thing you can just add the colors like this, like for the better understanding. That's it. Okay, so this job is not getting selected now. So now let's come back to the job J4. So here the profit will be 35 itself over here. So the job J4 is telling I can wait up to 3 hours. That's great, right? Already the job 01 is selected. Job between 1 to 2 slot is selected. We have a availability of this slot, that is a 2 to 3, that I can do the job of the job J4 because he is ready to wait up to 3 hours. So I'll be telling here. So J1 is selected, J2 is selected. Again J4 is getting selected. The profit is for the previous is 35 plus this for the job J4 is 5. So I'm going to tell 40 is the specific job I have been selected. For the J5 is telling 3 is the 3 hour he can make it, but my all the slots is filled. So the 0,1 is filled, 1 to 2 is filled, again 2 to 3 is also filled. So I cannot select. J1 is already selected, J2 is selected, J4 is selected. I cannot select the J5 because we don't have the specific space to it. So again I'm just going to tell I cannot select you as well. So I'm going to tell I cannot select this specific job also. So I'm not going to select this specific job also. Okay, so this is what this specific thing is been going on here. Okay, this is how the table you can draw it, and you can have a look onto it. So this is how about the specific job sequence. So let's understand another example over here. So let's understand another example. So let's try normally. So I'll just tell it over here. Okay, so imagine I have another that is jobs over here. So I'm going to tell we have the specific jobs, that is we have a J1 job. So we have a J2 job over here. So it's giving, okay, so it is having a J1 job, J2 job, and we have a J3, and we have a J4 job, J5, J6 and J7. So we are having a 7 jobs here. So let me write the specific profits as well. So I'm going to tell the profits we are having here is we are having the profit as a 35, we are having as a 30, we are having here as a 25, we are having the profit as 20 here, again we are having a 15, we are having a 12, and we have a 5 here. So I'm going to write the specific deadlines for it. So deadlines is 3 hours, 4 hours, 4 hours, 2 hours, 3 hours, 1 hour and 2. So basically the maximum is 4 here. So I'm going to draw here. So 0, 1, 2, 3 and 4 over here. So these are all the jobs I can have it. So right. So these are all the specific jobs I can have it, 0 to 4. So now I'm going to look which is going to be the maximum profit. 35 is the maximum profit. So that he's telling he can wait up to 3 hours. So the job is J1. So I'm going to tell from 2 to 3, I'm just going to place the job J1. Okay. Next job is basically which is giving more profit, that is 30. So 30 is the job J2. He's telling he can wait up to 4 hours. So we have a slot available. So I'm just going to tell J2 is going to be placed over here. So here we got the, what is the profit? We got 35. Here we are getting the 30 as the profit over there. Job J2 is also selected. Again, job 3 is selling. He is telling I can wait up to 4 hours, and the maximum profit we are getting as a 25 as compared to other. So I have a previous slots available. So I'm going to put it into the 1 to 2. So in the 1 to 2, I'm just going to place the job J3. I'll just tell, okay, I can do it your job in this specific slot, and I can do it. The profit we get as 25. Next, J4 is telling next highest profit is 20, right? So in the 20, can I get this 20? 20 can be done in 2 hours. So in 2 hours, I'm going to tell, okay, 1 to 2 slot is available, whether the next slot is available or not. Yes, the previous slot is available. What I'll do, we have a slot 0 to 1 available. I'll do this specific job as he can wait up to 2 hours. I'll do his job in 1 hour, and I'm just going to send him. So I'll just select 24. The 20 is going to be profit, and 20 is getting selected over there. So next we don't have for the 15 job. So he is telling 3, he can wait up to 3 hours, but all the slots are filled. I'm not going to select. For the next slot 12. So again we have all the slots full, it is not selected. For the next slot, again all the slots are full, it is not going to select it. So in this scenario, the job sequence will be J4, J3, J1 and J2. So the maximum profit we got here is 20 plus 25 plus 35 plus 30, that is going to be, that is 110 is the maximum profit. We are going to use the job sequence problem to solve this specific scenario over here. So I hope you have understood how this specific job sequence works. So that's all for the session, guys. So let's see the coding part into the next session regarding the job sequence using Java. Take care. Bye bye.
Hey guys, welcome back to the session 38. So let's understand the job sequence coding problem into this session over there. So let's begin with the coding part. So in the previous session, we saw like how the specific job is going to be working. So which jobs we have to select based on the higher profit and based on the slots availability and the deadline here, right? So there are the 3 major things that comes into the picture for the selection of the job over there.
So now let's try to create one program that's using a Java. So we are going to import a few of the packages over here. So I'm going to tell here as a import java.util.stars over here. So I'm importing the java.util.star over here. So where we are going to make use of the arrays and the comparator over here. So here I'm going to create one specific class. That is, I'm going to create one class here. That is the class name. I'm just going to create it as a job over here. So for every job, I'm just going to create a job ID. That is going to be the ID here. And for the int, I'm just going to create the deadline for it. So it is also going to be a deadline. And I'm just going to create one variable for the profit as well. Okay. So those are the three variables: the job ID, deadline, and the specific profit over here. Now, I'm just going to create one specific public class that is a job. That's a constructor job. That's basically takes an input parameter as ID, then it takes the deadline here, and it takes the specifically that is the profit over here. So ID, deadline, and the profit. So this initializes, that is this dot ID, which will be initialized with the ID and the deadline. So I'm going to tell as this dot deadline is going to be the deadline over here. Then this dot profit is been initialized with the profit. We are just creating a constructor to initialize the key value pairs over here. That's it, right? So we have created the one profit stuffs over there. Now again, I'm just going to create an another class. The class I'm just going to create it as specifically a job sequencing class. So that's basically has the takes the jobs and initialize the calculations inside the class over there. So I'm going to create a class, a public, that is going to be a public static void class. That's going to be the class name as job sequencing, sequencing sequencing. So that takes basically a job class, job array here, and I'm just going to pass the jobs here, and here I'm just going to pass the int of n value over here. So once I pass the jobs as what we did here, so when I got the job, what I did whenever I wanted to create a job, right? So whatever the jobs was there, I just initialize into the ascending order, right? So whatever the value will be, whatever the jobs will be there, we are initializing with the ascending order, right? That is the first thing which we did it, right? So then we are going to start putting that jobs inside the values here. That is what we did. So now we are just going to sort the specific jobs in the descending order here. Okay. So we are going to sort the specific jobs in the descending order based out of their profit. If I just make it as a profit as high, so here you can see 20 to 15, 10, 15, 1. It is descending order. From here to here it will be ascending, right? So we need to make it as a descending order here. So first I'm going to tell here a function that's I'm going to use it as arrays dot sort method. So I can use the sort method. So inside the sort I'm just going to pass the jobs. Then after that I need to get the specific new comparator value here. So I wanted to just tell new of comparator that takes the specific jobs over here. Okay, so I'm going to tell here as a take the specific job job as the comparator over there. Okay, so here this is all the things is going to be the. So once I sort it, then I'm just going to create another function that is a public int. We are going to use it as a compare function. Compare. So we are going to compare the two jobs, like so job A has been compared with the specific job B over there. So once I compare the two specific job, I'm just going to return what is the profit of. So B dot profit is there, right? Brief dot profit minus A dot profit. We are going to get it over here. Okay. So that is what the things is going to tell. We got the specific compare after comparing two jobs. We are going to get what is the profit between two jobs over there. Okay. That is what we are going to do here. So once I done, we need to store the result into the jobs, right? So once we compared here, so once we compared what is the job. So here whenever I come here, I compared this job with this. When I come back here, I compared this job with this, right? So like that was the function which we return it. So once we done it, so now we need to store it into the results as well. So for that, what we are going to do here is we're just going to create a specific char, just tell as a character. So where we are going to store the results. Okay, result is equals to new char of character of n over here. So we wanted to store the n values for n jobs for n results, right? So we are going to create one boolean value. So that boolean is going to check whether the slot is full or not. If the slot is returns true, that means the slot is full, or else the slot is been false over here. So we are going to initialize the value to a boolean slot value. Then we are going to check whether the slots, or we are going to just check whether the slots are free or not. For that, I'm going to tell for int of I is going to equals to 0, start with 0 and go till the last job and increment the I value. So here slot of I for the initially mentioned, this slot of I is going to be false for all the things over there. Okay, so we have just initialized all the slots to be free for the initial purpose. So once it is done, now I'm just going to iterate through all the given jobs. Then we are going to make it the slot full, or it is going to be full, or it can be a false or the true. True means slot is full, false means the slot is not full, like that. So I'm going to iterate all the jobs, then I'm going to fill it based on the formula. So let's tell for int start with 0. Okay, then I value should be lesser than or equals to jobs dot length. Then we are going to check here the jobs dot length here. Then I'm going to mention here as I plus plus here. So once it is done, so I'm going to just find the free slot for the job starting from the last possible. So from the last, I'm going to check it whether the slots are filled or not. So for that, I'm going to write the loop here, again the inner loop for int of j, that should be a min value, math dot min value from the n minus 1. Okay, is going to be taken. Then next jobs, from the jobs I'm going to find which is having the minimum slot availability here. Okay, dot deadline. So I'm going to just pass the jobs I dot deadline minus 1 here. Then j is greater than or equals to 0 over here. Okay, j is greater than or equals to 0 over there, and j minus minus. Okay, I'm just going to pass these values over here. Okay, so first int value, it should be the start with which has been deadline. If it is deadline or not, we are going to check it. That's where then j should be greater than or equals to 0 and j minus minus over here. So after this, if the slots is free, we are going to assign the job. That's it. If it is not, we are going to make it as a false. So we are going to tell here as a specifically if the slot of j, if the specific slot of j is equals to false. Okay, that means this slot is available, right? So for that, I'm just going to tell here as a result of j is just going to in the result of j just store that specific jobs id here, jobs of I dot id here. We are just storing that specific job id into the results of j over here. So after doing that, we are just going to make that specific slot of j to be full. That we are going to make it as true here. So then we are just going to break the loop over here. Okay, so this is how the things is going to be there. Now I wanted to create one more function to basically print. So this is a logic which we have written, that is done. Now I'm going to just tell one print ln. We are going to tell the job sequence. So what should be the job sequence? It has to tell me for printing purpose. I'm going to tell that is going to be stored inside the results, right? So I'm going to tell here as a for the basically I'm going to run a for loop. So for int, that is going to start with int of I is equals to 0, I value should be lesser than n and I plus plus over there. Then I'm just going to check, basically first I'm just going to check if the slots is if the slot of I, if it is true, then only you need to print, right? Or else we have not used that specific job, that's it. So the slot of I, if that is true, basically I'm just going to print that specific where is it? So SYSO. So for that I'm just going to print whatever the results of I value will be there. So I'm going to tell the result of the value I and just make it as the new character as the pass it over here like this. Okay, that is done. So now I need to pass the jobs. I need to just pass the values to it. Let's try to pass the one jobs over here. Okay, in the public static environment. So let's try to pass one now input here. So I'm going to tell here the job jobs. For here I'm just going to pass the jobs, so which we have seen. Let's try to see that specific example here itself. I'm going to tell here as a new job. So basically in this I'm just going to pass it here, new jobs and like this. Okay, so here I'll just tell comma. Okay, I'm just going to pass new job 1 2 3. So how many we have input? Let's see how we can pass it. So we have this. Let's try to pass this one. Okay, j1 j2 j3 j4 j5. Okay, so let's make it this as the values 1 2 3 4 and 5, right? So for first thing we need to pass what is the job here. So let me pass whatever I want. I can just pass it here. So I'm going to tell here as a j1. Okay, let me pass this as a j2. Then again I'm just going to pass this as a job 3. So here I'm just going to pass it as the job 4. Then here I'm just going to pass it as a job 5 over here. So after that I need to pass the what is the vertex deadlines and the profits. So the deadlines and the profit 20 15 10 5 1. So I'm going to tell 20 15 10 5 1 over there. So I'll be passing here as comma. I'll just tell here as a 20 and I'm just going to pass it as a 15. and I'm just going to pass it as the 10, and again I'm just going to pass it as the 10, 20, 15, 10, 5, 1, right? So it is going to be 5 and it is going to be 1 over here. Just I'm just passing the inputs over here. Then I'm going to tell double 2 1 double 3. Okay, so I'm going to tell here as a last parameter the deadlines double 1. So I'm going to tell as a double 1, and I'm going to mention here as a double 2 and 3, right? So I'm going to mention here as the 3 over here. So what we have done, double 1, sorry, double 2 1 double 3, right? Okay, sorry, double 2 1 double 3 it was 1 and double 3 it was. So for this, now I'm just going to park it over here. So here we are getting an error. So what is an error we are going? I'm getting an error, invalid character constant it seems. So why? So I think it should be J. If I give it here as a J1, so J1 is not taking. Why? So okay, it is a invalid character constant. Okay, it is giving you in this way. So let's take it something like ABC. Okay, so let's tell job A, job B, and job C, and job D, and job E over here. Okay, so let's take it in this way. So now I wanted to find what is the job sequence and number of the job lines over here. So if I try to calculate the input for this, I'm going to mention. So I'm going to tell here as a for the number of jobs length. So I'm just going to pass it over here. So let's see what is the output we are going to get it over here. So still I'm getting an error here. So why is giving an error here? Okay, 10 we pass, 20 we pass, and value we are just passing as the things. So okay, so what I need to do here is first I need to pass the deadline, then I need to pass the jobs over here. So in the job, what is the, like, let me go to the jobs here. If I go to jobs, okay, deadline I need to first pass, then I need to pass the specific profit over there. So I'm going to tell here as a 20 here, and here I'm just going to mention here as a 2 comma, that is 15. So here I'm just going to mention here as 10 here. Here I'm just going to mention here as 5. Here I'm just going to mention here as 1 over here. So let me delete these things from here. So here I'll be deleting this. I'll be deleting this as well. I'll be deleting this. I'll just put the comma here, and I'll be deleting this specific one over here. Okay. So now we have just passed this data over here. So still we are getting an error. So basically I think I need to give it as the static class here. Static class jobs over here. So yeah, now the specific things is gone. So now once I execute this specific program, so what is going to be the output here? You can see I'm getting the job sequences BAD here. So what we were getting here, BAD. So you can see A is selected, B is selected, and D is selected, right? As it is ditto, you can see the job sequence is BAD over here. So even here B is basically J2, A is J1, and D is J4 here. So this is the jobs which has been selected over here. So this is how the specific jobs things can be calculated. I hope you got the understanding how the job sequence program works. It was a very simple program. Thank you guys. Take care. Bye bye.
Hey guys, welcome to the section 9. So let's begin with the heap concept into this entire section. We are going to look on to be seeing like what is heap, what all the operations in the heap like insertion, deletions, and sorting, and along with that we are going to see with the priority queues and much more into this section. It is going to be an interesting part of it. So what is heap over here basically? A heap is basically again a data structure concept basically which we are going to apply this heap for the specific specialized tree based here. Here we are going to implement using the priority queues as well. So mainly for insertion, deletion, and sorting algorithm. Okay. So we saw insertion, deletions with the various data structure concept into our previous section, and in the same way we can use this sorting, insertion, deletions, and all those things into the more optimal way using heap as well. So that's what it's about the heap. So we are going to implement mainly the heap onto the complete binary trees. Here we are having a two types of heaps majorly, that is going to be the max heap, and there is another thing that is called as a min heap over here. So what is going to be called as a max heap here? A max heap is basically again a given node. The value of I is greater than or equals to the value of its children over there. So basically imagine there is a node I. Okay, I is the specific node I. The value of I node should be greater than or equals to its children. Basically the root node, whatever we are talking about the root node, right? The root node should be greater than or equals to the children's node over here. So such kind of trees we are going to call it as the heap trees over there. So we can see this property ensures that maximum element is at the root of the heap over here. So whatever the maximum element will be there in your tree, that should be present onto the top of your tree. That is going to be the root of it. In other words, root node has a maximum value. That's what I said, right? So this is what about the max heap, and min heap is opposite of the max heap majorly, like the specific root node is there, right? That should be lesser than or equals to the children node.
So in this overall, you can say like the root node will be having the lesser element as compared to the elements which is already present inside our tree over here. So we are going to see a lot of examples with the max trees and all. So we'll see again, heap can be implemented as a binary trees. Again, heap is a binary tree, okay, which I cannot tell as a binary tree because in the binary tree we had like some left, right, that should be, we are having some properties there. So left should be lesser and right should be greater and root can be anything, right? So that is why we have some properties, but in heap, no, they are min heap and a max heap. So we need to take care on the min heap or a max heap property, and we can dedicate, right? It is a specifically a min heap or a max heap, we can differentiate like that. And a binary max heap, we are having it. In a binary max heap, every node's value is greater than or equals to the value of its children. The maximum element is the root children. That is what the max heap, as we said, the root node will be the maximum as compared to its children. So any parent should be greater. So in a tree, we can have 5 parents, 6 parents, right? So whenever you take up the parents node, that should be greater than or equals to its children. That is what about the binary max heap. In the binary min heap, basically, whenever you take the parent node, that should be lesser than or equals to its children. Okay, that is going to be called as a binary min heap over there. And the heap operations, there are several components operation we are going to do it onto the heaps. Mainly we are going to see the insertion into the next sessions, like how we can insert the specific element into a heap, and how we are going to do the bubbling, like bubbling in the kind of, we are going to swap it the things, and we are going to insert an element into a correct position into a tree. Okay, so these all things we are going to take place while insertion. And while deletion, we are going to delete a specific element from the root. Then after deletion, how we are going to rebubble these specific things, right? So again, we are going to call it these conditions for the deletion. We are going to call it as bubbling down. For the insertion, we are going to call it as a bubbling up. Okay. So what is the time complexity and space complexity of it? So if you take up a heap, peak is basically that gives the maximum element of your heap or min element of a heap. That's going to give it as a peep. And the heap are efficient removing a string valuing into a constant time that we go off n. It means like whenever you are trying to insert an element or any element which we are inserting that is already it is a complete binary tree and it is a max heap. Then if you are inserting an element at the last position, right? So if it's smaller than the existing element onto the top, then it is going to be the big O of n, as it is only taking a single operation. And even in the same way, while deleting, even if you try to delete the large like a leaf nodes, then that is also is going to be the big O of n. And if you imagine there are a insertion is happening at the middle or onto the top, or deletion is happening at the middle or onto the top, at that case what happens? At that case the time complexity is going to be big O of log n over there, right? So that again we need to balance the specific max heap or a min heap tree. So in that way it is going to take a more time, and that's why the time complexity is going to be big O of lag n over there. Okay, so now let's look up with an example how the heap is going to be there. So I'm just going to open the notepad over there. So let's see one example over here how this specific tree is going to be there. Okay, so let's try to create one. Let's first understand, let's glance up the binary tree or a complete binary tree. So that's we need to understand first, right? So imagine I'm just going to create one specific element over here. So that's I'm just going to create a specific node A over here, and imagine that is having a node B, and we have a node specific C over here. Okay, so node A, node B, and node C, and node C is having a node D here, and imagine this is F, and it is something F, and it is going to be G over here. Okay, so imagine this is the specific nodes which we are having it. So in this, whether it is a complete binary tree or not. So if I talk about whether this is a complete binary tree, whether it is complete binary tree or the full binary tree. So whether it is a full binary tree or a complete binary tree, yes, it is a complete binary tree because your left right children are equally balanced and it is onto the same level. So that is why it is full binary tree. So whether it is a complete binary tree or not, yes, even this is also a complete binary tree because all the values root nodes has been filled over here, and the parent node also having two children. So it is also going to be the complete binary tree. So this is one example. So let's see with the second example over here. So let's take it here E is a node over here. So imagine I'm just going to make it as a B, then I'm going to make it as a C over here. So instead there's A, B, C. So I'm just going to tell this is going to be 1, this is going to be a node 2. So for the B, I'm just going to draw again a two specific children's, like I'm just going to mention here as a D here, then I'm just going to mention here as a E over here. Okay, so we are having A, B, C, D, E node over here. So now my question is whether it is complete binary tree or not. So yes, this is a complete binary tree. So I wanted to just check. Okay, this has been gone. So let me get back that specific Okay, so I got that specific point. It has been gone for some reason for having tea or coffee. That's fine. Okay, so ABC is there. So now I'm going to mention here as again there is a D. So this is going to have another that is an element E over here. Okay, so we are having a two specific tree now. So now I wanted to check whether this is going to be your complete binary tree or not. Yes, this is a complete binary tree because A, B, C, and when you come back to the B, D and C is there. So it is not C as not having children. That's fine. Basically because on the left hand side it has to be filled, right? So again this is going to be your complete binary tree, so not an issue over here. So if I draw this specific thing over here, if I just draw this specific line, so they have a here, we have a B, then I'll be telling C here, then we have a element D here, then we have an element E. So this is going to be the heap of it. Okay, I can just tell heap is going to be like this. So again if I draw a specific heap for this specific element, like I'm just going to tell A we are having, then B having. So for B we are having D and E. Again we are going to take the C here, and F we are having a G over here. We talk about the specific size of it. 1 2 3 4 5 6 7. 7 is your heap size here. Okay, it is done, so it's completely fine. So here next take another example which is not going to be a binary tree, something like that. So imagine we have an element here, root node, that is A, then we have a specific node that is a B over here, then we have an element that is a C over here. And for this I'm just going to tell for a D, we are having some node here. Okay, and here we are also having some node over here. Okay, so I'm going to tell ABC, D is there. Again I'm just going to mention here imagine that I'll just tell it here as again let's take it here as ABCDE. If I'll take here. Okay, now if I take this as a specific here, whether it is your primary, whether it is a complete binary tree or not. No, it is not going to be a complete binary tree. So A, B is A, for A, B is do two children, for B 2 we are having. So for C here there is no left children, right? So there is a right children but there is no left children here. So in that case it is not going to be the binary tree, right? So it is not going to be the binary tree over there. Okay, that is the another scenario which we are going to take it over here. So when if I just take an again example, that is the fourth example. So we are having A, we are having B, we are having C, and here we are having D, here we are having F. So whether this is a complete binary tree? No, this is also is not a complete binary tree because your left child is not completed. So even you can see in this case the left side has to be filled, but right is not, no worries here. But in this case the left side is not, we are having an empty here, we don't have anything here, right? So that is why it is not going to be the complete binary tree. So if I draw, for this specific thing, if I try to draw this specific if I just try to draw one specific box, like array box over here. So here whether if I just tell here, so if I imagine I'm just going to draw a specific box here. So if I tell here A is going to be there, okay, then I'm going to fill B, then I'm going to fill C here, then I'm going to fill D, then I'm going to fill E. So for at the time of element while filling for the C, so for C we don't have an left node, right? So here this is going to be a dash here, so this is going to be an empty array over here, so F is going to be there. So here it is creating a empty space, so that is why it is not going to be here, it is not going to form the specific heap over here. That is why a complete binary tree is only going to form a heap. So if it is not a complete binary tree, we cannot apply the heap concept over there. Okay, even if I try to draw a specific box for this specific scenario, so here you can see A we can fill, then we have B. So for B we don't have an element children, right? So we don't have a specific children like here and here, so it is a blank, right? So I'm going to, this is going to be blank, this is going to be blank. When I take C, for the C we are having D and F over here. So here it is creating the blank, it is creating the blank spaces over here. So again it is not going to form the specific heap. So overall we can understand if it is a complete binary tree, we are going to form the specific heap, or else we are not going to form the specific heap over there. Okay, so that is what the things comes into the picture. So now let's understand about the max heap and the min heap over there. Okay, so let's understand about the max heap and the min heap over there. So let me write it here itself. So if I just take an example, so let's take a good one here. So let's try to create one specific node of bigger one size. Okay, so I'm just going to create one specific node that is going to be 50 over here, and imagine I have a node that is 30 over here, and we have a node that is 20 here. So this is another node. Okay, so what is going to be about the max heap here means, so we are talking about the max heap here. So max heap here. In the max heap, the formula we understood in the definition, the root node is going to be the higher value. So root node is going to have the more bigger value, right? So you can see here it is 30 is bigger than 50 is bigger than 30, 20 is bigger than 50 is bigger than 20. So it is a max heap. That is a max heap. Again, if I just talk about the another one, that is if I tell here as a 15, again if I just tell here as 10 over here. So you can just take it. So whether this is your max heap, yes, this is also given, this is max heap because it is a complete binary tree again, and it is root node value as a higher value, that is going to be max heap. Again, if I just talk about the element here 8 here, I am just going to tell here the element that is 7. Okay, I can just add anything, so it is going to be your max heap over here. This is going to be the max heap over here. In the same way, I'm just going to draw it again another one. So imagine I'm just going to do it for the min heap over here. So in the min heap, the root node value should be having the lesser value, right? So I'm just going to mention here as a 10 is we are having a 10 is your root, and I'm going to tell here as a 30. Yes, 10 is lesser than 30. That is going to be a fine over here. And again, I'm just going to tell here as a 20 over here. Okay, we are having a 20 here. That is fine. Then again, I'm just going to tell here as a 35. Here, children's nodes are having the greater than the root node. That is what the overall point of saying here, right? So again, I'm just going to tell as a 40. Yes, it is also a min heap. It is a complete binary tree. Again, it is a min heap because the root is having the lesser than its children. Okay, again, here we can have the repetitive elements over here. I can have a repetitive element here. I can have here 20. That is fine. Okay, again, I can have it here as 49 here. That is also is fine. Okay, because the children should be greater than the root nodes over there, the parents of nodes. So this is going to be your min heap over there. Okay, so now if I try to draw what is going to be the specific heap here, so whether what is the h max here, and I wanted to draw what is going to be the h min over here. So again, I'm just going to draw one specific box over here, and here also I'm going to draw one specific box over here. So here it is, sometimes it takes, sometimes it doesn't take, based on my design, right? So let's try to make it now. Okay, now it is going to form the box. Okay, it is not forming the box again. So let's make it here. So let's make it here. I'm going to mention here. So okay, it is not creating. So let me create it here like this box. Okay. So here I am having a box here. So I'm going to tell here as a 50 is going to insert first. Then we are going to insert an element 30. So for a 30 we are having the children's here. So for the 30 then we have inserted, then we are inserting here as an element 20. So for here left hand side we have a children's, that is a 15 we are having. Then we are having 10. Again for here we are having a 8. We are having a 7 over here, right? So this is going to be the maximum 1, 2, 3, 4, 5, 6, 7 is the specific size of it. Okay. So this is going to be the h max heap. So if I wanted to calculate what is going to be the specifically h specific thing, so I'm going to draw another again one more box. So I hope this time the box is going to come properly. Okay, yes, it is coming. So if I just tell about the h min, that is a min heap. So 10 will be there, again 30 will be there, 20 will be there, 35 and 40, and place the 20 and 49. Here you can see there is no any gaps, there is no blank space. So this is all about the concept of heaps over there. Okay, so in the next session we are going to see how we are going to do the operations on heap, like insert operation, deletion operations, and so on. So far we have understood what is heap here, right? So heap is basically a complete binary tree. So we are having two things, that is a min heap and a max heap. A min heap is something which is having the root element should be lesser than it, lesser than or equals to its children, and the max heap is something that is root element should be greater than or equals to its children element over here. And here if there is a blank spaces are forming, then that is not going to be your heap over here. That's all overall story of this heap over here. So let's catch you in the next session.
Hey guys, welcome back to the session number 40. So let's understand the heap operation into the session. So we are going to look on to the how the specific insertion happens and how the specific deletions we are going to do with the heap over there. So let's begin with an example part. So coming back to the specific notepad over there. So let's imagine I'm just going to create one specific nodes. Then we are going to have some the specific array list, how we are going to place it over there. Then let's try to insert some kind of a nodes. Then again let's try to delete it and let's see how this fast swapping is going to happen over there. Okay, so I'm just going to take one example of the max heap over here. So I'm just going to take an example of the specific max heap. So we are going to try to create one specific node, that is a 50 here, and we are going to have an element that is a 30, imagine it, and we are having a specific node that is 20 here, and we have an element that is 50 here, and we have an element that is 10 here. So I'm just going to take, I'm going to taking one sample example. Okay, so we have an element 8 here, and we have an element that is 16 over here. So now first let's understand whether it is going to be your max heap or the not. So first and foremost we need to decide whether it is your max heap or not. So yes, it is a max heap because you can see the root node we are having as a 50 here, and the children's nodes are lesser than or equals to its root node. If I take here 30, 15 and 10 is lesser than 30. If I take 20, 8 and 16 is lesser than 20 over here. So it is going to be your max heap over here. That's fine. So it is going to be your root node here, right? Now let's try to create one specific table over here.
So I'm just going to create a heap here, h is equals to, so I'm going to tell here the heap is going to be a table over here. So inside this specific table, I'm just going to insert some kind of a values over here. So let me erase a little bit over here. So I'm just going to erase like this. Okay, so I'm going to tell here as we are having this, and here we are having this specific element over here. So in this heap, we are having an element, that is I'm going to insert the element. So what all the elements we are having? So I'm going to insert here as a 50 is inserted here. Then I'm just going to insert, that is 30 is there. Then I'm just going to insert 20. Then I'm just going to insert here an element 15 here. And then I'm going to insert an element 10. Then I'm going to insert an element 8. And I'm going to insert an element that is 16 over here. So now imagine I wanted to insert an element here. So I wanted to insert an element, suppose I wanted to insert something called as 70. So I wanted to insert an element that is 70. I'm just going to mention here, I wanted to insert an element that is 70 over here. So now how you are going to store the element here, where you are going to place this specific element. So that comes into the picture, right? So now what I'm going to do here is I'm just going to insert here. So basically here you see, whenever I wanted to insert an element, so let me try to create an same tree over here, right? So let me draw another tree. So imagine we are having a 50 already here. So again we are having an element here already, that is 30 over here, and we have element that is, again we are having 20. Let me draw this again. We have here as a 15, we are having here as a 10 here, and we are having here as a 8 here, and we are having here an element that is 16 over here. So now where you are going to replace? So that is a question, right? So where you are going to insert the element here? So already we are having a heap that is 50, 60. So where you are going to insert? Definitely when I wanted to insert anything, I am just going to insert at the left hand side, right? So imagine I'm just going to insert it here. So I'm just going to tell, I'm just going to insert it here. Okay, I'm just going to insert a specific element that is here, that I'm going to insert it here as a 70 over here. So now the question here is whether is your tree is a heap or not. Whether it is your heap, whether it is specific tree is the heap or not. Now it is not a heap, because if I see here, it is not going to be here, because here if I just take an example of you, so let me control V. So I have here, right? So I'm just going to place this specific onto little bit onto the top here. I'm going to mention here. Okay, now it is fine. So it is not your heap, right? Basically it is not your heap. Why? Because here the root element, whatever the leaf element is there, it is 70. But according to the definition of the max heap, the largest element should be onto the top here, right? So now what we are going to do here is we are just going to shift it over here. So we are just going to shift an element. So we are going to do the swapping here. So I'm going to swap the element here to here. So imagine the 70 comes over here. So in this case 15 is going to go here, 70 is going to come over here, right? So the 70 is going to come here and 15 is going to be here. So still whether it is the map here, still it is the specific max heap? No. Here the root element is still lesser than the children, right? So again I am going to do the another second time swap over here. So after doing the second time swap, so 30 is going to get removed. So 70 is going to come over here. So I'm going to tell here as a 70 is going to up to the top, 30 is going to move on to the top bottom over here. Okay. So whether still it is the thing? No. So again I need to swap again into the onto the topper node of it. So after swapping, 70 will go onto the top and 50 is going to come onto the bottom. So 50 is going to come over here and 70 is going to go onto the top of here. So now this is going to be your max heap. So this is going to be your max heap. So here the conditions is getting satisfied over here, right? So that's an absolutely a perfect example, right? So whenever you are trying to insert it, make sure whatever the element you are inserting, that should be properly balanced in the entire tree over here. So now I'm just going to draw the specific what is the heap of it is going to be. So once I draw it over here, so here after drawing it, I'm just going to tell the black color here. So I'm going to tell the element is first here is a 70, then we are having a 50 here, then we are having 20, then we are having an element 30, then we are having 10, then we are having 8, then we are having a 16, then we are having an element that is 15 over here. So you can see this is going to be your max heap for the after inserting an element that is 70 over here. So here we need to basically one point we need to notice over here always. So always whenever you are inserting, always add the element, to leaf node, right? We need to add the element to the specifically to the leaf node, and if necessary we need to swap the element over here. We need to just apply this swapping over here. So where we are swapping towards the upward. So what we call these things, we call it as a bubbling, right? So we saw something in the PPT, this kind of things we are going to call it as a bubbling over there, right? So this is what about the specific insertion operations inside the specific max heap over there. Okay, there can be another scenario in the insertion itself. Suppose there can be two scenarios here, right? So even I can have another scenario, like let me scroll a little bit down. So now I'm going to have an element here as a 30. So we are having an element 20 here when we were having it element 10 over here. So if I wanted to insert an element that is suppose I wanted to insert 5,6 over here. So 5 is going to insert it hit the here, right? So again after the leaf node, still the element I'm going to insert it over here. So whether this is the max heap, yes, so here it is the max heap. Here no need of sorting, or else here like any kind of swapping here. So the time complexity will be big O of n over here. So in the same here it will be big O of log n. So here it will be a log n, right? Big O of log n, it will be the time complexity over there. So this is one specific example for the insertion purpose. Now let's see an example how we are going to do it for the deletion over here. So let's take an example for the deletion over here. So let's take an example for the deletion over here. So imagine I have a same tree. So I have copied previously. Yes, great. So it has been copied. Now I need to draw again. So I'm going to tell you we have a 30, 50, 30, 20, 15, 10 and 8 and 16 we are having it. So let me remove the element over here. So now I wanted to place it for 2 more times over here. So I'm going to just place it for the 2 more time over here. So I'll just select it and I'm going to I'm just going to place it here. Okay. So here I'm just going to control Z. So first I'm just going to place it here, and again I wanted one more. So again I'm just going to place it over here. Okay. So now we are having the trees over here. So I'm just going to remove the bottleneck of an node from here, and here also I'm going to delete it over here. Now I wanted to delete an elements now. So I wanted to delete the elements here. So I'm just going to delete here. So in the first operation I wanted to delete an element that is 16 over here. So I wanted to exclude the 16 over here. So once I exclude the 16, simply I am going to exclude the 16 element over here. So this has been excluded, and this is going to be your tree. So this is going to be your tree, and this is a max heap. There is no anything. So here it will be the time complexity will be big O of n. Same way, imagine now I wanted to remove an element that, so let's imagine I wanted to remove an element 50 here. So I'm just going to tell remove 50. So I'm just wanted to remove the root node here. Okay, when I want to remove the root node, so what you are going to do? So there are few conditions which we need to satisfy, which we need to follow it. So this is the condition. So whenever I am going to remove the topmost element, whenever we are removing a topmost element, it will be the max element, right? Basically whenever I am trying to remove the black element, it is going to be max element. So we are going to do what? Topmost element will be replaced by the last element here, last element over here. So the topmost element will be replaced by the last element. If I try to create a specific scenario for it, here I'm just going to tell here. So here we have a node here as a 50, and we are having a 30, we are having a 20 here. Then again we are having a 15, we are having a 10, we are having a 8, and we are having a 16 over here. So when I try to remove the top element over here, so when I just try to remove the specific top element, I mean to say I'm just going to make it as yellow. So imagine I'm going to remove the specific top element. It is going to replace by the 16th element over here, right? So that is why it has to happen. So I'm going to tell here as a, so the topmost element is removed. So the last element is 16. So I'm just going to remove this last element, and I'm just going to place it the specific element over here as a 16 over here. I'm just removing it over here. So after removing the element number, that is 50 over here. So now after removing an element that is 50, so now I'm just going to have a question whether it is your max heap or not. No, definitely this is not your max heap, because your root element is having a smaller value over here. So now what I need to do here? So now I need to just swap it over here. So what I need to do? I need to just apply the swapping over here. So I'm just going to write the element over here. So what I'm going to do? I'm just going to draw now. So I'm just going to create, I'm just going to write the specific heap over here. So after drawing the specific heap, so here I'm just going to tell we have a 16 here, and we have a 30, we have a 20, then 15, then 10, then we are having an 8 over here. So now I am just telling here this is going to be wrong, right? So 16 is not. So basically I am not going to replace it over here. So what I am going to do here is I'm just going to replace the swapping. I'm just going to apply the swapping over here. I'm just going to apply the swapping again. So 60 is going to be swapped with 30. So again I'm just going to replace 30 with an element that is 16, and again the 16 will be replaced with an element that is 30 now. So after replacing here, let me tell here, so let me draw it here. Okay, now the last, it is going to be something like 30 is going to be onto the top. Okay, then here 16 has been come, 16 is going to be there here, and 20 is going to be there, and here it is going to be 15, here it is going to be 10, here it is going to be 8. Now whether this is your max heap or not, yes, this is going to be your max heap. So this is the max because the root element having the top here, and if I come here parent is greater than or equals to the child here, again its parent is greater than or equals to child. So this is how we are going to apply the delete operations over here. Okay, so that is how the things happens over there. Okay, so we saw when I want to delete a root node, last node 16, I can directly delete, that's fine, the time complexity will be n. So if I wanted to delete the last topmost, here the time complexity will be log n over there. Okay, so this is all about the heap, the insert operation and the delete operation we saw. In the next session we are going to look onto the heap sorts, and then we are going to see the heapify priority queues over there. Okay, take care, bye bye.
Hey guys, welcome back to the heap concept session number 41. So we are going to look onto the heap sort here along with the insertion and deletion operation. So let's begin with an example over there. So coming back to the notepad over there, so I'm just going to create one heap and let's see how the sorting and things is going to work on over there. So let's take an example. I wanted to create one specific heap. So I'm going to create the heap. So here I'm going to give the numbers. So those specific numbers I wanted to create it over there. Okay. So imagine we are having a specific heap elements over here as 10 here, and we are having 20, and here we are having a 15 and 30, and we are having something called as a 40 element over there. Okay. So using this specific array list, I wanted to create the heap over here. So this is the first task over here. So first and foremost, I'm just going to take the first element, that is going to be the 10 here. So I'm just going to mention here as a 10. Okay, this is going to be your first step over there, right? So then next already we have an element that is 10 over here. So I wanted to insert an element that is 20. So I'm just going to insert the first 20 over here. So I'm just going to create it here as a things over here. So now here it is this heap or not? No, it is not the heap. So while inserting, here we need to sort it over there, right? So I'm just going to tell this is not your heap. So I need to just apply the swapping over here. So after swapping, 20 is going to come onto the top and 10 is going to come onto the bottom over there. Okay, so then this is going to be the heap over here. That's perfect. So here I'm just going to tell, so that 10 is completed and 20 has been completed. So now we are going to select the element that is 15 over here. So for inserting an element 15, so 20 is going to come over here, that's great, and 10 is going to come here, that is also fine. So then I'm just going to come here and I'm going to add the element that is 15. Yes, this is your max heap or not? Yes, this is your max heap, so it is going to get satisfied. Then again next. So next I need to insert an element that is 30. So now let's try to insert an element 30 here. Sorry, not 30. So it will be already 820 here already. So always when you are inserting, we are going to insert at the bottom, right? So here already we have an element 10. Here we have already an element that is 15 over here. So after element 15, so I'm going to insert an element that is 30 here onto the left of this. I'm just going to insert an element 30 over here. So after inserting it, whether this is your heap, no, it is not your heap. So now what I need to do, I need to apply the swapping over here. So I'm going to apply the last element. I'm just going to replace with the way. So where you are going to replace the last element. So I'm going to tell here as a, this is going to get swapped. So 30 is going to come over here. So after it is going to be there, so 20 is going to become here, and 30 is going to get swapped and is going to come here, and the 10 element is going to at the bottom, and here it is already, it is a 15 is there, so 15 will be here itself. Okay, so now again there is a question whether it is your heap or not. No, it is not your heap. So first what we did, first we swapped with the 10, right? So now we need to swap with the element that is 20 over here. So we need to swap, first we swapped 30 and 10. So now we are going to swap 20 and 30 to get the heap here, right? So after swapping it, so I'm just going to tell 30 is going to come on to the specifically top, and next that is 20 is going to be over here, and again the 15 is going to be here as it is. Again next whatever the element 10 is there, so it is going to be here as it is. So now if I talk about this, whether it is your heap or not, yes, this is your heap because the conditions are getting satisfied. So now I wanted to insert an element that is 40 now. So I wanted to insert an element that is 40. So I'm going to insert an element as a next node over here. So 40 is going to come over here. So now again it is not is going to be your heap here. So here I wanted to apply the swapping here again, right? So here I'm going to swap with the 20 and 40 over there. So here I'm going to mention, so this is what the swapping we did. So here we need to do the swapping in this way. So we are going to face parents element, swap it with the parent element. So after swapping with the parent element, so 30 will be there here, and again there will be an element 40 is going to come onto the here,
and there is a 10 already that is here, and 20 is going to come over here, and the remaining element that is 15 is going to be here itself. Okay, so now again I am just going to check whether it is your heap is sorted or not. No, it is not a sorted heap, and it is not basically a heap itself, right? So again what I am going to do, I am just going to shift the 30 to the top of it. So what I am going to do here is I am going to mention here the 40 is going to come here. So here it is be like this, right? It's going to swap it over here. So here I'm just going to mention the 40 is going to be at the root element over here. So here after 40, okay, after 40, 30 is going to be here. Okay, then again element that is 15 is going to be here, then an element 10 is going to be here, an element 20 is going to be here. Okay, so yes, this is the sorted heap, right? So this is going to be the specific sorted heap for us. So it is going to be sorted as well, and it is a max heap over here. So while inserting we have done now. So now what we are going to do, now we are going to create a specific heap over there. So I'm just going to create what is going to be the final heap over there. The heap is going to be 40, and here we are going to have a 30, here we are going to have a 15 here, then we are having a 10, then here we are having a element 20 over here. So this is how about the which we have created the specific heap now. So now after creating a specific heap, now let's do the same for the delete operation now. Okay, so while deleting we are going to sort it. Okay, so while inserting we have done it, so now we are going to do for the sorting purpose for the delete operation over there. So let's see how it is going to be there. So I'm going to scroll a little bit down. So I can take, and I'm just going to take the new heap over here again. So let's take a new heap here. So let me go to the new page best. So I'm going to go to the new page again. So I'll just create a new here. So again I'm just going to create a new page here. So I'm just going to mention here as a, that is a heap sort here. So it is a heap deletion sort over there. Okay, so we are going to see the heap deletion sort here. So in this case, let's try to have a heap here. Okay, so we have a specific heap that's already a, let's create one specific, we are having a heap that is 40, and so let me start from here. Okay, so we have an element that is 40 here, and we have an element again here as a 30 here, we have an element here as a 15 here. So here we am going to just draw the specific lines to it. So here it has been connected with this to this. So 30 has been connected with the element that is 10. So here we are having an element that is 20. So now we are going to see the sorting for the deletion. Okay, so let's see how we are going to have. So here if I try to create, so we need to do, there are things here. So we need to delete the root node, then replace with the root node. So what is I need to do? I am going to tell here as a, the condition delete the root node, and I'm just going to tell replace with leaf node of last element. So this is what I'm going to do it over there. Okay, so now I'm just going to apply this specific scenario over there. So here I'm just going to delete one specific thing over here. So I'm going to tell here, so I'll be creating a two specific scenario. So I'm going to maintain here. In the first thing, I'm just going to start with the first over here. So first I wanted to delete an element that is 40 here. So I'm going to delete the element that is 40 over here. So first let me draw its what is going to be its root, what is going to be its array over here, right? So if I try to draw what is going to be the array, so it is going to be 40, again it is going to be 30, it is going to be 15, it is going to be 10, it is going to be 20 here, right? So this is going to be the heap of the specific heap over here of the specific tree. Now I am deleting an element that is 40, right? So I'm just deleting an element 40 here. So what I'm going to do here is, after deleting an element that is 40 over here, so I'm just going to draw one specific scenario like, so the 40 is going to be at the last. So the whatever the element you are deleting, you have to delete and you need to place it onto the first over here. So this is basically sorting happens while deletion. So sorting, we created a heap, right, using the top element. Previously we created a heap. Now we are doing a sorting. So how we are doing the sorting? While doing the delete operation basically. So we have just inserted an element that is 40 over here, right? So after inserting a 40, now I'm just going to draw how this specific heap is going to be there. So remaining element whatever we have, we need to just place it as it is here. So we are having an element that is 30, we have an element 15, we have an element 10, we have an element 20 already. Whatever the elements we have, just keep as it is over there. Okay, now how the things is going to be here. So here after deleting a 30, I'm just going to replace with the last element, right? So according to these things, we are going to replace leaf node of the last element of the 40. So I'm going to tell here, so 20 is going to be come on to the top, the last element basically, then 30 will remain as it is, then again 15 is going to remain as it is over there. Again here it is going to be 10 over here. Now my question is whether it is your heap or not. No, it is not your heap, right? So here what I am going to do, I am just going to apply this swapping because 30 is greater than 20, right? So I am going to tell 20 you have to swap it. Okay, so I'm just going to tell swap the 20 with 30. So after swapping it, so 30 is going to come onto the top and 20 is going to be here, and the remaining the 10 element is already here itself, it is going to be here, and 15 will remain here as it is. So now if I just target here, yes, this is going to be your heap over here. This is going to be the correct heap now. So after using this specific correcting, so 30, 20, 15 and 10 is over, right? So again I'm just going to draw one specific thing over here, right? So I'm going to tell here as a, I'm just going to tell, okay, so I'm going to tell here as a, there is an element that is 30, we have an element that is 20, we have an element that is 15, we have an element that is 10, and already there is a specific 40 element is added here. So already the 40 element is there, don't touch it now. So now what I am going to do, I'm just going to delete the next leaf node, next root node of it. So I'm just going to delete this specific root node again. So after deleting this specific root node, so how the specific thing it is going to be there. So how the things it is going to be there. So already 40 was here. So now I am deleting the next root node, that is basically a 30. I am just going to delete it. So here the pointer is going to be pointing now. So here is the pointing will be pointing now. So after deleting, what all the elements will be having? So after deleting, we'll be having like again I need to replace the 10 with the last element with the topmost, right? So I'm just going to replace the 10 with the top, and remaining 20 will be here as it is, and next 15 is going to be here as it is. Now I'm just going to check whether this is your max heap. No, it is not your max heap, right? So what I'm going to do, I'm just going to swap this with this over here. So after swapping it, 20 is going to come onto the top, and 10 is going to be come onto the bottom, then 15 is going to be here. So now it is the max heap, right? So I'm just going to tell it as a 20 and 10, and I'm just going to mention as a 15 over here. So this is going to be the next operation over there. So next, let me do the next operation over here. Let me scroll to the bottom. Okay, yes, that's great. So I'm just going to draw one straight line. That's good. So now I wanted to delete and again the root element. So again I'm just going to delete the specific root element here. So after deleting the root element, so already into my existing heap, so already there is an element that is a 40, and we are having an already an element 30 here. So after deleting 20, so 20 is going to come over here, so that the remaining element will be 10 and 15. So 15 is going to come onto the top, right? The last element is 15 over here. So I'm going to tell here as a 15 is going to come onto the top, then it is last element will be 10. So whether it is your max heap, yes, this is your max heap, top element is 15. So again what I'll do here is a, so here is a 15 and we have an element that is 10 over here. That's great. So now again we need to delete the topmost root element here. So I'm just going to delete the root element. So after deleting the specific root element, so I'm just going to mention, so after deleting the root element, we are going to get the final values over here. So already 40 was there, already a 30 was there, already a 20 was there, and I'm deleting an element that is 15. So the last node it is getting remaining only 1, so 10 will get placed. So at the last the 10 is also get deleted. So here you can see the specific scenario. So you can see here this specific output, we got the specific element into the sorted manner. You can see here we got 10, we got 15, we got 20, we got 30, we got 40. So it has been sorted heap. So this is all about the sorting over here. So that was great, right? I hope this specific session was amazing for you guys. So we saw how we are going to create a node, create this specific heap. Then to start applying a sorting, we are going to apply the deletion method. So we are going to first delete the root node, then we are going to replace with the leaf node, basically a last node over here. Okay, we are going to replace the things with the last node, replace with the node of last element. That's it, right? So that is what the entire concept of heap sort using deletion operation. So in the next session, we are going to look on to the Java program for creating a heap, insert operation, delete operation, and again we are going to see the for the sorting, we are going to look on to the Java program for it. Take care. Bye bye.
Hey guys, welcome to the section 9, session number 42. So let's understand the heapify and the priority queues into this session. So already we have seen about the what is heaps, what is min heap, and what is max heap. It's similar to kind of that. So let's understand with an example in a more better way. So coming back to my specific notepad over there. So let's create one specific tree and understand how the specific tree is going to be there here. So here we are going to mainly talk about the downward approach. So
Here let's take an example over here. So we had an element that is a tree, so where we were always sorting from the top to bottom, right? So now let's see how we are going to sort from the bottom to the top over here. So let's understand what is downward approach here. So in a downward approach, in a specific min heap, let's take an example of a min heap that is a 10 here. Let me create an element here as if it 30 and I am creating a element that is 50. So I'm just going to draw this specific tree, and if I just tell here as it is going to be 12, here it is going to be 40, here again if I just tell here it is going to be 25, here it is going to be 18 over here. So in this case, if I talk about this, what is it? It is basically a min heap, right? Because the parent element are having greater than its, having the lesser than its child element over here. So this is the min heap, right? This is going to be the min heap over here. So if I try to write the specific stuff for it, so let's try to write one specific graph like the in the array format. How what is the array is going to be there over here. So I'm just going to write the specific array over here. So I'm just going to tell here an element that is a 10, then we are having an element 30, 15, 12, 40, 25 and 18, right? So these are all the elements which we are having it here, right? So first tell here as a 30, and we are having an element that is 15, then we are having a 12 here, then we are having a 40, then we are having an element 25, then we are having an element that is 18. So this is going to be the specific array if I mention inside the array about the min heap values over here. So all the elements we are having it over here. So let's we need to, whenever we are, this is specifically a downward approach over that. Now I wanted to convert this min heap into the max heap over here. So I wanted to heapify it. So how we are going to do it over there? So first always we are going to look onto the leaf nodes over there. So what all the leaf nodes inside this heap? The 18 is the leaf node, and 25, then 40, then 12 and 15 and 30, then it comes to the 10 over here, right? So these are all the specific leaf nodes. We are going to look onto it while sorting it over there. So let's see how we are going to do this specific method. So let's imagine now I'm just going to swap this two element over here. So I'm just going to swap this two element because the last element I need to look first, that is the first leaf node is 18. So first I'm just going to swap it towards to the top, up to the bottom, up to the top over here. So 10 will be here as it is, and 30 is going to be as it is here, and 15 is going to be as it is again. So here it is going to be 12, here it is going to be a 40. So here once I just swap it, so whenever I just swap this, right, so this value will get changed, right? The value, the 18 is going to come on to the top, and we are going to write it here like this. So 18, so 18 is going to come on to the top, and 15 is going to go on to the bottom, and here it is going to be 25 over here. So again, now after this again, the 25 is greater than 18, right? So I wanted to swap these two things over there. So next element, so 10 is going to be here, and next 25 is going to come on to the top, and again 30 is going to be here. Here it is going to be 12 as it is, here it is going to be 40 as it is, and here it is going to be 18, here it is going to be 15 over here. So here the elements are been swapped over. Now it has been swapped. So after that I wanted to swap, which is the next element. 18 has been swapped, right? And again 25 is also swapped. No, I'm going to swap it for the 40 over here. So for the 40, so I wanted to swap in this way over here. So 10 is going to be as it is here. So the 40 is going to come on to the top. Then again 12 is going to be here, and the 30 is going to come on to the bottom. Then whatever we have 25, it is going to be here, and here it is going to be 18, and here it is going to be what, 15 over here. That has been done over here. So 45 is also has been swapped over there. So the ones, so here we are just moving the element to the top, right? So that is what we are doing it now. So if 12 is already, it has been in the ordered, okay, the parent element is larger and the root elements are smaller. Here also parent is larger, root elements are smaller. Now I wanted to swap for the element that is the major, that is 10 over here. 15, 13 is also sorted because all the things is done. So once I sort it here, now I'm just going to sort this to here over here. So I'm just going to tell 40 is going to come on to the top, and 10 is going to come on to the bottom here. Then 25 will remain here as it is. Then for the 10, I'm just going to tell 12 will remain here as it is, and 30 is going to be remain as it is. And again the element that is 18 is going to be here, and the element that is what, the next element that is 12 is going to be here as it is. So 12 or 15 is going to be here as it is here. So you can see 40 is here, and here is the less, and here it is a greater element, here it is a less, again here it is a greater, here it is greater, and here it is less, right? So here also we need to swap it over here. So rather than having a 15 and 18, so 15 has to be at the left side, and greater element can be made at the right, okay, because to maintain the priority queue properties over here. So here you can see we have converted the heapify. So we're using a heapify. So from the downward approach, we have just converted the min heap to the maximum heap over here. So if we try to see what is the value of this specific heap over here. So here I'm just going to tell here as a 40 we are having, then we are having 10, we are having 25, then we are having 12, then we are having 30, then we are having an element 15, then we are having an element 18. So this is going to be your max heap over here. So this is going to be your max heap. So this is how the things we can just follow up the downward approach using a heapify, and we are going to do it over there. So now next coming back to the next thing, that is a priority queue over here. So in a priority queue is nothing less, we are just going to tell what is the priority of the min heap and what is the priority of the max heap over here. So that is all a very small thing. So let's take an example over here. So let's create one array of element A. So inside this I'm going to tell here as a 8, 6, I'm going to give it as a 3, 10 and 5, 4 and 9. So we have some element over here. So if I draw a specific min heap for it, so it is going to become, so smaller element is going to become at the top, and it will be like 5 here, and here it will be like 4 here, and here it is going to be an element 10, here it is going to be an element 8, here it is going to be an element 6, here it is going to be an element 3, element 9 over here, right? It is going to be an element that is 9 over here. So I'm just going to draw it. So already we have seen, I'm not going to teach again how we are going to create the heaps and all, right? Because already we know. So if we form the specific min heap, it is going to be the specific tree for us. So it is going to be 4 here, okay? Don't get confused. So if I just tell here what are the things we can, what is the priority queue says here is, the priority queue says here is smaller number is here, right? Smaller number has the specific high priority here. So high priority. So smaller number will be having the high priority. And if I talk about the complexity of the priority queue, it is going to be big O of n in always, that is arrays over here. It is going to be big O of n in arrays. Okay. When we take a max heap example over here, if I just take the max heap example, okay, if I just take this specific max heap example, let's say it is 8, 6 and 3, 10, 5, 4, 9 over here. Well, if I just try to draw the max heap for it, so the 10 is going to come on to the top here, then 8 is going to come over here, then 9 is going to come over here, and 6 is going to come over here, and again we are going to get it as a 5 here, then 3, then we'll be getting 4 over here. So here we can take here is the larger number will be having high priority. So what is priority queue says here is, in this specific min heap, the smaller number is going to have the high priority, and in this specific max heap, the larger number will be having the high priority over here. For this, you can just tell here as a, the time complexity will be big O of log n if we are using the heap over here. So that is why, as compared using an arrays, if we follow the heap approach method, the time complexity can be shift from big O of n to big O of log n. So big O of log n is better than the big O of n, right? So this is all about the entire concepts of the priority queues and the heaps here. So in the next session, so let's discuss how the Java program is there. We are going to look on to for the Java program for insertion, deletion, sorting and all the operations which we have seen. So I'll catch you over there. Take care. Bye bye.
Hey guys, welcome back to the session 43. So let's understand the Java coding problem on heap operations. We are going to look on to the entire heap operations into this session over there. So let's begin with the coding part on it. So open your Eclipse over here. Let's try to create one Java class for the heap. So I'm going to create one specific class here for GUVI DSA. I'm just going to create, right click here, just click onto the new and just click onto the specific class over here. To the class, I'm just going to create the class name as heap. I'm just going to create public static void main as the method to run your program. So here I'm just going to start writing the program over here. So here I am going to write all the operations whichever are having a interaction with the heap here, whichever we have learned it. So first I'm going to import the package, that is a java.util.arrays package over here. So I'm just going to make use of the array java.util.arrays over here. So here I'm going to initialize some of the variables onto the top. So basically I'm just going to initialize a array, so a empty array to store all our heap values over here. So this int array is going to store our heap is going to store our all the array element inside our heap as an array over there. Then I'm just going to create another variable, that is a int of size over here.
So what this size is going to do, it is going to store the current number of the arrays element inside the heap over here, like how many specific nodes are present inside your heap, that it verifies in that we are going to store it in the size over here. Then I'm just going to initialize one boolean value for the specific isMin heap. So this specific variable, what it is going to store here is, if it is a minimum heap, it is going to change the flag to true. If it is not, the flag is going to turn as the false over there. Okay, that is what it is going to do. Then I'm just going to create a constructor to initialize the heap values over here. So that is a constructor. I'm just going to create a public constructor that is for the same class name as a heap. It basically takes the capacity, it takes the specific capacity, and it is going to take the again the boolean value of isMin heap or not. So what it is going to tell you is whether it is a minimum heap or not. It is going to take an input and it is going to take the capacity. So first, in this specific program, I'm just going to initialize the what is the heap values here. So first I'm going to create the this dot heap is equals to new heap. I'm going to create it here. So new heap int of capacity, like what all the nodes they are providing it. For those, I'm just going to create one specific initialize with the capacity and the whatever the size is there. So for the size, I'm just going to initialize startingly as a 0 over there. Then I'm just going to initialize this dot isMin heap. Okay, is equals to isMin heap. So whatever we are just passing as an argument, that is going to get passed over here, whether it is a min heap or a max heap, that's we are going to declare it. That's constructor going to initialize the values over there. Next, we need to initialize one utility methods to get the parent element. So here I wanted to check who is the parent, who is your left childs, and who are your right childs. So for that, I'm just going to initialize the things over here. So we are going to create some kind of a variables here. So I'm going to tell here as a private, that is going to int. So I'm just going to create one method called as a parent. So here I'm just going to pass an element I, whatever the node I am going to pass it I. So this parent is going to return what? It is going to return I minus, basically I minus 1. This is going to be the formula. Okay, so this is going to be formula to get this specific parent element over here. Okay, in the same way, I'm just going to write another formula for understanding who is your left child. If I wanted to find who is your left child, I'm just going to pass the int I of value something. Then what it is going to do here is, it is going to return you 2 star I value plus 1 over here. So this is going to be the formula for returning the left child. And the same way, we have another formula, that is int of specifically a right child. So to get this specific right child, again I'm just going to pass the int of I value. So it basically returns you the 2 star, that is I plus 2 over here. Okay, so this is all the formulas that is there officially to get the parent element, to get the left child, and to get the right child over here. Okay, so these are the variables. We have utility methods which we have created by our own over here. So basically, now whenever we will be applying the approach of swapping here, right? We saw something like swapping things inside our heap. So we need to have one function for swapping as well, right? So that is like simply like swapping a 2 element. So I'm just going to create one private void method that is going to swap the element over here. So whenever I call this method, it is going to take 2 nodes value, that's I can treat it as int I and the int of j over here. So here I'm just going to tell here I'm going to create one temporary variable. Here I'm going to store the whatever the heap value of I will be there, I'm just going to store it as a temporary variable. Then whatever the heap of I is there, I'm just going to replace with the heap of j over there. Then I'm going to tell here as a heap of j just stored here as a temp value inside it. Okay, so this is going to be the swapping of a 2 specific when nodes over here. So this is going to be another method. So now I am going to create another method. That method does what here is, it is going to apply the heap properties from the bottom to top over here. So here we are going to write the method called as heapify. So I'm going to write the heapify up over here. So here I'm going to tell heapify up over here. Basically we are just doing for the applying the heapify up. That means if something is smaller, I wanted to shift it to the top over here. So that is what we are just applying top heapify up method over there. Okay, so for to write this one, so we are going to write the program like it is going to be a, let's create a private void method. It is going to be a method name, that is a heapify up. I'm just going to mention the program name as heapify up. So if I want to heapify the up value, it takes basically a node here. Here I'm just going to check if the value of I is going to be equals to 0, simply I'm just going to return the program over here. I don't want to do anything, just return the base element. So if it is a small only one element existing, just return the root element, that's it. If not, I wanted to just declare one int of that is a parent index. I wanted to see who is the parent over here. The parent index will be the root element, that is going to be a parent of I over here. So you see in the parent what it returns, it takes the formula, it returns you the parent of this. Okay, that is what happens here. So now I'm going to check if the specific is min heap or not. So I'm just going to check if it's if the min heap, if it is a min heap, what you need to do. So if it is a min heap, we need to do here as a whatever your heap of I value will be there, the parent element, if it is a min heap, the parent element will be having a lesser element, right? It will be having a less number. So I'm going to tell it should be lesser than the heap of that is a parent index, parent parent index over here. Okay, so whatever the heap of I value will be there, whatever the indexing we are showing, that indexing should be lesser than the heap of the parent index. So that is going to be the condition if it is a minimum heap. Okay, and again we are just checking if it is a specifically a heap of I is lesser than the parent index over here. So if it is happening, we need to just apply the swapping, right? So if we are just checking the two things here, that is what we are checking. We are checking the two things here, right? When I'm checking the parent element with the child, if it is smaller the element, we are just going to shift it to the top, right? So that's why we are using the swap method here. So here I'm going to just swap the element that I'm going to pass a node, whatever the node I am passing it, then I'm just going to pass the parent index to it. Okay, so this is the one swap is going to done. So after swapping it, I'm just going to tell here as a heapify up method. I'm just going to call the recursively, I'm going to call the parent element. So what it does means it keep on calling a method. So here you can see 3 times we called. Here the recursion is happening until and unless we are not making this specific scenario, we're pushing the larger element to the top and the smaller to the bottom, and it applies the heap property. We are going to keep on sorting, we are just keep on shifting it, we are just keep on swapping it basically towards the towards the basically topward approach over here, right? So the program which we are writing is writing for the heapify up here. Okay, so it is going to be heapify up. Okay, bottom to top over here, we are just sending the element from bottom to the top. The same method we are writing it here. So we are going to do same thing. So I'm going to call the same method, that is a heapify up, as a recursively we are going to call it, and I'm just going to pass who is the parent index of it. Okay, so we are going to keep on doing this specific part. So if it is not the min heap, so it is going to be the else, it is going to be going to the else part. So here it is going to check the opposite of, if the heap of a specific I value is there, right? Here on top we check like lesser than, here we are going to check if it is greater than the heap of the index, that is a parent index. We are just checking here whether the child element is there, whether that is a greater than the parent index. So whether it is a parent index, that means it is going to be the min heap, right? It is going to be there here. So I'm going to just say the parent index. So here what we are going to do, again we are going to do the same thing. We are just going to apply this swap method. So we are going to pass the I value here, then I'm just going to pass the parent index to the element, swapping it. Then again I'm just going to call the heapify method over here. I'm going to tell as a heapify method, and we're just going to pass the parent index as a property over here. So this is how the things is going to be there over here. Okay, so I hope you have understood what we are going to do here is I'm going to put the semicolon over here. Now the things is sorted. Okay, so this is basically a method to heap the property from bottom to top approach here. So it is basically bottom to top, we are just checking to bottom to top over here, bottom to top method, heapify up, it is bottom to top. So here we are applying the concept of recursion, right? I'm going to mention here as a recursively we are heapifying up here, heapify up the parent over here. That is what the method we are calling it here. Okay, that is what we are doing, the top up approach over there. So once it is done, so now we are going to do the top to bottom now. So here we did top bottom to top. Now we need to write another method, that is the top to bottom method here as well. So let me write it again another method, that is a top to bottom over here, a method that's going to mention a heap, maintain heap property from, that is basically we are going to write it as a heapify down method. Here we are just going to write the heapify down method, that is going to be also called as top to bottom method. Okay, we are going to call it as a top to bottom method. Initially whichever we have understand towards the upper, right? So we call it somewhere we have written so it is a top towards the upward building, that is if it's necessary add the element where max heap over here. Somewhere I have written it, that is if I just scroll here, so here we have just checked the binary tree and we have a max heap and a bottom heap, and if I just come here, it is we are creating a heap here, I just come here as well, replacing with the deletion operation, and here it is a priority queues. So it is a downward approach, right? So the downward approach, we have written it. It is a top to bottom, that is a heapify down method we are writing it now. So now let's write this specific method over here. So here it is going to be again a method that is a private void. So I'm just going to tell here as a heapify the down over here, heapify down method. So again it checks the same value, let's check the int of I value. So here I'm just going to initialize what is your left, what is your right, and what is your extreme, what is your node actually. Okay, so I'm going to tell here as an int of left is going to be your left child. So left left child. Okay, that takes an element I here as it is. Then again I'm just going to mention here as an int of right child is going to be equals to your RIGSG right child, and takes the I property. Then we need to tell which is your node, right? So I'm going to get as something like a extremum here. Okay, I'm going to use it something a element name as extremum is equals to the node value, whatever the I we are going to define it over here. So here I'm just going to check whether if it is again is a min heap or not over here. So based on that we are just going to heapify down here. Okay, so I'm going to mention here as a, if this specific is a min heap. Okay, if this min heap occurs, if it is a min heap, then I'm just going to initialize the constructor with the all the left right values. I'm going to tell if the left value is lesser than the size. Along with that we are going to check if the heap of the specific if the heap of the left element is lesser than the basically a heap of the node over here. So whatever the node we wanted to check, right? So if that specific node is lesser than the left element extremum, whatever it is, so we have given as like this. So then if it is this condition satisfied, then we need to make the node to the left side, right? So that is why I'm going to tell whatever your extremum will be there, just keep that whatever the left value will be there, just store it as the node value to it. Okay, so again I'm just going to check another condition. If the right value is lesser than the size, and along with that we're just going to check that is a heap of right side is lesser than the heap of the extreme element. If this condition satisfied, what we are going to do, we are going to just make the extreme value towards to right, just writing the opposite of the top over here. So it's going to be the if condition. So then if there is a conditions gets filled, it is going to come back to the else part if it is a max heap. So for the max heap, how we are going to shift the values to the left, right, and extreme. So here I'm going to tell if the left of SSZ the size and a length and percent, I'm just going to tell here as a heap of left value is greater than the heap of the specific right value, sorry, heap of the specific extreme value, whichever you're checking, right? The left value is greater than the node value which you wanted to pass. So in that case, again I'm just going to make it as the extreme value is going to be your left side. And if this condition not gets set, again I'm going to check another condition. If the specific right value lesser than this size, and along with that I'm just going to tell as a heap of RIGHT, right? Here if it is this condition, so I'm going to check is a heap of the greater than, that is the extreme element over here. So if this condition satisfied, I'm just going to make it as an extreme value towards its right over there. Okay, so this is going to be the formula for heapify down over here. Okay, so again I'm just going to check if the extreme is not equals to a value. So what are the node element I'm just checking, right? Which are the node I'm inserting, checking for it. So if that element is not equals to the root element, what you need to do, so if it is not element to the root element which you are passing it, so again I'm going to just swap it here. So I'm just going to swap it to the top. So I'm going to tell I comma extreme over here. Okay, so this is going to be there, and I'm just going to call the recursive method, that is a heapify down method over here. So heapify, that is down method, and just pass the value of the extreme over here. That's it. Okay, this is going to be the method over there. So this we have written the top down approach, we have written the bottom down approach here as well. So the two things has been done. So now let's try to write a method for the insert and the deletion method. So here basically, now whatever the methods we have written right now, the heap method to initialize the values, and swapping for swapping purpose, the heapify up and the heapify down, we have written a methods that's basically checks the heap properties. That's it. Okay, when I'm following a top down approach, it checks the heap properties. When I'm following a bottom down approach, it checks the heap properties. So this we have just declared the properties code here right now. Now we are going to write the method for the insertion over here. So let's write this special method for the insertion over here. So for this I'm just going to write one method, that is a public void. So I'm going to make it as an insert method. So it basically takes the key element, whatever I wanted to insert it here. So here I am going to check where I need to insert it here. Okay, so I'm just going to check one condition. If the specific size of the specific, if it is the size is equals to heaps dot length, heap dot length length over here. So that the heap length and whatever the size we have declared, if we are checking that if it is size is equals to heap dot length, that means what we are going to do. So at that time what we are going to do, we are going to create one array. So we are going to create one array dot copy of, I'm going to use the copy of method. So whatever the heap is there, so for that heap I'm just going to create another one copy, and I'm just going to multiply with the size of 2 over here. Whatever the size is, just make it to the double of it. Okay, if it is there, or else it will not create it. Okay, for initially I'm just creating it. So then I'm just going to tell the whatever the heap size is there, right? So for the heap size, whatever the key element we are passing it, declare the heap size or whatever it is key is there. Then we are going to call the heapify method. So heapify up method. So I'm going to, if you wanted to use up, you can just use the up method, maintaining the specific heap property here. So I'm going to pass what is the size of that. So maintaining the heap property, I'm going to pass the size, and after that I'm just going to increment with the size plus plus over here. So this method does what? This method is basically helps us to insert the element at the heapify up property, maintaining the heapify up properties, and we are going to insert the element into it. So for the deletion, how it is going to be for the delete? So for the deleting, it's simple over here. Okay, for deleting as well, so we are going to write a method here. So it is going to be a public method. So I'm going to tell here is a public int of delete method. So this delete method does what here is, whenever I call this specific delete method, so I'm just going to check if the size, if the specific size is equals to 0. So if its size is equals to 0, there is nothing to delete. So I'm just going to tell new illegal exception. I'm going to tell here as a new illegal state exception, something illegal legal state exception. Okay, so I'm going to tell illegal state exception over here. So inside the illegal state exception, I'm just going to pass something like is a heap is empty. So I'm going to mention here as a heap is empty over here if this condition satisfied. Okay, now I'm going to just, it's going to return something, right? So I'm just going to tell if I'm going to try to delete the root. So if I'm going to initialize which is the root, so I wanted to understand which is going to be root. The starting element inside your heap is going to be the root element, so which is present at the 0th index. So I'm going to mention at the initialize with the root over here. So then I'm just going to tell whatever your root element is there, right? So for the root element, just initialize the value of, that is a heap of size. So basically imagine I wanted to delete the, here it is going to delete the root element. So after deleting the root element, I wanted to make the last element as a root element, right? Or whatever the last element present inside the index, that I wanted to make it as a root. So I'm going to tell for the root, what you need to do here is take the element that's present into the heap, that is a size minus 1. Basically size minus 1 returns the last element. Just initialize that to root over here, then decrement the size as well. That's it. So this is going to be here. So after that initial, then whatever, after deleting a root element, we need to swap it. We need to check the heapify method. So that method property is going to be what? Heapify down method, right? So I'm going to tell here as a, you need to apply the heapify down method. So after that, for the down method, I'm just going to pass it as a 0. From the 0th, you need to start maintaining the heap property. So again, whichever the element has been returned, deleted, that you return that specific root over there. So it's going to be the delete operation over there. So now let's try to write the another method, that is going to be for the sorting method. So for the sort, I'm just going to write a public, that is going to be a void method. So I'm going to mention as a heap sort method, heap sort over here. So this heap sort method is going to, whenever I wanted to sort an element, so what actually we were doing it here. So actually we were just doing the deleting, and again we were calling the same, that is a heapify down method. And after deleting, we delete every element, then we are going to store that element inside one heap, right? We were just creating one array. So we were deleting an element. After deleting an element, we were storing inside the array. So that is what we were doing it, right? So if I just create, first I'm going to create one original heap here. So what is going to be the original heap value? So here I'm just going to create a copy of that array, whichever already existing over here. Okay, so I'm going to apply the copy of method, that is a heap, and the size over here. I'm just going to pass it over here. So this basically does what? We are just keeping the backup of the original arrays into the original array heap over here. Okay, so then I'm just going to tell here as an int of, that is the original size. I'm going to tell as a original size is equals to size over here. So I'm just going to initialize the original size over there, and I'm going to run the loop for starting from the int I, that I value is going to be size minus 1. Basically from the last element I'm going to start deleting it. Okay, so after deleting it, so I value should be greater than or equals to 0, then it should be I minus minus over here. Okay, so once I just start deleting from the 0, so after deleting and every element we are going to store it into the array. So after storing it, I'm going to tell swap it from the 0 to I element. I'm just going to pass 0 to I, whatever the element from the 0 you need to swap it. Then I'm going to decrement the each size, and after that I'm just going to copy the heapify down method, and I'm just going to pass the element that is 0 over here. So to restore the heap properties over here, so we delete it, and after deleting it will just store it into the original size. So we are deleting it and we are heapifying, checking the properties. So after doing that specific operation for every element, so we are going to tell size is going to be the original size, and the specific heap is going to be the whatever the element that is going to be the original heap over here. Okay, so I'm just going to mention original size and the original heap for the heap and the size over here. So it is restoring the original heap. Here it is restoring the heap properties. Here we are keeping the backup of it, okay, for whenever I am going to sort it. So now we need to write another method, the last method, to print the data, right? So I'm going to create another method that is a public void. So I'm going to tell as a public void. This method is going to print the heap here. So whenever I call this specific heap method, so it is going to run a loop. I'm going to start from the, I wanted to print from 0 to n. I want to tell here as a n I value going to be start from 0, and I wanted to print whatever the element that is there inside the size of an array. So I plus plus, okay, so it is going to be I plus plus, and inside this loop I'm just going to tell so, so I'm just going to print whatever the heap elements we are having it. So inside that I wanted to just pass the heap of I, that's it. There is a heap of I element that is going to give you the data, plus I'm just going to create some element over here, and I wanted to create so an empty line, so this is going to be like this. Okay, so this is how all the methods we have written. We have written for the insert, sort, delete method, and we written the heapify method up and heapify bottom down properties over here. So once I added this all properties, now I'm just going to check demonstrating now. So let's demonstrate the min heap and the max heap over here. So let's try to create one heap. So I'm just going to create a HEAP heap that is going to create the min heap. Let's try to create the min heap first. So the min heap, I'm just going to create a new HEAP heap of, so I wanted to create a 10 elements, and it is going to be the true. Yes, this is going to be your minimum heap. I'm just creating the min heap with the capacity that is 10 over here. So let's try to create another method that is a max heap. So I'm going to create a max heap. So I'm going to create it as a new, I'm going to create it as a heap here, again HEAP heap again. So here also I'm going to create a 10 here, but it is going to be the max heap, so I'm going to make it as a false as the second argument over here. Okay, so we created a min heap and we created the max heap for the both. So once I create, I'm just going to pass the specific values over here. So I'm going to just pass the values is equals to whatever the values you want, you can pass it over here basically. So let me pass some from here. Okay, we have let me come back to this method, so which we had we have created a heap, right? So yeah, let me give this specific heap properties. Okay, so whichever you want, you can just pass the heap values over here. Okay, so if the values is going to be, so here we have some values, right, at 50, 30, 20, 15, 10, and it is going to be there. That's great. And here if which I have used here, so this is going to be the min heap, max heap, and here. Okay, so let's try to insert the 10, 20, 15, 30, and 40. So let's see what happens. So I'm going to just mention here as a 10 comma, so then after passing 10, we are going to pass it here as a 20 comma, 15 comma, and 30 and 40. Okay, so 30 comma and 40. So we are going to pass this as an elements over here. The values is going to be this, and in this specific values, values I wanted to print so. So in this I'm just going to tell here as the specific min heap for this. I'm just going to create the minimum heap is going to be for this is going to be, I'm just going to tell min heap is going to be. So I'm just going to run a for loop here. So inside this I'm just going to iterate the every value from the specific values. Okay, so from the specific values I'm going to iterate the every for each loop we are using it, and inside this I'm just going to want to get the min heap. So I'm just going to pass the min heap dot, I'm just going to insert the every values into it. Once I just pass the insert the min heap value, so after getting it, I'm just going to print what is going to be the min heap. Okay, dot, I wanted to print it here, so I wanted to just print the specific heap over here. If I execute this specific program of creating it here, you can see I got it here. So 10, 20, 15, 30 and 40 is the specific min heap over here. So if I just see here 10, so you can see 10 here, you can see the max heap is basically, this is going to be the max heap. So if I just try to pass the min heap, if I just try to pass 10, 20, 15, 30 over here, the what is going to be the min heap value? 10, 20, 15, 30 and 40 is going to be our values over here. Okay, yes, this is exactly correct. See, it will be 10 here and 20 will become here, 15 is going to come over here again there will be a 30 if it is 10 and 20, 10 15 will become left side, and sorry, 15, 20 will be left and 15 will be right. Again for the element 20 will be having 30 and 40. This is exactly obviously it is true, right? This we are getting the min heap exactly what we wanted. So now let's try to print this specifically for the max heap over here. So I'm just going to tell here SO dot I wanted to have the max heap here. So I wanted to print what is going to be the max heap. So for the printing a max heap, again I'm just going to call the same thing for each loop. So for int value, I wanted to just pass the values to it. Okay, I wanted to call the max heap method here. So I'm just going to call the max heap dot, I'm just going to pass the insert method. I wanted to just pass the insert method to insert the specific value over here. So after passing the max heap, so I'm going to print what is going to be the max heap over here. So here I'm just going to print here as a max heap, whatever the max heap dot print. So I'm just going to tell max heap dot print here. So if I execute here, so here the larger number should be top. Obviously, that's great, right? See, in the max heap, the top number is going to be the larger. The root element, you can see 40, 30, 15, 10 and 20. So 40, 30, 10, 15, 10 and 20. So what was here? That is 40, 30, 15, 10, 20. You can see, guys, I given this specific as an input. You can see the max heap we created while seeing the example as we got 40, 30, 15, 10 and 20. So here also you can see the same, we are getting 40, 30, 15, 10 and 20. So this has been, hence it's proved, right? So this is going to be your specifically max heap over here. Now let's try to apply the insert and delete operations over here. So here we have created a max heap, that's great. So I'm going to create it as a SYSO. So now I wanted to see what is going to be deleting from the element. Okay, so I wanted to just say here as a deleted from min heap. So let's try to delete something from the min heap. So if I try to delete something from the minimum heap, which is the element which we are going to get deleted. Okay, so I'm just going to tell here as a min heap, I wanted to apply this is a delete method over here. So when I try to delete it, again if I just try to, after deleting, if I try to print the max heap, the min heap over here, min heap dot thing. So I'm just going to save this, and if I execute here, so it's just going to delete it into the min heap over here. You can see the deleted the min heap is going to be 10 over here. The first root element will get deleted, right? You can see the root element has been deleted. After deleting the root element, you can see, guys, again the swapping happened. Again it is being coming as a properly, that's 15, 20, 40 and 30 is coming. That's perfect, right? So again if I try to delete another time, Control C and Control V. So if I try to delete 2 times over here, so let me delete for the 2 times. No, so the second time the 15 has to get deleted. You can see the 15, 10, first 10 got deleted and 15 has been getting deleted over there. So the same thing, I'm just going to apply it for the max heap also. I'm going to tell here, and I wanted to see it for the max heap over here. That is a delete from the max heap. If I just pass the max heap over here, so I'm going to pass it here as a max heap over there, the specific max heap. So again I'm just going to tell it as a max heap over here. So if I execute the program, so you can able to see the first, the root element, the top element in the max heap was 40, right? 40 will get deleted and 30 has to get deleted. You can see first 40 will get deleted, again it has been coming as a proper, then 30 has been deleted, again it is coming as exactly what I was wishing for, right? So this is how the specific thing is going to be work inside the max heap and the deleting operation over here. Okay, so this is, I'm going to just comment it out over here. So let me comment these specific things. Now I wanted to sort for the min heap and I wanted to sort for the max heap over here. So for that I'm just going to write it as a SYSO. So I'm just going to tell a method that I wanted to apply the heap sort here. So I wanted to apply the heap sort for the specific element that is a min heap over here. Okay, so for applying the, I'm just going to tell here as a whatever we have a min heap, right? So for the min heap, I'm just going to apply the, that is a heap sort method. So we are just going to apply the heap sort method. So after sorting an element from the minimum heap, I wanted to see what is going to be the min heap. After sorting it, I wanted to see what is going to be the min heap dot print. I wanted to apply the print here. Okay, so once I just save this and if I execute the program, so you can see After the sort 10, 20, 15, 30 and 40 we are getting it. So you can see after sorting it, we got the sorted element 10, 20, 15, 30 and 40. 10, 20, 15, 30, 40. Same thing obviously we get. Okay, after sorting, we got the exactly the mean heap over here. Same thing I wanted to do it for the sorting for the max heap. So I'm just going to apply the max heap. So I wanted to apply here as a max heap over here. Here also I wanted to apply that is a max heap. So that is going to be a max and gap heap over here. Okay, so if I execute the program, so you can see again we'll be getting the same order here, that is 40, 30, 15, 10, 20. That was the 40, 30, 15, 10 and 20. The same thing we are getting it over there. Okay, so this is all about the heap. So we have typed 100 and almost 200 lines of code into these heap operations. That was amazing, right? So whatever the concept which we have learned theoretically, we have done practically as well with the Java program here. This is all about the heap, and this is all end of the section number 9. Take care, bye bye. In the next session we are going to start with the backtracking.
Hey guys, welcome to section 10. So let's move on to the last section of our DSA course, that is on backtracking and recursion. So we are going to look on to the Tower of Hanai. So how we are going to see like Tower of Hanai over here. So the Tower of Hanai is a kind of a DSA problem. So where we are, it's like mathematical puzzle. So where we are going to have some 3 rods. So we are going to name it as A, B and C. So A is your source, C is your destination, B is going to be your auxiliary node. So what you're going to do here is you're going to move some n-dicks from A to C using an auxiliary node, that is B over there. So here there are few of the conditions to be noted here. So only one specific disk has to move at a specific time, and each move consists of taking the upper disk from one stack and placing into the another top of the another stack over here. So if you are placing any disk from one A to B or A to C, so everything has to be happen only at one time. So one time at a time you have to do it, this specific task over there. Then there are another condition here. So there are smaller disks. If suppose B has your smaller disks and A is having your larger disks, you cannot place a larger disk to the smaller disks over there. Okay, so this is the next specific condition over here. So let's see how we are going to solve this problem using the name they have given as the Tower of Hanai over here. So let's see with one specific example over here. So I've created a Tower of Hanai over here. So let's see how it can be done. So I'm just going to enlarge this specific thing. So let's try to create one Tower of Hanai over here. So I'm just going to select little bit bigger one. So I'm just going to create one like this. So I'm going to draw one specific straight line. So okay, it is not creating this straight line. So sometimes it happens. So let's see now if it is creates or not. Yeah, it is created. Okay, so we have created a straight line over here. So what I'm going to do here is, in this specific straight line, imagine there are 3 specific disks over there. So imagine there is a specific disk over here as a 1 over here, and we have the next little bit smaller disk here is a 2, and along with that we are having a one more smaller disk over here. So we are having a 3 specific disks. You can name it. This is going to be 1, this is going to be your second disk, this is going to be your third disk over here. So this is going to be your A over here. In the same way, what I'm going to do here is I'm just going to create another same disk over here. So I'm going to select this here. Okay, so again I'm just going to create it one specific straight line over here. So imagine this is going to be your auxiliary node over here, and same way I'm just going to select the same specific disk over here, Control C and Control V over here. So I wanted the another disk to be there over here, so I'm going to make use of it. So now this is the specific disk, so that is going to be your A, and imagine this is going to be your destination, and this is going to be your auxiliary node over here. So this is going to be your source, this is going to be your destination, and this is going to be your auxiliary node over here, auxiliary specific disk over here. So now we are going to move every disk at a time. So now all the 3 should have come to the specific destination over here. So this is going to be our main specific task over there now. So now I'm just going to create another specific disk over there. So I'm just going to create one disk like this. So one, and I'm going to just create one empty disk over here. Okay, so this is going to be one over here. So I'm just going to create some 3 stuffs over here. So imagine Control C, Control V. So I want here one more. Okay, so again one more over here. So this is the first step. I'm just going to do it here. So this is the first step, and in the same way we are going to repeat this for 4 many times. So I'm just going to place 4 times over here. So I'm just going to place it everything after this one. Okay, so I'm just going to create again. So again I'm just going to paste another time. So I wanted to keep it all the things ready.
So again, I'm just going to tell. So this is going to be it is going to take the 4 specific iteration. Let's see if it takes more. We are going to see it over there. So the first thing what I'm going to do here is, in the first iteration, I'm just going to take the color that is red color. So I'll be taking this color now. Okay, I'll take the thickness over here. So what I'm going to do here is, first, in the first iteration, I'm just going to move this specific first disk over here. Okay, so I'm just going to disk the specific. Imagine we are having the 3, we are having it here, and we are having a 2 over here. So this is going to be the third disk, this is going to be the second disk. So for the first iteration, what I'm going to do here is, I'm just going to move the first disk to the specific destination, that is A over here. So I'm just going to move this specific over to the destination over here. So that is one has been moved over there. And for the second time, already my third disk is already here, right? And already the first disk is already present into my destination, and the second disk I'm just going to store it into the auxiliary node over here, that is 2 over here. Okay, so this is going to be the next iteration over here. Now we are having 1, 3 and 2. So now how we are going to do next? So what is going to be the first iteration? This is going to be your first, this is going to be your second iteration. Now I'm just going to follow the third iteration now. So for the third iteration, now what I'm going to do here is, I'm just going to move this specific first disk to the second disk over here. So here already there is a disk that is 3. So I'm going to, already we have a disk that is 2 over here, and I'm just going to move the first disk to over here. So once I do this, that will be the third iteration now. So the fourth iteration. So for this fourth iteration, what I'm going to do here is, so the third iteration, third disk, I'm just going to move on to the final disk destination. This is source, this is your destination, and this is your auxiliary, right? So the third disk, I'm just going to place it over to this specific disk tower, and the second disk and the specific first disk is going to be here itself now. So now once we have done, so what is going to be the next case now? So for the fifth specific scenario, I wanted to use again one more state here. So in this one, the specific third disk is going to remain as it is over inside the specific tower. The third is going to be there already, and whatever the first disk is there, right? This first disk I'm going to move on to the source over here. So I'm just going to move on to the first here. So the third disk is already there, and the second disk is going to be here itself. Okay, this is going to be the second disk. And in this sixth specific iteration, I'm just going to paste this again. So after pasting this into the destination, so into the sixth specific iteration, so I'm just going to do what? So the third disk is going to be obviously here itself as it is, and what are the, so this is the source, this is your destination, this is your auxiliary, right? So from this specific auxiliary node, so basically from this specific auxiliary node, that is 2, I'm just going to paste it. This is over here. So that's, all the things happens once at a time. Okay, you cannot move all the things at the once in the single iteration itself. Okay, this is going to be the first over there. Now what I'm going to do, in the last step, that is 7th step, the first disk is going to come on to our destination over here. So 3 is already there, 2 is already there, so the first is going to be coming over here as it is over there. Okay, so I'm just going to mention here that is going to be let me put it over here like this. Okay, so here I'm going to tell is going to be the 1, this is going to be your 3, this is going to be the, so this is going to be the source, destination, auxiliary. So this is your tower of an eye. So in the next session we are going to see the coding part of it. Take care, bye bye.
Hey guys, welcome back to the session number 45. So let's see the tower of an eye coding example using Java program. So in the previous session we discussed how it is going to work theoretically. So now we're going to see the practical with coding part. So coming back to my Eclipse over here, I'm just going to create one Java class for tower of an eye. So I'm just going to create the right click, and I'm just going to create the new class. So I'm just going to make it the name as tower of an eye over here. Okay, so this is going to be the public static void, but I'm going to initialize it. So now let's see how the specific program is going to be there over here. So here I'm just going to create one specific function here. So the specific variables, like how we are going to follow those things over there. So basically in this thing, I'm just going to create one more function that I'm going to create here as public static void, and I'm just going to mention here the something called as a tower of Hanai over here. Okay, Hanoi, Hanai. So it is going to take two parameters. It is going to take the n value, how many disks are there. Okay, then it is going to take what is the source and the destination. I'm going to tell here as a source source here, and I'm just going to mention here as a character that is going to be the destination over here. So source, destination, it is going to take. Okay, so basically it is going to be the recursive function, and along with that it is going to take another example, another thing, the source, destination, and auxiliary also, right? So I'm going to tell
auxiliary, AUX auxiliary something. Okay, this is going to take these many input parameters from the function whenever it gets called. So after passing these three information, so now we are going to write first check one specific condition. If the specific n value, if specific one n value is equals to 1, imagine there is only a single disk I wanted to shift from source to destination. So in that case, I'm just going to tell system.out.println. I'm just going to tell here as a moving the specific disk from so and so, from the source to destination directly. I'm going to tell here as a move disk 1. So I'm going to mention move disk 1 from the specific source to destination. So I'm going to tell plus, that is your source. Okay, then I'm just going to mention here again, that is 2, and I'm just going to mention here that is as a destination over here, directly over here. Okay, so I'm just going to move disk 1 from source to destination. Just save this particular thing, and I wanted to just return the specific program over here. Okay, this is the first condition, we are just checking it. So then again, I'm just going to check if I wanted to, there are some more than n value is not greater than 1. So I wanted to move the top n-1 disk from source to auxiliary, right? So the first thing what we did, we are going to move the specific top disk from the source to auxiliary disk over here. Even you can use direct extension or auxiliary like that also. So we are going to make use of the auxiliary, right? So what we are going to do here is the specific, I'm just going to tell here as a solve the specific tower of Hanoi. So I'm going to mention, okay, it is a recursion call, right? So I'm going to call the same function here. So I'm going to call the same function, that is a tower of Hanoi. So I'm going to tell move the n-1, just pass the n-1 value from the specific, move from the specific source to specific source and auxiliary. So make use of the auxiliary node, then move back to the destination over here if it is n-1. Okay, this is what we are going to do, and along with that, this basically moves the top of n-1 disk to the from source to auxiliary. I'm going to mention into the comment, it is going to move the top, that is n-1 disk from source to auxiliary. This is the function that is going to do this specific task over there. Okay, so then after doing that, we are going to print one statement like we are move the specific disk. We are just going to tell move the specific disk, okay, from where to where. So from, I'm just going to pass from the n value, whatever we are having n value. So if it is going to tell move the specific disk, whatever the value of the n disk value will be there, it is going to target here. I'm going to mention move this move disk 3 from so and so. So from source to destination here basically. So I'm just going to tell from specifically source to destination, right? So I'm going to tell plus source to destination. I'm just going to tell source to destination over here. So this is how the specific things is going to happen over there. Okay, so this is the, I'm just going to duplicate this same for 2 more times over here. So again, I'm just going to replace here. So I'm going to place it over here. So here we are into change the only things. So first we are going to pass the n-1 from source to destination. So after that, what we are going to do? So after that, we are going to tell again, we are going to call the same things. So this time it is going to pass the n-1. So this time the auxiliary nodes comes to first. So then we are going to move from auxiliary node to destination. So from destination, we are going to move back to the source. We are going to make use of these 3 things over here. So here the 3 times the recursion is getting called over here. Okay, so this is 2 times is enough, I guess. So this is basically moving from source, auxiliary, destination. So again, from auxiliary destination to the source, we are going to make use of this 3 combinations over there. Okay, so once I done, that is only the problem is done. So now what we are going to do here is we are going to pass some kind of a number. So I'm going to tell it as a int number of disks. So I'm going to tell int number of disks is equals to, imagine we are having 3 disks over here. So we are going to see, we are going to call the tower of Hanoi now. So I'm just going to tell the tower of Hanoi. I'm going to pass the number of disks over there. So let's imagine the first value we are going to give it source as this one. Then the specific we are going to make use of the destination as C. Then we are going to make use of the auxiliary node, that is B over here. Okay, so once I execute this specific program, so you will be able to see the n number of combination it has been taken. You can see 1 2 3 4 5 6 7 8 9 10. This many combination it. First it is moving the disk 1 to A to C, then disk 2 to A to B, then C to B, A to B, A to C, B to C, like that. Okay, so whatever the things happen, so you can just match it with this thing. So it is going to be coming perfectly over there. Okay, so it is what how the thing disk is moving from one things to another place over there. Okay, so this is how the problem of a tower of Hanoi. I hope you got this. It's a very easy task, nothing rocket science here. In the next session, we are going to look on to the BFS and DFS, that is a breadth first search, depth first search. Take care. Bye bye.
Hey guys, welcome back to the section 10, session number 46. So let's understand the BFS and DFS data structure concept. So the BFS and the DFS is a backtracking problem and it's even a recursion problem. So we are going to see how we can do the BFS. Is basically we are going to call it as a breadth first search and depth first search over that. So let's see with an example and understand what exactly it is. So coming back to my specific drawing pad. So let's take one example of a tree. Then we are going to understand how exactly this is going to be that. So let me select one specific color here as red. Let me create one tree. So it's going to be one first vertex. Here let me create a vertex number 2 here. Let me create a vertex number 4. Let me create another vertex. It is going to be 5. And this vertex has the vertex 6. And this is going to be having a vertex 7. And this is going to be a connected bidirectional graph, basically vertex 3 and the vertex 8 and a specific vertex 9 over here. Okay, so here it is going to take use of the concept here. The BFS and DFS is going to take the concepts of data structure. It is going to store in the stack, or even it is going to store inside the specific queues over there. So the specific BFS that is a breadth first search. So the full form of BFS is the breadth first search over there. Okay, it's not going to come into the mind frequently in the mouth, so it is a little bit difficult to pronounce. So if you just pronounce breadth first search and depth first search. Okay, so the BFS. So BFS is going to make use of queues over here. So what is queues? We know. So queue is FIFO, right? The first in first out, the queues. So the BFS is going to make use of the queues data structure, and the DFS is going to make use of the stack data structure for storing purpose. Okay, so now let's draw one specific queue over here. Let's try to draw one specific queue. So this is going to be your queue data structure. Okay, so let's try to draw one specific queue. So we are going to store some kind of a vertex over here. Let's store it some values over here. Okay, so I have created a specific values over here. Okay, so inside it, so we need to traverse the tree, we need to traverse the graph in a BFS such that we can select. Let me write the points over here, what all the major points we are going to look onto it. So I'm just going to tell we can select any vertex starting. We can select any vertex as a startingly. Okay, we can just select any vertex startingly. So every vertex is added to queue over here. It is in the first in first out manner, and look on to adjacent vertices. Okay, we need to look on to the adjacent vertices. The three things we are going to follow it over that. So let's try to create something called as here as a visited over here. Let's try to call something called as a visited over here. So let me start from the vertex number 1 here. So let me start from the vertex number 1. So 1 is getting selected. Okay, 1 is getting selected. I'm just going to add that 1 inside my queue. So 1 is getting selected. I'm just going to tell the 1 is added into the queue. It has been visited over there. It has been specifically visited over here. So from the vertex 1, from the specific vertex 1, 2 adjacent vertices we are getting, that is 2 and 4 over here, right? So I'm just going to tell we are getting 2 and 4 we are getting from the vertices 1. So I'm just going to tell, okay, 2, 1 is there. So that I'm just going to add it inside the queue over here. That is 2, 4, 2, 4 has been added over here. So now if I just tell 2, 4, so from 2 we are getting 3, 8, and from the 4 we are getting 5, 6. So now which you need to select now? So first 1 is selected, 1 is getting selected, it is completed, right? So next, from the next we are going to select the vertices 2 here. So from the vertex 2, we are getting a vertex that is 3, right? We are going to get the vertex that is 3. So I'm just going to tell after 4, we are going to get the 3. So I'm going to tell here as a 3 vertex is added here. So from the 2, we are getting a vertex 3. So 2 is done. So 2 is been selected over there. So 2 has been selected. And after 3, which is the, from the vertex 1, after the 2 is selected, right? So again, so this is 2 is selected from the specific 3 has been added over here, right? So again, what I'm going to do,
Next again I'm going to select from the fourth here. So we are going to select from the queue. So next after 2, from the vertex 2 we are getting 3. So 3 I have added. Again from the vertex 4, we need to select the next vertex which you need to select. Whether you need to select 8 or 9, or from the 4, that is 5, 6 you need to select. So we are going to follow the queue here, right? That is why we are writing. See, 1 I have selected, I have added it here. So from 1 we are getting 2, 4. 2, 4 is added here. So the next which you need to select. Next we need to select from the 2. So from 2 we are getting 3. So 3 is added. So next we need to select. Next you need to select 4 here. So from the 4 which is our vertex we are getting 5 is there, right? So I'm going to tell 5 is added here and 5 has been added. So 4 is also getting selected over here. 4 is also done. So next which you are going to select now. So next again I'm going to select it from the queue itself. Next I'm just going to select the vertex number 3. So from the vertex 3, which all the nodes we are getting 8 and 9, right? So I'm just going to tell 8, 9 I'm getting it over here. So the vertex 3 is also visited, 2 is also visited over here. Okay, next we need to select the vertex number 4 is also selected, right? So next I need to select which. Next I need to select the vertex number 5, right? The vertex number 4. So next I'm going to select the vertex number 4. So from the vertex number 4, which all the vertex number 4 is done, right? So 3 is also done. So next we need to select the vertex number 5, right? So from the 5, which all the vertexes we are getting 6 and 7. So I'm going to add it here as a 6 and 7. So this is going to be your DFS. Okay, 5 is done. So after 5, basically we are going to get here as a 8, 9 and 6, 7. So if you have not understand, I'll tell you again. So here I will tell you very simple way. Okay, let's tell you about everything over here. So let's see here. 1 I am going to select here first. So from 1, 2 and 4 is good. 2 and 4 I am going to add it. Okay. So after that, which you are going to select, first you are going to select it as a from 2. From 2 we are getting a vertex 3, we will add it. From 4 we are going to get the vertex 5, we are going to add it. So that is done. So next we will come back to the 3. From 3 we are getting 8 and 9, we are going to add it. From last whichever way 5, we are going to get 6 and 7, we are going to get added over here. So this is going to be your visited node over here. So it's very simple. Okay, see, first vertex 1 we selected, added. Then from the vertex 1 we are going to select getting 2 and 4. Simply we'll add 2 and 4 into the queue. Then we'll do select. From 2 we are getting 3, we'll add it 3 here. So from 4, within 4 I'll select. From the 4 we are getting 5 I have added. Then again I'll come back to 3. So from 3, 8, 9 is there, I'll add it. So again I'll come back to 5. From 5, 6 and 7 is there, I have added. That's all. Very simple. Okay, so it can be n number of ways also. So I can just select. So imagine I can go, I am going first, I'm selecting 2, right? So even it can be like this also, right? So even it can be like this also. So I'm just going to tell in the queue itself, in this box itself. Okay, so first it can be like, okay, I'll just select the vertex number 1. So after selecting the vertex 1, I can get the, I'm going to go to the right side now. 4 is there, 2 is there. I'm going to tell 4 is there, 2 is there now. Okay, 4 is there, then 2 is there. So from 4, which all the there? So from the 4 we are having what all the thing we are having. From 3 we are having 5. 5 I am having. I'm going to tell 3 is there, 5 is there. Okay, so again, so from 2, 3 is already done, right? 3 is already done, 3 is already added over there. That I am going to keep it as it. After 3, which all the things we are having it. So from again I'm going to tell. So from 2, 3 is already added. So again I'll come back to the 3 here vertex. 1 is selected, 4 is selected, 2 is selected. So I'm coming back to the 3. So from 3 we are having 8 and 9. So I'm going to simply add 8 and I'm going to add it 9. So then I'm going to select the 5. So from 5 we are having 6 and 7. So I'm going to tell 6 and 7 I'm going to get added. So this is also the valid BFS over here. So this also can be one specific scenario. So again I'm just going to tell another scenario for you. So again, imagine there is another scenario. I'm going to select from the vertex 4 here. So from the vertex 4, if I select the starting vertex as 4, so from 4 we are getting 1, 3, 5 I'm getting, right? I'm going to simply tell 1 is there, 3 is there, 5 is there. I'm just going to tell 1, 3, 5. So 4 is selected. So I'm going to come 1. From 1 we are having 2. So I'm going to add it here. So 1 is also selected. So after I'm going to select 3 here. So from 3 we are having 8, 9. So I'm just going to simply add 8, 9 over here. So 3 is also selected. So again I'm going to come back to the 5. We are having 6 and 7. So I'll add it as a 6 and I'm just going to add the 7. So this is also another BFS also, it can be there. Okay, it's very simple. Okay, so you can add another BFS. I can create another BFS. These all are correct. Okay, so these are all the correct valid ones over there. So let me again, I'm going to create the another DFS. So for a DFS, sorry, we are talking BFS, not DFS. Okay, BFS. I'm going to mention here BFS. Okay, don't get confused. So in this, I'm going to select the vertex number 3 now. So let's select the vertex 3 here. So if I select the vertex number 3, we are having 2, 4, 8, 9. I'm having how many? 2, 4, 8, 9, right? So I'm going to tell 2, 4, 8, 9 I'm having here. Okay, 2, 4, 8, 9 I'm having it. So 3 is selected. So I'll come back to the 2 here. So from the 2 we are having the vertex 1. So 1 is getting selected. So after 9 I'm just going to simply place 1 over here. So I'll come back to the 4. From the 4, the vertex 5 is getting selected. So I'm going to come back over here. I'll be adding it over here. So the 4 is selected. So from the 8, 9, nothing is there. So I'll come back to the 1, nothing is there. Then again, I'll just come back to the 5th vertex. After coming back to the 5, 6 and 7 is there. So this is going to be the another BFS over here. So this is all the valid BFS. Okay. It not only you can select any vertex. So first you will look onto the adjacent, then the specific vertices over here. So let me add it which all the invalids one. So let me add the invalids. Invalid. So if I just imagine, I'm just going to start from the 1. I'll just start from the 1. Then I'll go to the 2, 4. So 1, 2, 4 is correct. So after 2, 4, I will go back to the simply 3 here. So after from the 2, I'm going to go to the 3. So after 3, I'll go back to the 5 and 6 here. So 5, 6. So this is invalid one. So this is going to be invalid because 1 is selected, 2, 4 is added. 2, 4 is added. Done. So again, if I just select after 2, 4, we have added. From the 2, we are selecting 3. That is correct. Again, after selecting 3, we are selecting 5, right? That's correct. You need to first select the 8 and 9, not the 6, 7. So this is going to be the invalid because first it is going to be first in, first out. It is going to BFS follows the first in, first out, right? So whoever come first, he has to be visited first. Okay, then he has to now go into the non-visited mode. Okay, so it is what the queue is going to follow the first in, first out manner over there. Okay, that is a FIFO manner. So this is all about the BFS over here. So now let's understand about the DFS over here. Okay, so if I just try to draw the tree for it, so how it is going to be the tree. So let me draw one specific tree as also. So I'm going to draw one small tree. Okay, so don't mind it. I'm going to draw one now. One here it will be coming. So from the 1 we are getting 2 here. I'm going to get the 4 here. So from 1 to 4. So from 2 we are going to get the node that is 3. So from 3 we are going to get the 8, 9. So that is going to be 8 and 9. So from the 4 we are going to get the specific 5. Again from the 5 we are going to get the 6, 7 over here. So you can see this is going to be the BFS tree for this specific. Again from if you take this, again there can be another. So there can be n number of trees for this as well. Okay, so this is going to be the BFA tree. So now let's understand about the DFS over there. So let me zoom little bit out. Okay, so let me write the DFS of it. So let's create one more graph. So I'm going to mention here as a DFS over here. So depth first search. So in the depth first search, I'm just going to create it here. So it is not creating it, guys. So let me erase these things. I'm going to select the stroke razor. So I'm going to delete it. Okay. So now let's try to create the concept of DFS over here. Depth first search over here. So in the depth first search, I'm just going to create another tree same as it is. So I'm going to tell here as a 1 here. I'm just going to create it as a 2. I'm going to create it as a 4 over here. Again, I'm just going to create it as a 3. Again, we are having a same, that is 8. Again, we are having a 9 over here. So from the 4, we are having a 5 here. Then we are having a 6. Then we are having a 7 over here. Okay. So I'm just going to connect this graph. So one has been connected. This has been connected with this. This has been connected with this. And this has been connected with this. And this has been connected with this. So this is connected and this has been connected. And this has been connected here. And this has been connected over here. Okay. So again, it is the same specific things over here. So DFS. So basically DFS is going to follow the stack here. That is the LIFO structure. That is the last in first out. Whoever comes last, he is going to be going first, right? So it's going to follow the specific stack manner over here. So I'm just going to create the specific horizontal box over here. So let's try to create one box. So I hope it is going to create one good box. Okay, it is not. So I'm going to create one shape, that is I'm going to create it one box over here. Okay, so this is going to follow this stack here. So this is going to be following this is going to be our stack. So let me understand how it is going to be there over there. Okay, so here first I'm going to tell first is going to get visited. I'm going to add it into the stack. Then again, after adding this stack, for the first we are having a 2 and 4 we are having. So I'll go to the next visited node, that is 2. So from 2 we'll go, we don't go to the 1 because we need to backtrack again, right? So here it is a backtracking. We can backtrack it here, right? This is what was backtracking. So I'll go to the 1, 2. So after 2 I'll be visiting 3. So from the 3 I'll be visiting after 1, 2, 3. So I can visit 8, 9, 10. So I'll visit here as a 4. So after visiting 4, right, I'll be visiting 5 here. Okay. So after 5 I'll be visiting the 7. After 7 I'll be visiting the specific after visiting 7, so this is, imagine this is your dead end, so it is going to be dead end over here. Okay, so in this dead end, after visiting 7, again I can backtrack it, right? I can come back 7 to 5, 5 to 4, 4 to 3. First I'll visit 8, 9, then I'll go back to the dead end. So I'll visit the 8, then I'll be visiting 9 over here, then again I'll just visit the element that is 6 over here. Okay, so this is also can be possible over there. This can be one of the possible way. So again, let's say another examples, like I can just visit first 1 I'll be visiting, then I'll be visiting 2, then I'll be visiting 3, then I'll be visiting 4, then I'll visit 5, then I'll visit 6, then I'll visit 7, then I'll simply backtrack and I'll visit 8 and I'll be visiting 9 over here. If these all things, all the dead ends, so these all things can be treated as a dead ends over there. Okay, this can be another scenario. So again I can write again, I will be visiting 1, I'll be visiting 2, visiting 3. So after 3 I'll be visiting 8, 9. So as it is, I'll visit 8 and 9 over there. Then I will visit the element 4, then I will visit 5, then I will visit 6, then I will visit 7. So again there are two possible. I can visit 1, 2, 3, 8, 4, 5, 6, 7, 9. This is also a correct. So again I'll be visiting 1, 4, 5. So I'm going this way. Okay, so I'm going this way. So I'll visit 1, 4, 5, then 6, then 7. Then I'll be backtracking. I'll be visiting 3. Then I'll be visiting 2. Then I'll be visiting, again I'll backtrack and I'll go to the 8, 9. So this is all going to come back to the BFS over here. So if I write the specific, this is all the specific BFS. That is the, here you can be go back and you can just visit all the nodes and go back to it. So this follows the stack banner over there. Okay, so I hope you have understood the BFS and DFS. In the next session, we are going to look onto the problem statement on the Java. Take care. Bye bye. Hey guys, let's understand the coding part of BFS and DFS using Java. So let's begin with the Java program for BFS and DFS problem statement. Coming back to my Eclipse over here, so I'm just going to first work on to the BFS part. So let's create one Java program for BFS. So I'm going to create a Java class. So the name I'm just going to tell it here as the graph, something like or I'll simply give it as a BFS. Okay, breadth first search. So I'm going to just click on to the finish over there. So I'm going to create import the Java packages. That is, I'm going to tell here as a import java.util.star. So I'm just going to create one more variables here, some kind of a vertices. So basically I'm just going to create a vertices. So how many vertices are there and how many edges are there, like that. So I'm going to tell here as a int of, that is vertices over there. So in the vertices I'm just going to create one something called as linked list. So let's create is the linked list also. So linked list, it is a kind of a list, right? So I'm going to create integer, the private integer. So it is going to be the adjacent list. So adjacent lists, I'm just going to store it into the linked list over there. So I can just tell here as a adj list list over there. Okay, so this is going to be your linked list private data type. So now I'm going to create one specific constructor to create the specific graph. So I'm going to tell here as a BFS is going to be your constructor, and I'm just going to pass the vertices value here. So inside these vertices, I'm just going to initialize the vertices is equals to the vertice, whatever the values are there, and the edge list, whatever the adjacent list will be there, right? That is going to be your new linked list. That is going to be new linked list. So in the linked list, I'm just going to pass it as a vertex v. Then I'm just going to run a loop for initialization purpose for the all the values. So I'm going to tell int of I is going to be 0. Then I should be lesser than the vertex, and increment the pre-increment the I value to it. So once it is done, here we are going to just initialize the values of the adjacent list or whatever the new linked list value will be there. So I'm going to tell here as adj list, right? Not adjacent list is of specific I, that is going to be the new linked list. So this is going to be the initialization of the constructor for us. Okay, so we have initialized the constructor over here. So now we need to write a method to add the edges to the graph, right? A method to add the specific edges for the graph over there. I'm going to write a void that is going to tell here as add edg edge. So here inside that I'm going to pass the vertex value as int v and int of w here. So we are going to add the what is the edges, what is the specific which is the having the edges basically. Okay, so I'm going to tell here as the adjacent list of the vertex v dot add the specific whatever the we are adding as a W. Okay, I'm going to add it as a W weight over there. Okay, so we are not actually adding the weight, we are just adding the specific edge, either it is existing or non-existing between the two vertices over there. Okay, so then we need to write a program for traveling the BFS. So I'm going to tell here as the another method, that is something I'll just tell here as a BFS specific. I can just tell BFS traversal is your method name. So that takes the which is from where you are going to travel. So yes is going to, we are going to pass from the S source. So I'm going to tell here as a boolean value. So first I'm just going to make down whether it is visited or not. To keep track of that, I'm just going to create one new boolean value, that is a vertices, that is equals to, I'm going to tell here as a new boolean of the vertices over here. I'm going to match the vertices over there. So once it is added, so I'm just going to create the linked list for the, basically it will use what? BFS is going to use the queues, right? So we are going to use the queues linked list over there. I'm just going to make use of the queues. I'm going to tell here the linked list is the integer value I need to pass. I'm going to mention here as a queue is going to be new linked list here. New linked link list over there. Okay, so this I'm just going to pass it over here. So we have created a new linked list. Then I'm just going to mention something like visited, like whichever the starting node we are passing, right? So first we need to make that node as a visited. So I'm going to tell visited of the specific source is make it as the true over there. So first we are just making that node as a true visited. So once we have visited the node, we are going to add it into the queue, right? So I'm going to tell queue dot add that specific node value inside the queue. That is what we did, right? So once we visited, just we are adding the data inside the queue over here. That is what we have done it inside the BFS. So once it is done, this is the method we have created. So then again we need to write the same method. So we are going to do it for other vertices as well, right? So for that other things, I'm just going to check one condition while loop. So while I'm just going to tell here as a queue size should not get full, right? So that I'm going to just tell if the queue dot size is size, then I'm going to tell the queue dot size value is not equals to 0. Okay, if it is size is not equals to 0, if we have a space, and that time we're just going to tell queue dot poll method over there. So what this poll is going to do? So in Java, you know, right, it basically retrieves and removes the header first, basically, right? That's what the co is that the specific thing is going to do. It returns the head of the list or null if the list is specifically empty. Okay, so this is we are going to keep track onto the S to keep track on the header part. Then I'm going to tell SYSO. So inside this, I'm going to tell whatever the node we are passing, I'm just going to tell pass that S value. Then I'm just going to give one space. Then I'm going to use the iterator for adding the whether that is having a next value or not. So for that, I'm just going to make use of the iterator. So iterator, okay, that is a Java class. That is, I'm going to pass the integer into it, the iterator I, that is going to be the adjacent list over here. So I'm going to tell it as a adjacent list of S dot list iterator. So I'm going to make use of the list iterator over there. Okay, so this is going to be the method. So after iterating the adjacent list value, I'm just going to run the while loop. I'm just going to check for that specific node if there is the having a next specific edge or not. For that, I'm going to run a loop if the value has next, if they're having an adjacent list. So what I'm going to do here is I'm just going to initialize that n value is equals to I dot next value. So I'm going to iterate the what is the vertex value, and so then I'm just going to check if that specific vertex is visited or not. So if it is not visited, I'm going to tell if not of visited, for whom, for that specific vertex, that is n, just make him visited. That's it. I'm going to make it as a just make that specific node as a visited and just make that node as a true over there. That's it. So after visiting node, then again I need to just tell so queue dot add that specific node inside your queues over here. That's all. So that is a very simple program, right? So here we are initializing it. Here we are creating one linked list constructor. Then we are just checking a boolean BFS, like whether creating a new vertices. Then we are creating a queue. We are adding the first source vertex into it. Then we are running a loop. Then we are iterating the next vertices, and for the next vertices, then we are going to check how many adjacent list we are having it for the adjacent data. If that adjacent data is existing and if it is not visited, we are going to make it to visited and add it inside the queue. That's very simple, right? So now what we are going to do here is we are going to create one specific example. Let's create a graph and add it into it. So I'm just going to create one graph here. That is, I'm going to create as a BFS is equals to That is, I'm going to create one new graph. So BFS graph is equals to create a new, that is BFS graph. So here I'm just going to pass the value as 4 over here. So I'm going to pass the 4 vertices, imagine it. Okay, so once I pass the 4 vertices, I'm just going to tell here as a G dot add the specific edges over here. I'm just going to add the edges. So from the 0 to 1 there is an edge. Okay, imagine there is an edge between 0 to 1, and from the G dot add the specific edge. Imagine from 0 to 2 we are having one specific edge. In the same way we are going to add few more over here. So I'm going to add 1, 2, 3, 4 and 5. Okay, so we have 0 to 1, 0 to 2. Imagine we are having specific from 1 to 2, and we have from 2 to 0 we are having the specific least edge, and we are having from edge, that is from 2 to 3 we are having the edge, and imagine we have a specific edge from, that is basically from 3 to 3 we are having an edge over here. So basically we are going to, so 0, 1, 2, 3 only we can use the values, right? So fancy we have added. So now I'm just going to tell the vertex. So let's imagine I'm just going to tell SYSO. I'm going to tell here I wanted to what is going to be the starting vertex. So I'm going to tell BFS traversal starting from vertex 2. Let's imagine we are starting the vertex from 2. I can start from any vertex, right? Basically. So after giving this, I'm just going to tell here as a for G dot, I'm just going to add the method that is a BFS traversal. So I'm going to pass the value that is 2 over here. Okay, I'm going to start from the 2. So once I start and execute the program, so if I execute, you can see the BFA traversal from the static vertex 2 means first it will visit the 2, then it will visit 0, then it will visit 3, then it will visit going to be 1 over there. Okay, this is going to be the BFS traversal. If I start from the vertex 0, what happens? If I start from the vertex 0, you can see the BFA traversal 0, 1, 2, 3. If I start from the vertex that is 3, what is going to the BFA traversal? It is going to be 3. Okay, it is not visiting the other nodes. Okay, so this is we cannot start from the vertex number 3. And if I just start from the vertex number 1, if I execute here, you can see if I start from the vertex number 1, 1, 2, 0, 3 is going to be the visited node. So for this specific graph, we can create the edges and add, like there is a connection from 1 to 2, 1 to 4, and 4 to 5, and 5 to 6, 5 to 7, and 3 to 8, 3 to 9, 2 to 3, and 4 to 3, 3 to 8, so 3 to 9. So if you can add these vertices and just have a look onto it, whether we are going to get the any BFS value which we have got it over there. So definitely we are going to get that. Okay, this is going to be a small assignment for you guys. So this is about the BFS. So now let's discuss about quickly onto the DFS part of it as well. So I'm going to create a new Java program for the DFS here. I'm going to create a public static void main and just finish it off over there. So here again I'm just going to not going to type, actually I'm going to paste the values, the code already I have written in. So we are going to use the java.util.package here. So once we have declared it, we are just going to declare a few of the variables, that is a vertices, that basically does what it tells the number of vertices in the graph, and we have created a same, that is adjacency list for the linked list as it is. And same thing we need to create the constructor as it is how we have created for the BFS. I'm going to tell you as a DFS is going to be your constructor, where we are initializing the vertices v value and the adjacent list over here, and mapping the specific adjacent lists over there. Then again we need to create the same method that adds the method to adds the edges to the graph. Okay, that is adds the edges to the graph. Then we are going to tell here as a DFS traversal is a method to check whether the specific vertex is visited or not. Then I'm just going to create one DFS util. So that method is going to do what? That is going to call the recursion method and backtracking, like basically checks the vertex. If it is visited, it is going to have the visited. If it is not visited, it will tell the things has been visited over there. So it is exactly similar to the BFS here. Okay, there is nothing much changes over there. We are just calling this method inside DFS util. But in BFS, we are not calling this here. So we can say we are adding the queue directly. Okay, in here we are just calling the recursive method to store the specific DFS over there. So now we are just going to create one graph for it, and let's call the method that is working or not. I'm going to tell you as we are just creating the specific DFS is the graph. We are just creating one node DFS. Then we are just creating the adding the edges 0 to 1 and DFS for starting from the vertex 2. If I just tell here as a traversal DFS traversal G.DFS traversal, Now if I execute pass the value vertex 2, if I execute it, so I'll be getting the DFS, dev first for the specific program. That is the dev first for the starting vertex 2 is 2013 over here, 2013 over there. Okay, this is going to be the vertex. If I just start from the vertex 1, if it is going to be what, it is going to be the 1203. You can see it is coming, we are getting a different values apart from the BFS over there. Okay, so this is the simple program for the BFS and DFS. Here it is going to make use of the stack data structure, so that is why we are using this one. Okay, so that's all for this session, guys. Take care. Bye bye.
Hey guys, welcome to section 10, the n queens problems over here. So let's understand the last concept in DSA which we are going to do into this course, that is the n queens problem over there. So let's begin with the example over there. So in this specific n queens, I'm just going to create one specific box over there. So here what happens here is whenever we are having, like suppose imagine, I'll tell you with one example. So imagine we are having one specific box over here. So we are having some specific things like this. Okay, so we are having some diagonal, that is a 4x4 matrix over here. So you are going to place the queens here. So whenever you are trying to place these specific queens, so such that the two queens should not be together like this. So it is the not a correct value. This is also going to be valid. This whenever you're going to draw like this straight line, or if you are going to draw this kind of a straight line, or if you are going to draw this horizontal straight line, the vertical diagonal like this, or if you are going to draw a diagonal like this, or if you are going to draw a diagonal like this, or if you are going to draw a diagonal like this, or if you are going to draw the diagonal like this, the queens should not meet. Queens should not meet over here. Okay, so in this you can see it is getting me, this is not satisfied. Even if it is there, it is getting me, this is not satisfied. Even imagine if the queen was here, this is meeting, this is also is not satisfied. Imagine the queen is getting here, queen is placed here, and if one more first queen is placed here, so this is not getting me, this is correct. Okay, again if the queen is here, so again if I just try to draw a straight line, so you can see it is not, it is again not meeting. But here if you place here already, if you are placing here, these queens are getting matched over here. So the queens should not get clashed. So just take this example. So whenever you are drawing a straight line, if you are drawing like this, if you are drawing like this, so basically the queens should not get each other, even if it is a row, or if it is a column, or if it is a diagonal over there. Okay, so this is the major agenda behind the n queens over there. The queens should not get meet over there. Okay, so let's try to draw one specific queens, and let's try to create one specific box over there. Then we are going to see how the things is going to be there. So this first I'm going to draw one specific box. So I'm just going to erase this thing. So let me select these entire stuffs and delete it off. So I'm going to draw one specific box over here. Okay, so that box is, I'm going to make use of the same box over here again and again. Okay, so this is not giving me the box. Okay, so let me draw again. So I'm going to draw a small box over here like this. So this specific box, so let me draw it. So from this specific scenario, from this specific, I'm just going to select it. Okay, so meanwhile I'm going to delete this box as well. So let me select the box from here. So a neat box, so this is going to be the box over here. So I'm going to make use of the same box again and again. Okay, so I'm going to draw the specific lines over here. So this is going to be one, and this is going to be the second diagonal. So why it is creating two boxes, I don't understand. Let me create it again. Let me select this. So I'm going to create one box here, and there will be another diagonal here, and again I'm just going to draw another diagonal over here. Okay, so I'm just going to select this. Basically I need to draw the 4x4 matrix over here, that's it. Okay, so in this specific box I'm going to give the shapes again. So I'm going to give the specific shapes 1, and this is going to be the second specific shape, and this is going to be the third specific shape over there. Okay, so this is all the specific queens we have just drawn it. So I'm going to little bit make it slightly. Okay, so here we have the specific box now. So now we are going to place the specific queens over there. So whenever I wanted to place the specific queens, so let me place it inside the specific boxes over there. Okay, so I wanted to little bit, I'm going to erase the box because I wanted to draw a lot of boxes in the bottom. So I'm just going to keep a small box over here. Okay, so this is going to be do our task over here. Okay, so this is the small box I have created over there. The same box I am going to repeat for a number of times over there. Okay, so first I'm just going to draw this box. So one, it is going to be there. So if I just create a tree
for a backtracking. So basically this is a backtracking problem, okay, because that is we are going to backtrack this. So you can see from this specific child we are going to create two specific node, and from here again we are going to create 1 and 2 and 3 and 4 over here. So this I'm just going to place it here. So this is from here, from this specific box we are going to get the 4 childs basically, okay. So that is what I'm just placing it here, and I'm going to place this specific box again here, okay. So from this specific child I'm going to get the 4 boxes. Again from this specific child, right, again I'll be getting 4 boxes. So again I'm going to get the 4 boxes from this specific child as well. So I'm going to, okay, it is not copied properly, so let me copy again, Control C, Control V. So I'm just going to tell from this specific child we are going to get the again 4 more boxes over there. So again we are going to create another 4 boxes we are going to get. So I'm going to just place that box as well. So I'm going to place again the same box. So here again I'll be getting 1 box, okay. So again we are going to get the another box. So we'll see from which specific diagonal we are going to get it. So right now I'm just creating one prototype so that literally I don't need to create again, okay. So here you can see it is creating like this. So I'm just going to place these boxes from here to here. So from the left I'll just take it, okay. So from where all my queens are there, okay. So here we are taking it here. So again from here that 4 boxes is done, right. So again there will be the 4 boxes is going to come into the picture here. So again this will be going to come into the picture. Again the another one is going to come into the picture. Again there is another 1 box, it is going to come into the picture over there, okay. So these are all the boxes we are going to get it. That's why I have drawn it. So now let's see how that is going to be there, okay. So I'm just going to little zoom out over here. Now this is going to be fine, okay. So now what I'm going to do here is I'm just going to scroll towards it's like, okay, let it start from here. So basically from this specific child, so I'm just going to create one black color thing. I'm just going to create the black color here. So now I'm just going to draw the queens over here. So okay, so for this is your queens. So in this queens I need to place the queens inside all the boxes. So these many iterations will get repeated basically. I just created the boxes right now. So from this specific box we are going to generate the 2 specific box over here. So from here 1 and we are going to get it here, okay. So in this specific thing, so first I'm just going to place the queen onto the top over here, okay. So first I'm just placing the queen onto the specific box into the first specific row, okay. And here I'm just going to place the queen onto the second row over here. This is the first iteration we are performing it, okay. So after performing the first iteration, so from this specific child we are going to get the 4 more operations over here. So in this I'm just going to apply the first operation. So in this we are going to get the 4 operations. So this is going to be 1, and this is going to be another case, and again this is going to be another thing. I'm going to erase this. I'm going to tell here this is going to be the second operation, and this is going to be the 4th operation over here, okay. So this is all the 4 possible ways we are going to get it from this tree. So already a queen is placed here, okay. So again if I just try to place the queen onto the first, so I'm going to take the second column basically, okay. In the second column I'm just going to place it here. So again I'm just going to, queen is already placed here. So again I'm just going to place onto the second in the second column, second row. So again I'm just going to, queen is already placed. Now I'm going to place the in the second column, third row I'm just going to place. Again the queen is already placed in the second column, 4th row I'm just going to place. So basically I have selected first row and the second column here. So let's verify which is correct or which is wrong. See here it is, the queens are getting clashed here. So these are getting clashed. So this is not going to select because it is giving you this straight line here. So if I just see the diagonally, yes, this box is getting collide with this specific box. Again this is also is not getting selected. So if I take this specific box, the Q and Q, so here you can see the diagonally if I go, it is not meeting it. And if I just go vertically, this is not getting meet, and this if I just go diagonally, it is not getting meet. So it is in the third row, so the diagonal will come to the second box like this, right? It is not meeting it. So this is correct. So if I just go to this box over here, so if I just go to this specific box, so now which is getting here, also you can see this is also the diagonally it is not getting meet up over here. This is also the diagonally it is not getting meet. So this 2 box I can just select it. I can just say this is the box selected, and even this box also can be selected over here. So what we are going to do, the first box which we are going to get selected, that we are going to take care into the further notice. So let's take this example, next one. So in this specific queen, so it is getting one box is getting here, and one is getting here, and this is also getting here at the end, and this is going to the this specific box. So in this place, the queen is placed at to the second here, right? So the queen is here. So after I am going to place the second here. Okay, this is the one thing. Again, I'm just going to tell queen will coming over here. Again, queen is here already, so I'm going to place into the third row. Queen is here. I'm just going to place at the fourth row over here. Okay, so this is how the things happens here. So in this case, let's see which all this getting collide. So you can say this is getting collide with this one. Okay, even this two is getting collide because it is coming in the horizontal way. So this is diagonally it is getting collide. So in this case, the only one it is getting selected, the fourth row over here, because this is not getting collide, right? So I'm going to mention here as a, so I'm just going to pass the queens here basically. Okay, so here it is getting collide. So this we can just select it, this we can just select. So this rest three we cannot select it, whichever I have highlighted into the yellow color boxes over there. So once I have selected this, so now I'm just going to tell, okay, from this I'm going to create these 4 more boxes over here. I'm just going to tell this is one going to come, and this is also is going to come, and this is also is going to come, and this is also is going to come over here. Okay, so these are the 4 specific possible ways which we are going to get it inside this specific box. Let me draw it neatly. So it is going to come here, and it is going to come over here. Okay, so now in this specific case, the queen is already placed where, so the queen is already placed. So whatever the wherever whichever we are selecting, that place we are going to fix it. The queen is already here, and the queen is already here, queen is already here, queen is already sitting here, queen is already here, here it is there, queen is here, and queen is here. Okay, now we are going to keep on adding to the next specific rows over here. So into the third iteration, in how we are going to do here is, so we are going to select the third row now. So I'm just going to select the third row. So this is I'm going to select here, then I'm going to select the third column basically. Okay, third column we are selecting. Again, second is done, then here I'm going to place it here, and I'm going to place it at the fourth column over here. So now let's see which is getting collide and which is not getting collide here. So you can see this specific thing is getting collide over here. You can see this specific box is getting collide. So you can see I'm just going to draw this line, so because you will be understanding, okay, this is meeting diagonally over here, this is getting thing. So here you can see this is getting collide. If I just tell here as this is getting collide like this. Okay, so you can see this box is getting collide as a diagonally, as a row wise here, right? Again, if I just take this second here, it is getting collide. If I just tell, you can see queen and second queen is not getting collide, but the queen 2 and the queen 3 is getting collide. You can see it is getting collide in this specific manner. You can see it is getting collide inside this specific manner. Okay, even this is also is not getting selected. So here also it is not getting selected. These 2 queens are getting collide in the row wise, right? So this queen is getting collide with the row wise, so it is also is not going to select. So now if I take it this example, the last example here, so you can see here also the queen is getting collide. So basically here it is getting collide, here it is getting collide, and here it is getting collide, right? This is not getting selected, so this is also is not selected. So here it is going to, for this specific queen, all the queens is not getting any, no queen is getting selected. So I'm going to select, I have selected this box, so you can see it is not getting selected for this specific things over there. Okay, so that is why things is getting happened over there. Now let's take an example for the second one over here. So this is not getting happened, right? So now let's take this one. So this is done. So it is not, even this is also is apparently it is not getting selected because of it is meeting horizontally, it is getting collides over there. Now let's take an example for this one here. So I'm going to select this here, it is there, 1 is 3. Again, I'm just going to tell this the second is going here. Again, I'm just going to tell here as this is the third one, and I'm just going to tell this is going to be your fourth one over there. Okay, so this is going to be the 3 specific possibilities for this specific rows over there. Okay, so here already the queen is selected here, the queen is sitting here. Okay, so the queen is here, the queen is sitting here, the queen is here, the queen is already here, the queen is here, and the queen is over here. Okay, again I'm just going to select the same thing, that is the third column here. So the first here it is going to sit, then here it is going to sit, then here it is going to sit, then at last over here it is going to sit over there. Okay, so now let's see from where whether this is also will get the diagonal or not. So you can see if I just take this example here, the diagonality it is just meeting it here, diagonally it is meeting, so it is not getting selected. So if I take this example, if I take the second example, you can see if I just go like this, it is not meeting. If I go like this, it is not meeting. For the queen it is not getting collide. So for the queen it is not getting collide. So if I just go here, it is also not getting collide. So basically I can say, okay, this queen is selected. So I can just tell this queen is being selected. So I'm just going to mention this queen is getting selected over there. Why? Because here it is not meeting any diagonally or horizontally or vertically over there. So then here, if I take here, you can see this queen is getting collide with each other over here. So if I take this example, this is getting collide with each other. Okay, so this is all not selected. The yellow color, whichever I have highlighted, those queens are not getting highlighted majorly here. So now we have gotten another queen. So we have a 2 here. So we have a selected queen here is a 1 and here 2. So we need to go with these 2 scenarios now. So now what I'm going to do here is I'm just going to place this box little bit towards it right. So this I'm going to take it over here. So or else I can do one thing. So from this specific box, okay, so I'm going to tell from this specific box I'm going to zoom out. If I zoom out, it is going to be a very smaller. So what I'm going to do, I'm just going to place it here. Okay, so now what I'm going to do here is I'm going to slide towards it a little bit like this, zoom it over here. So now we have selected this specific box, right? So for this also we need to create the possible ways over here. So I'm just going to tell here this is going to be the one specific scenario from this queen. Okay, from this specific queen. So I'm just going to tell Control Y. Okay, from this specific queen, I'm just going to select the boxes over here. So here I'm just going to select here. So for this I'm going to get this specific box over there, and from here we are getting this box over there. So from again we are getting this specific box. So from here again we are getting this specific box over here. Okay, so in this specific scenario, how the things is going to be there. So already queen is placed here. Already the queen is placed here. So I'm going to place wherever already the queen is placed. So I'm going to just maintain here like this. So after this, now let's try to see where we are going to place the queens over here. So even here we are going to select the third specific column over here. So in the third specific column, I'm just going to place here first, then I'm going to place here, then I'm going to place it here, then I'm just going to place it over here. So once I select this place, so let's see how the diagonal it is meeting or not. So here if I just see here it is going, if I go here it is not getting meet, if I go here it is not getting meet. So if I go horizontally or vertically it is not getting meet, even if I go diagonally it is not meeting, if I go here it is not meeting it here. Okay, so this has been selected. So here in the second box this is not getting selected, it is meeting it. In the third box it is diagonally it is getting meet, it is not getting selected. In the fourth box this is getting meet over here, so it is not getting selected. So I can say in this specific iteration this specific box has been selected over here. Okay, for this specific box has been selected over here. So now we have a 2 selected box. This is the box we are getting selected, and this box has been getting selected over there. Okay, so we are having the 2 specific box which has been selected majorly. Okay, so after selecting that, now I wanted to create the specific again scenario. So I'm going to create another things over here. So let me select the whole thing. So for this specific box I'm just going to draw one specific queen, and for the last box, so whatever we are having, so for that specific box I'm just going to create the another 4 boxes over there. Okay, so let's see how the things is going to come over here. So for this specific scenario, so I'm just going to zoom little less. Okay, so this is going to be fine. So for this specific scenario I'm just going to tell, so from this specific box I'm going to get the majorly I'm going to get the 3 specific scenario, 3 box I'm going to get it. So okay, not this one, right? Sorry, so we need to select for this one which has been selected. So I'm just going to tell we are getting here, and here we are getting another box over here, and from here we are going to get it here, and we are going to get it these specific things over here. So from this specific selected box we are going to get again 4 boxes. So basically we are going to select the last to 4th column here. Okay, so 3 columns is filled. So now we are going to look onto the 4th column over here. So here I'm going to tell here as it is how the queens are there. So the queen is placed here, and the queen is placed here, and the queen is placed here. So queen is placed here, queen is placed here, and the queen is placed here. So here which is already selected we need to place as it is. Okay, wherever it is there. So it is done. So now I'm just going to select the last column now. So in the last column I'm just going to tell queen will come here, queen will come here, and queen is going to sit here, and the queen is going to sit over here. Okay, so here we are going to see where the diagonals are getting meet. So here you can see the diagonals are getting meet over here, right? So yeah, so if I just tell here this the diagonals are getting meet, so you can see this queen and this queen is getting clashed. So this is not possible. So here the diagonals are getting this specific row is getting meet, so this is not getting satisfied. So here also the queen is getting collide because it is coming out like diagonally it is meeting, it is not satisfied. Okay, so if I take here in this example here also it is meeting or not. So if I take the last row of this one, so here whether it is meeting or not. So if I just go, it is not meeting. If I just go here, it is not meeting. So if I just go here also, it is not meeting. So here basically it is selected or not. Yes, this is selected, right? So even if I can place the queens in this manner as well, I guess, right? Because see, if I just go diagonally, it is not colliding it. If I go here like this, in this oh, this is colliding, guys. So this is colliding, my bad. So you can see this box is getting collide. You can see this box is getting collide. If it is diagonally, it is two queens are getting collide. So this is not getting satisfied. Okay, so in this case, this is not getting rejected over here. So now let's take this example over here. So the queen is already placed here, and the queen is already placed here, and the queen is already placed here. So again, I'm just going to place as it is, how this is things are there. So I'm just going to tell second is selected, second here it is selected, here it is already selected. Sorry. So again, I'm just going to mention here queen is selected here, the queen is selected here, the queen is selected over here. So now I'm going to select the fourth column again. So I'm going to tell queen will place here, queen will be placing here, queen is going to place here, and queen is going to get placed over here. So now let's see which all it is colliding or not. So here if I just tell, you can see this is already first all it is getting collide, it is not satisfied. So here you can see these two diagonals are getting collide, so this is not getting satisfied. So if I take this example, so if I just go horizontally, it is not getting collide. If I go vertically, it is not getting collide. If I go diagonally, it is not getting collide. Even if I go diagonally for this side, it is not getting collide because it is in the third, it is in the second, this is in the first, not getting collide. So this is selected. So again, if I just go here, whether this is selected or not. So if I just go here, it is getting collide here. So overall saying here is, we can just say this specific box has been selected over here. So I'm just going to tell this specific box. Okay, this specific box has been selected over here at the last over here. Okay, so this is basically your n queens problem, guys. So in this specific problem, so you can see I have zoomed out over here. So in this specific problem, we understood one thing, that the queens are not getting collide in this specific case over here. In all the other cases, the queens was getting collide, we saw one by one. So this is the one specific, you can say. If I tell here as we are getting as it in the row is 2 here. Okay, then in the second row we are getting fourth column is selected, and the third row first column is getting selected. In the last row the third column is selected, that is in the column wise. If I tell in the row wise, the 3 is selected. In the row wise I am saying 1 and 4 and 2. So this is on to the row wise over there. So this is all about the n queens problem, guys. So this is how the specific things happen. So there is a 8 queen as well. So if I take 8 queen, it is going to be very big. So we have taken the 4 example, 4 queens, and this is how we are going to play. This is going to be the 4 queens problem, n queens problems into the DB. So that is basically here the row should not get collide, the column should not get collide, and the interdiagonal way the thing should not get collide. In such a way, we need to place the settings of that. Okay. So this is how the things happens over there. So in the next session, we are going to look onto the Java program for the n queens. Take care. Bye bye. Hey guys, welcome back to the last session of this DSA course. So that is the n queens problems coding part. We are going to look onto it. So let's begin with the coding part as well. So in the previous session, we discussed like how the n queens problems is going to place. So we saw this is what we are going to get for the 4 queens. If you are placing in order, that is 2 4 1 3 or 3 1 4 2, we are going to get it, right? So we saw how the working procedure is here. I'm not going to drag on that. So let's begin with the coding part of it. I'm just going to create the new Java class for n queens. So I'm just going to mention it as a n queens over here as the public static void main. I'm just going to click onto the finish this program over there. So into the n queens, let's try to create one functions, and let's begin with the coding part of it. So first we are going to check the queen can be placed on board or not. So I'm just going to create one specific one function, that is a private static, that is going to be the boolean value. So it decides, this function decide whether the queen is safe to place or not. Okay, so I'm going to keep the function name as is safe. So here it is going to majorly take the multi-diagonal matrix, right? So I'm just going to tell to arrays, and I'm going to tell board comma, they are going to pass the row, and we are just going to pass the int of column, and I'm just going to pass which queen we are just placing it. So int of n over there. Okay, so this is n is going to be placing the row over here. Okay, it's going to be taken. So in this scenario, I'm just going to check if the queen can be placed onto the left side or not. Okay, check the specific row on the left side first. Okay, for that I'm just going to tell for int I is equals to 0 and I should be lesser than column. Okay, call value and I plus plus. So in this, it is going to loop for the left hand side. So I'm going to tell if board, I'm just going to tell if board board. So it means I can place the queen on board. Okay, so I'm going to tell if board of, I'm just going to pass the row and row of I over here. If it is equals to 1 over here, if it is equals to 1, if it is all the queens can be placed onto the left side or not. Okay, I'm just going to return the specific false over here. It means I cannot place it over here because it is already selected. Okay, this is going to check for the left side first. The same way I'm just going to check for the upper diagonal on the left side. Okay, and then the lower diagonal on the left side. So this is this three scenarios I'm going to take. Now I'm just going to check for the upper diagonal on the left side. For that I'm just going to tell for loop. So I'm going to tell int of I is going to be row value and j is going to be taken as the column value, and I'm just going to tell I should be lesser than n value, and along with that whatever the j value is there, right, that should be greater than or equals to 0. Okay, then I plus plus comma j minus minus, I'm just going to do it over there. Okay, so I'm going to go into j value and j value and I value increment, j value decrement. So here I'm going to check again if the specific board, here I'm just going to check for the I comma j over here if it is on board or not. So I'm going to check the I comma j. Basically the problem will remain same here. We are going to check diagonally, horizontally over here. To check the horizontally, diagonally, this is the major logic which we are going to write it. Okay, this is how the things is there in the program. So if I just tell here as a if I board of I j is equals to 1, if this condition is there, so I'm just going to tell you don't need to place it. So if these two conditions are satisfied, so the thing is the queen is not safe to place it over there, or the horizontally or a vertically or diagonally. So if the two conditions are getting false, you can just return true. So you can just return true. Basically I can just tell okay, you can place the specific queen over there. Okay, that is queen is placed to safe to place it over here. Okay, this is the one thing. So now I'm going to create a recursive method. This backtracking is majorly on the recursive method that solves the n queens problem. So I'm just going to create a new method that is a private static boolean. We're going to tell here as a solve the specific n queen here. So we are going to solve the n queen util here. Okay, so I can just give it here. So it is going to be the multi-diagonal matrix, and it is going to be a board here. I'm going to pass two values, that is a int and a column, and the L or n value, what is the queen I wanted to place into the column wise. Okay, so first what we did, we placed the queens onto the row. Now we are going to place onto the column wise over there, how we placed it over the while seeing the example. So in this problem I'm just going to check first if the all queens are placed, we need to return true. Okay, so I'm just going to tell for checking that, I'm just going to tell if the column value is greater than or equals to n value, means all the queens has been placed. Okay, at that case I'm just going to tell return the true value. So I'm going to tell it as a return true. Okay, this is going to be happen. So if this conditions is not satisfied, now I'm going to try placing the queens in all the rows one by one. We are going to place the queens now in all the row one by one over here. So now I'm just going to write a loop for it. I'm going to tell start int I value is going to be 0, I value should be lesser than the n value, and I plus plus over here. Okay, so in this case now I'm going to check again. I'm just going to use the above method, is safe method. So whether is queen is safe to place, so I'm going to place the board here. I'm going to pass the I value, column value, and the n value. See, it is so smart, it has taken the same values here. Okay, so if it is condition is getting satisfied, if it is safe to place it, so I'm just going to here it is a return or etu or it. So here what I'm going to, if the queen is safe to board, I'm just going to tell board board, so of I, and I'm just going to pass the column value over here. So I'm going to tell okay, the queen is safe to place over here, so I'm just going to place it over here. So this is going to be like this. Again I'm just going to tell if this is there, so again I'm just going to place for all the queens. So I'm going to call the method that is a recursive method. So solve n queens problem util method. I'm going to pass board. So first one queen is getting placed, for the next time it is going to be column plus 1 over here. Okay, so this is the one thing. So if it is done, again I'm just going to return the true value. If all the things is done, keep on calls the method. If it is done, all the method is going to be done. So here it is going to get the true value over here. So here I wanted to check one condition. If the placing on queen is does not lead to a solution, then we need to backtrack, right? So what we did here, so backtracking is something, see here we are we got selected here, then after selecting this we got 4 solutions here, right? So here it is not at all selected, not even one is getting selected. And what we did, we didn't stop here, we backtrack the thing, right? That is why the backtracking is the name given to the n queens problem. So backtracking is something we are going to follow some kind of a way. So if the way is not getting, then if we stuck it over there and again we cannot go to the further way, again we take back it, again we are going to see the next route over there. Okay, imagine you're going to some place and where you're you lost the way, right? Again what you are going to do, you're going to reverse your car and again you are going to see the another way, right? So the same thing here is also the backtracking. That is what the backtracking is here. Okay, so if the for that thing, again what I'm going to do, if this is getting fine, or else what we need to do, we need to back, if imagine it is getting stopped somewhere, it is getting stopped. So what I'm going to do, so board off, again I'm going to tell I comma 0th vertex, go to the back, go one step specific back, that is okay. Here I need to do I of column, okay, that make it as a 0 over there. Okay, so we are just backtracking. So the entire this line is we are telling about the backtracking on it. Okay, so this is going to be the backtrack your problem over there. Okay, this got your thinking going to there. So if all the things happens, so I'm going to tell return false at the last, only this condition satisfied, then only need to return true, or else I'm going to return the specific false over there. Okay, so now we are going to write one function again, that is a solve n queens problem. Okay, this is going to be the backtrack your problem, solve n queens utils. Okay, so let's try to write another one more functions that majorly completes the program. So this basically function is to solve the n queens problem here. So above problem we are checking the diagonally way, we are checking if it is safe or not, and here we are just placing all the values. Now here we are going to check, okay, the entire thing. I'm going to tell you as a public static, okay, it is also a boolean. So I'm going to tell you as a solve n queens over here. I'm going to just give this specific name, so I have not used this name. Okay, I'm going to use solve n queens over there. So it is going to take the n queens values over here, check the n values. So I'm just going to onboard the queens here, that is board board is equals to new int of, I'm going to initialize the row and columns to the n cross n matrix. So I'm going to tell n cross n over there. Okay, this is going to create the n cross n matrix. Now we are going to initialize it. I'm going to tell here as a for int I is going to be 0, I value should be lesser than n, and I plus plus. Okay, so once it is done, so I'm going to tell again for loop, I'm just going to tell int of int j is equals to 0 and j is lesser than n value and j plus plus over here. So once it is done, so I'm just going to onboard it. So I'm going to tell board, that is I comma j2 starting initially with 0 over there. Okay, initially with the zeros over there. So now we are going to start the n queens problem over here. So after this, I'm just going to tell that if the specific not of solving, so basically I'm going to call the util function. Okay, if not of solve n queens util over here, I need to pass solve n queens util. So n queens util, where is it? Oh, it is not util, right? Okay, so I'm going to tell not of solve n queen util. So I'm going to pass the onboard value to it, and I'm just going to pass the start with the 0 comma and n over here, 0 comma n over there. Okay, so I'm going to pass these values to this specific thing. Okay, if I pass, it is going to basically, it is going to return you true, or it is going to return you false after calculating whether it is safe to place or not. If it is returning you the false, it will be true. If it is returning you true, it will be false, right? Opposite of it. So if it is condition is satisfied, I'm going to tell solution is not exist. So basically it is a backtracking problem. So it is solution not exist. So I'm just taking, if it is returning you false, basically if it is returns you true, right? If this condition, if it returns true, basically it is return not of it, right? Not of means the not of true will be not of false will be true. If it is true, it will be giving you this specific thing. And after that, I'm just going to return the FALSE false of it. Okay, return the specific false. So if it is not, then we need to print the specific solution now. So I need to create the one function to print this thing. So if it is not getting satisfied, I'm just going to tell here as a print the SULUTION solution is a function I'm going to call. So where I'm going to pass the board value and I'm going to pass the n value. So this after that, I'm just going to return the true over there. So I'm going to create a function for printing. So I'm going to tell here as a private static void, and I'm just going to tell here as a print SOLUTION solution. So here I'm just going to take the matrix values, that is int 1 of 1. I'm just going to take the board value, then I'm just going to iterate the int of n value over here. Okay, so once I just pass this, now I'm just going to run the loop and I'm just going to pass I'm going to print it over there. So here I'm going to tell it as a for loop. So for int value is I is going to be 0 over here, then I should be lesser than n value and I plus plus. So this is going to be the outer for loop. So let's write the inner for loop to print it. So int of j, so I'm going to tell int j is going to be 0 and j should be lesser than n value and j plus plus over there. Okay, so once I get this, now I'm just going to print it so system.out.println. So I'm just going to tell print the BOA or the board of I and j over here. So plus I'm just going to give the specific spacings over here like this. Okay, so after that I'm just going to print one so outside an empty one. Okay, so to get the values, just going to print it over there. Now I'm just going to write, I'm going to pass the queens over here. So I'm going to pass for the 4 queens first. Okay, n value is going to give the 4 value. So then I'm just going to call the method that is a solve the n queens. So I'm going to pass the n value to it. So once I pass this n value queens, so if I execute the program, so I'll be getting an output. Let's see what is an output we are going to get. So here you can see I'm getting all 0 0 0 0 0 0 0 0 0 and 0 0 0. So there is something, a mistake happens. So while typing happens. So here we are getting all 0 0. The 4 things we are getting 0 0 0 0 0 0 and 0 0 0. Okay. So imagine if I just try to give this specific value here as 8 here. If I just try to give the input as 8, if I execute. So what happens here? So all the values I'm getting as a 0. Okay, it is giving you the problem output correctly, but the values are not correct. So here I need to debug something if I have done wrong. So let me debug what has the things has been wrong here. Okay, so here I can see here I have just checked for the 2 things only here. We have not checked for all the things. So we have checked for the one thing, that is this we have checked for the diagonal on the left side, and we have checked the specific upper diagonal itself, right? So we have checked only 2 things over there. So that is why the things is not coming properly. So let me write that one more function. So here it is checking, this is I column I. So here there is another thing I need to write in. So what I'll do here is I'm just going to copy this for loop, and again I'm just going to paste one more time. Okay, so this is the another time I need to paste it. So here this is the I is equals to row, j is column, and I value should be lesser than n, and ij is greater than or equals to 0, I plus plus, and j minus minus. So here I need to check another condition. So just let me rename, I need to just replace the loop over here. Okay, so I'm going to tell here as a int of, so this is basically checking for the upper diagonal on the left side. So this is for the upper diagonal on the lower side and the diagonal on the left side, but it's the upper diagonal on the left side here. Okay, this is going to be lower diagonal, this is going to be the upper diagonal code. Okay, that's what you need to keep it in your mind. So I'm going to tell int of I is equals to row, and it is going to be j is equals to so let me tell I is equals to row, and j should be equals to the column value, and I value should be greater than or equals to 0 over there. And along with that I'm just going to increment the and along with that j value also should be equals to 0, and this is going to be I minus minus and j minus minus, I minus minus comma j minus minus over here. Okay, so this is the things I have done it here. So int I is equals to row, comma j is equals to column, and I value should be greater than or equals to 0, and j value should be like this. Okay, so this is the things we have done it over here. And if it is done, again I'm going to tell if I of returns the false over here. So let me write it properly. So here it is giving me the error. What is the error here? It is giving index error token invalid it over here. Okay, so here I need to put the comma, not the semicolon. Okay, and yeah, this is done. So now if I try to execute the program now, let's see what is the output we are going to get. So still we are getting 0 0 0 0 0 0 and 0 0 and 0 0 1. So still we are not getting a proper output here, right? So let's see again what is the issue over here. So yeah guys, so there was an issue with the print statement. So I printed, so even I have added the comment for all the things. So you can see for your understanding I've added the every comment for the functions. So what is going what, and all the things were there. So issue was with the print solution. So I wanted to print like this here, so I put it outside. So now let's try to execute the program this. So once I execute the program, now I will be getting a proper output. You can see the queens are getting selected. So the third diagonal is getting selected, 3 1 4 2, right? So that is what we are getting. That is, you can see 3 1 4 2. If I just go in the row wise, you can see the same output I'm getting, 3 1 4 2, whatever we have done. So you can see if I just come back here, if you go diagonally it is not matching, if you go vertically it is not matching, if you go horizontally also it is not getting matched. So this is how the thing is going to happen. Even if you try to give the n queens to, if I just change the value to 8, if I wanted to see what is the value for 8 queens, if you want to place the 8 queens into the diagonal, so it will be 8 cross 8 matrix. If I execute this, you can see after all the iterations, you can see the same program is working for the 8 queens as well. You can see it is giving you this output. So when you go horizontally or you go vertically, the diagonals are not going to get matched over there. Okay, so this is all about the n queens problem, guys. The code I'll be giving you, the entire code is written here, so we'll be into some folders. Take care, bye bye.